So analysis of algorithm is a very important topic before you dive deep into data structures and algorithms. Alright, so let me first tell you like why it is so important, why it is needed. So there are like many problems which have a number of solutions. And as a software engineer, your task is to find the algorithm which will solve the problem in the least time, which will be more efficient. Alright, so to find out, to compare between algorithms, we use analysis of algorithms. Alright, so in computer science, we use asymptotic analysis. So what asymptotic analysis does, it measures order of growth of time taken by a functional program in terms of input size. Okay, for example, suppose input size is n. So it will tell how the program grows, whether it grows quadratically, linearly, constant, etc. Alright. Okay, let me give you an example. So here we have a question, find sum of first and natural numbers. Suppose we have given this question to two software engineers, alright. So one software engineer came with this solution and one software engineer came with this solution. So let's see here what he did. He declared a variable sum and then he put the value of sum as n into n plus 1 by 2. This is a standard formula for finding sum of first and natural numbers and I hope you must be knowing about it. And this is another program written by another developer, and here what he did, he declared sum, alright, and then he used a loop which ran from I is equal to 1 till n, and he added the value of iterators 1 plus 2 plus 3 and so on. Okay, and then he also returned the sum. So now let's talk about time this program takes. So what this program does is it adds two numbers, multiplies two numbers and divide two numbers. So operations such as divide, subtract, add, multiply, they takes constant time. Alright, nothing else, just constant time. So here, what would be the time taken then? Constant. So I'm saying C1. C1 is a constant. Alright, any constant. And let's come to here, program 2. Now looking at this loop, sum is equal to simplify. This statement takes constant time. Suppose it's taking constant time of C2, alright. And it is run for n number of times. So it is like C2 plus C2 plus C2 C2, alright. And this is, n times, right? So it would be what? NC2. Alright. So time taken here would be what? NC2. And then there will be some other things in this program which would be taking constant time, such as declaration of variables. For example, declaration of variable of sum, declaration of variable I. So we can say they are taking C3. Alright. So this is what we do here. Now in asymptotic analysis, you will come across asymptotic notations, which includes big O of n, theta of n, and I'm sure you must have heard these somewhere. So we'll study them under this asymptotic analysis. Okay, but before studying them, let's talk about order of growth. We'll talk about order of growth in more detail. Alright, let's talk about order of growth in more detail. So, as a software engineer, what is your main task? You've been given a problem and there would be multiple solutions of the same problem. Now what you have to do is to find the most efficient solution which takes the least time. So what you will do is you will find time taken by all the algorithms. Alright. And then you'll write a polynomial in terms of time. And then we see order of growth of every time taken. You know, and one having least order of growth, that algorithm becomes efficient. Okay, and now you might be wondering what is least order of growth, what might be the higher order growth. So basically you might be wondering how to compare order of growth between two two polynomials. All right, so let me tell you how we can do it. Suppose there is a function of time fn. All right, and there is a function gn. So a function fn is said to be growing faster than gn if gn upon fn is equal to 0 when n tends to infinity. Alright, so it means that gn has a higher order of growth and gn having lower order of growth. Alright, let's take an example, you will understand better. So here, see, fn is equal to n square plus n plus 6 and gn is equal to 2n plus 5. Alright, so what we'll do is we will put gn here, gn we have put here, 2n plus 5, right? And fn is here, and we have to put limit n tends to infinity. And I'm hoping you guys know how to put limits. This is basic maths. So what we'll do, we'll divide numerator and denominator both by n square. All right. So this becomes 2 by n. This becomes 5 plus n, 5 by n square. 1 plus 1 by n plus 6 by n square. Now as we put n is equal to infinity, these terms become 0. So this becomes 0, this becomes 0, this becomes 0, and this becomes 0. So final result becomes 0. Hence you can say this gn function has lower order of growth and this fn function has higher order of growth. But when comparing many order of growth, you will not do every time you'll not do limits. So there has to be a simpler direct way to find order of growth. Alright. So yeah, there is one. So we'll talk about it. Alright. So we'll talk about now direct ways to find and compare growths. Alright. So it involves two steps. First, we have to ignore lower order terms, and then we have to ignore the leading terms constant. Okay. So yeah, leading terms constant. Alright. Let's talk with an example. See, fn here is 2n square plus n plus 6. Right? Now what we have written here, ignore lower order terms. So what are the lower order terms? N plus 6. So we'll ignore this, ignore this. Now this is the leading term, and what we have written, ignore leading terms constant. So 2 has to be ignored. Now what we are left with, n square. Hence order of growth of this function becomes n square. Now let's talk about another function, gn. Alright. Here also what we have written, ignore lower order terms. So we'll ignore this term, we'll ignore this term 3, and then we'll ignore leading terms constant, which is 100. So what remains n. So order of growth of gn becomes n. Now we have got order of growth of two functions. Alright. Now how do we compare them? So we have a small hierarchy which is very easy and you can learn it very easily. So it involves like this. So the least order growth is with constant. Alright. Constant grows with the least order. Alright. Basically constant doesn't grow. Obviously, right? But still we have put it in the hierarchy table because we have to compare it with other terms. Then after that log of n, it grows very minutely. And then there is log n, which grows faster than log n, and this continues. This is n 1 by 3 and a cube root of n. This is square root of n 1 by 2. This is n. This is n square, n cube, n raised to power 4, 2n, and this goes on. Right? Then n power 5, n power 6, and so on. So let's come back to our example. Alright, we have Fn, we have order of growth n square, and Gn, we have order of growth n. Alright, now what? C, where is n square? Here, right? N square is here, and where is Gn? Order of growth of Gn is n, so n is here. So as you can see, n is smaller than n square in this hierarchy table. So we can say that Gn's order of growth is less than Fn's order of growth. So suppose there is a function, there is an question which have two algorithms. One whose time polynomial is Fn, and another algorithm whose polynomial is Gn. All right. So order of growth of Fn is n square and order of growth of Gn is n. So we'll say that the second algorithm of Gn would be more efficient because its order of growth is less than that of Fn. So this is how we compare different algorithms. Alright. So I'll end the lecture here, and in the next video we'll learn about asymptotic notations, which will include big O of n, theta of n, and then we'll cover like what can be the best and worst time complexities. Alright. So see you next. Hello everyone. So today we are going to learn about best, average, and worst case, and then we'll talk about asymptotic notations. Alright, so let's start with the video. So first of all, let's talk about best, average, and worst case. Alright. So first of all, let's take this example. This is the same example which we took in our previous video. So it is, in this we have to find sum of first and natural numbers, and for this we used a loop which runs from 1 till n, and when we add all the iterators and return the sum. Alright. So as we told before, what would be the time taken here? It will be C1 n plus C2. Alright. Now C1 n because we are operating this expression n times, and C2 for declaring declarations such as sum is equal to 0, I is equal to 1, etc. etc. Alright. And then what will be the order of growth? To find order of growth, what we'll do, we'll ignore all the lower order terms, so C2 gets ignored. Then we'll ignore the leading coefficient of leading term, which is what, C1. So we'll ignore C1. We are left with n. So order of growth here becomes n. Alright. Now let's take another example. So in this, we are doing the same thing. We have to find sum of n natural numbers. Alright. But if n is an even number, like we have a condition here, if n%2 is equal to 0, which means if n is an even number, then we don't have to find sum, then we just have to return 0. Alright. So in such cases, we cannot make a general statement regarding order of growth. Alright, because see, if n is even, then we'll just simply return 0. So order of growth would be what? Constant. But if n is an odd number, then we have to go through this loop, and then the order of growth would be n linear time. All right. So in such cases, what we do, we divide all the cases into three cases, into three parts. So one is best case, average case, and worst case. All right. So let's first talk about best case. So best case is the scenario where we have the least order of growth meaning which takes the least time. So in this example, if n is an even number, suppose it is 4, 6 or 8, then we'll check if n is even, which it is, then we'll return 0. So this will take what? Constant time. Hence the best case here would be a constant, right? Now let's talk about the worst case. Worst case would be in the scenario which has the highest order of growth, which takes the most time. So in here, suppose n is odd, like 3, 5, 7, 9 or something. So we have to go through this loop. It will take, linear time. All right. So hence the worst case is a linear time. All right. Now let's talk about average case. All right. So in average case, we, assume the frequency of all the cases, and then we divide the total number of and divide the result by the total number of outcomes. Okay, so let me tell you what I mean through this example only. Suppose I am assuming that even and odd number both are equally likely. All right. Hence, suppose in best case, because there are only two cases, only it can be even. The number can either be even or it can be odd. So in the best case, it is even. So what will be the time then? C1. Then we'll go what if n is an odd, it would be the worst case, which would be what? C2 n plus C3. Then what did I tell you? We'll divide it by the total number of outcomes. There are only two outcomes, even or odd, so we'll divide it. All right. So what would it result to? Right, that is a question. So suppose C1 plus C3 by 2, we take it as another constant C4, and we take C2 by 2 as another constant C5. C5, right? Hence, what would be the order of growth? And hence linear. So this is how we compute best case, average case, and worst case. So you learned about all these things. But now let's talk about which would be better in practical use. Alright, first let's talk about worst case. First let's talk about average case. Okay, so direct, if I tell you, we cannot use average case at all. Alright, the simple reason is we have to make assumptions on our own. And different programmers may assume different distributions, and it may lead to like different average cases for different people. All right, suppose I took occurrences of even and odd as equally likely, but suppose some another programmer takes it like 90% frequency would be of even and 10% frequency would be of odd, then his average case would be different than mine. So average case is not efficient for different programmers. All right. Now, let's talk about best case. So again, simple direct answer, we cannot use best case also. Okay, let me give you an example. Suppose you made a software, all right, and you want to sell it to some company, and you tell them that the best case for this is 0.01 millisecond or something, all right. But then you tell them that this is the best case, and I don't know like what would be the worst case. It can be even hours, it can be days, anything. So by common sense, you can say that you would be pretty sure that no one will buy your company, buy your software. All right. So that is it. So the only case which we are left is worst case. All right. So this is what we use most of the time because it tells us the max time our program is going to take to execute. And this would tell us the exact efficiency of our program. Okay. So this was all about the best, average and worst case. Now let's go to asymptotic notations. All right. So as we talked previously, asymptotic notations are used to define asymptotic analysis. All right. So let me tell you about what are asymptotic notations. So asymptotic notations are mathematical notations which represent the growth of any mathematical function. All right. There are three famous notations which we'll talk here, which is big O, which tells us about the exact or upper bound on order of growth. Then there's theta, which tells us the exact order of growth. And then there is omega, which tells us exact or lower bound on order of growth. All right. So you'll understand better if I tell you through an example. Suppose this is an example. It is a program to find target element in an array. All right. It is a basic linear search program where we take arguments as in an array, size of it, and the number which we have to find. So what we'll do, we'll run a loop for I0 till I less than n, and if we find the target element in the array, we'll return the index where we found it. Or if we did not find it, we'll just simply return -1. All right. So this is like the case when which we saw in best, average, and worst case. So this is like quite somewhat example like that. Suppose if my x here is 10, all right, then what would be my order of growth? Constant. Was it the first term? I'll just go into the loop, I'll find and I'll return. So it is constant term. But what if my x is somewhat 75? Then I'll iterate through whole of the loop. I'll come out of it and then I'll return -1. So what work did I do here? Linear work. All right, I run through the loop n times. So I did a linear work. So here also there are two cases: best case, worst case, or average case. Okay, average case can be like any intermediate number, 30, 40, or something. All right, so you can guess it. All right. Let me talk about best and worst case here. All right. So best case is linear. Best case is constant time, and the worst case is linear time. All right. So then there would be like multiple lines. Key my best case is constant, and then my worst case is linear time. But instead of this, I can simply write that the time complexity of this operation, it is big O of n, right? Now might be wondering why. See here, big O is what? It is exact or upper bound on order of growth. So the time complexity here can be what? It can be either linear or it can be either constant. So big O of something like big O of order of growth, which is n here, which is linear, it tells us that either the time complexity of this function is linear or less than that. So what is less than a linear? It can be constant. Hence big O tells us that big O of order of growth tells us that it is either exactly equal to that or it is less than that. Now let's ON here. Cool. I hope you understand that. And now let's talk about theta. So theta is represented like this. Suppose I wrote theta n. So this means that it is an exact order of growth. All right. So for this search operation, you cannot write theta of n, because it means that this program will take linear time. But what if the target element is 10? Then we will have only constant time. Hence, we cannot use theta n here because it tells us the exact time. All right. Now let's talk about omega. What you can write here is omega of 1. Okay, 1 here means constant time. Right. So omega is, exactly opposite of big O. So omega of any order of growth means it is either equal to that or it is higher than that. Means it can be either a linear time, it can be either a constant time, or it can be higher than that. That means either linear, quadratic, or anything. So for this function, we can write omega of 1. So this means that it can be either of constant time or it can be greater than that, which can be like linear or anything. Now you must have guessed that we cannot use omega function mostly, because you know what, it tells us the best scenario and it does not take account of worst case. All right, as I told you in the average in the previous section, that if you made a software and you tell the best case but you don't know about the worst case, then you cannot use it. So that is what omega does. So what we use basically here is only big O and theta, which I told you about. To make things more clear, let me tell you about this. Yeah, let's take this example. We have used this many times. It is the same one where we have to find the sum of first and natural numbers. All right. So can you like pause the video and guess the time complexity of this one? All right. So it is can be either theta. All right, my bad. Yeah, it can be either theta of n or big O of n. All right. I must be wondering if you have got it very well, but let me still tell you like why. See this loop. No matter what, this loop will run n number of time because there's no condition inside it that it has to stop or anything. Like it was there in the upper example. So this loop will run for n number of times. Hence, we can find the exact time complexity of it, which is theta n. I must be wondering why I said big O of n. So let's go up and see why. Because see, big O tells us exact or upper bound. Big O tells us the exact or upper bound. So we can say like big O of n also here. All right. Yeah. See, many a times we only have to tell either theta or O, big O. Are you getting my point? See, in many times you've been asked question like what would be the time complexity of this, and you cannot tell both of them. So the one which you'll tell should be the most efficient one. Okay, so big O of n is what? Key it is either of linear time or less than that, which means constant. But you can clearly see here that no matter what, it will take n loops to run it. Hence, the time complexity would be, the time taken would be linear. Hence, theta n would, work here. I'm not saying big O of n is wrong, but sometimes the question comes like, we have to tell either one, only one. Either it can be theta of n or big O of n. In such cases, we'll use theta of n. Alright. So I hope you get the asymptotic notations. Among these, big O and theta are the important ones. Omega is not used as much and you'll rarely see it in your future. So concentrate on big O and theta. And I'll end this video today. And in the next video, we'll take some examples and we'll see the time complexities of the programs, and then you will understand more about when it would be a big O or when it would be theta. And there would be examples when we'll take omega, so don't worry about that. All right. So on this note, I'll end this lecture. Hello everyone. So in today's lecture, we are going to look at some of the common loops which are used frequently in the programs, and we'll try to find their time complexities. All right. And later we are going to look at some functions which contains multiple loops, and we'll try to find their time complexities as well. All right. So let's get started. So here's our first example. We have a loop where we have an iterator I, which initially is 0, and this loop is doing some constant work. So order of growth of this work would be theta of 1. All right. And after every pass, we are incrementing I with the variable C. All right. And this loop will run until I becomes more than N. Okay. Now, if we do a dry run of this code, then what would be the values of I for this case if n is 2 and c is if n is 10 and c is 2. So initially I is 0. We'll enter in the loop, we'll do some constant work, and after that we will increase our I. I will now become 2, and similarly I'll become 4, then 6, then 8. After 8 we'll enter in this loop, we'll do some work, then we'll increase I with a plus 2, it will become 10, and then this condition won't be satisfied and we'll come out of this loop. So how many times this loop have run? It would have been run for 1, 2, 3, 4, 5 times, right? Now let's look at this example when n is 20 and c is 6. So what would be the values of I? Initially I is 0, so we'll enter in the loop, we'll do some constant work, and then we'll increase I by 6. So I would become 6. Similarly, it would become 12, then 18. So when it becomes 18, it will enter in this loop, it will do some constant work, and then we'll increment I with 6 and it will become 24, right? And then this condition would be violated, then we'll come out of this loop again. So how many times this loop have run? 1, 2, 3, 4, 4 times, right? All right. So pause this video for 2 minutes and think how many times this loop would run in terms of n and c. All right. So by mere observation, you can say that this loop would run for n by c ceiling. This loop would run for ceiling of n by c. All right. Now, if you are wondering what is the ceiling function, so suppose n by c is an integer, is a fraction number. All right, so 4 point or 5 point something. So what this ceiling function does, it returns the value of integer which is just greater than n by c. All right. So we can use this example. What would be the value of n by 6 here? 3 point something, right? Hence, the ceiling of 3 point something would return the integer just greater than that, which is 4, right? And if n by c is an integer itself, then the ceiling function won't do anything. All right. for in this case. Here n by c is what? 5. Hence the loop would run for 5 times. Alright. Now if we talk about what would be the time complexity, then ceiling of n by c means that plus minus some number, right? So that would be a constant. So if we find the order of growth, that constant will be ignored. This c constant term will also get ignored. So order of growth would be n. Hence time complexity would be theta of n, right? That's how we calculate time complexity and order of growth, right? Now let's look at this example. Alright, so what we are doing here, we have made a loop. We have initialized our iterator as 1. We are doing some constant work inside this loop, theta 1, right? Then after every pass, we are increasing I by multiplying it with C, which is a constant. And this loop will run until I becomes more than N. Alright. Now if we want to have a dry run, we can use this example. N is equal to 33 and C is equal to 2. So initially I would be 1, right? So we'll enter in this loop, we'll do some constant work, and then we'll increase I by multiplying it with C. C is here 2. So I will now become 2. Similarly, after second pass, it will become 4, then 8, then it will become 16, right? Then 32. Then when it becomes 32, we'll enter inside this loop, we'll do some constant work. Then we'll increase I to I into C, which is 32 into 2, 64. Then we'll check this condition, I less than n, which is not satisfied, hence we'll come out of this loop. Alright. Now, how will you find that how many times this loop runs, or what would be the order of growth? Alright. Now, if you do 3 or 4 examples by yourself and try to find a pattern. If you're successful in finding the pattern, you will see that this loop is running for log n base c. This is the number of times this loop is running. Now, if you're not able to find this, that how this term is coming, we'll prove it mathematically. Alright. Now, if you have to, suppose we have to write I in terms of our constant c. So initially I is 1. So we can write I as c raised to power 0, right? Then I becomes 2. Then we can write I as c raised to power 1. Then I becomes 4, which is 2 raised to power 2, meaning c raised to power 4. Alright, and this is how this goes till suppose any variable k, which is, suppose this loop, run for what? K times, right? Now if we find the order of growth of k in terms of n, right? If we found the order of growth of k in terms of n, that would be the time complexity of this loop. Alright. So how to do that? So we can see that this is going to be the last term of our this series, or c raised to power 0, c raised to power 1, c raised to power 2 till c raised to power k minus 1. Alright. So what we'll do is that we'll use this condition, which is I less than n. That means c raised to power k minus 1 less than what? N. Right. Now what we'll do here is we'll take log on both of the sides of base c. So log here would become, k minus 1 log base c raised to power n, right? And then k final expression, 1 minute, yeah, log cn plus 1, right? Now if we find the order of growth of k, what we have to do? We'll ignore this one. This is a lower order term, right? Also, when we have to find asymptotic notation, we'll also ignore the base term. So we'll ignore C also. So order of growth of K would then be what? Log of N only. Alright, because we have to ignore the base term also. Hence the time complexity here is going to be theta of log N. Alright. Now let's go to our third example. So here also there is our loop where we have declared our iterator initially as 2. We are doing some constant work of theta 1, right? And what we are doing is we have to run this loop until I becomes more than n. And how are we changing I? After every pass, we are swapping I with I raised to some power, some constant power. Here, constant is, in this example, here constant is 3. All right. Now let's look at this, like how will the dry run look like? All right. So IS2 first of all. Okay, as you can see, IS2 first of all. We'll go inside the loop. We'll do some constant work. All right. Then what will happen? We'll, change I to I raised to power C. IS2 raised to power C. C is what? 3, which becomes 8. Yes. Now what will happen? We'll go inside this loop. We'll do some constant work. Then we'll again change I, which is now is 8, to 8 raised to C. C here is 3. So it will become 8 raised to 3, which is 5, 1, 2. Alright. Now we'll again, check this condition. If I is less than n, 500, whether 512 is less than 510, which it is not. Hence we'll come out of this loop and this loop will terminate. Alright. Now if you have to find the order of growth or time complexity here, we can use mathematics like we did in previous example to find it. All right. So for that, what we have to do, we have to write I in terms of C. So initially, what is I first of all? 2, right? After that, I becomes 2 raised to power C, 2 raised to power 3 is equal to 8, right? After that, I becomes 2 raised to power C, which is 8 raised to power C, 8 raised to power 3, right? So this goes on and on, like 2 raised to power C, raised to power C, raised to power C. All right. Now if we have to write it more in a compact way, you can say this is 2 raised to power C raised to power 0. All right. Okay, 1 minute. Yeah. 2 raised to power c raised to power 0. Yeah, this one is looking nice. So c raised to power 0 is what? 1, and 2 raised to power is 1. So this and this term are same. Another term we can write as 2 raised to power c raised to power 1. C raised to power 1 is c, and 2 raised to power c is 2 raised to power c. These two terms are similar. Similarly, next term we can write as 2 raised to power c raised to power 2. See, c into c becomes c square, which is similar to this one, c square, 2 raised to power c square. Another term becomes what? 2 raised to power c raised to power 3. These terms are similar. Another thing will come here, right? C into c into c, c cube. And suppose this loop runs still for k number of times. Right? This loop is running for what? K times. Right? Now if we find the order of growth k in terms of n, we say that would be the overall order of growth of this loop. Right? So we'll see this last number and we'll use this condition for it. So what will happen here is that it will become 2 to power c raised to power k minus 1 less than n, right? Now what we'll do here, we'll take log of base 2 on both the sides. This becomes c raised to power k minus 1 log base 2 n. Then we'll again take log of base c both the sides, then it becomes k log c log yes. After taking the log, I shifted one from left hand side to right hand side here. All right. Now what we have to do, we have to ignore this lower order term 1, and this would be the time order of growth of k. Here we'll ignore the basis, as I told you earlier, in asymptotic analysis we ignore the basis. Hence the overall time complexity would become what? Theta of log n, right? And the time complexity of our third example becomes theta of log of n. All right. So I hope that you are able to now able to find the time complexity of these common loops on your own, because these are going to be very helpful for your future programs, because these are very common loops. All right. Now let's talk about multiple loops. All right. So in this, we are going to study about multiple loops. So suppose this is our first example. We have a function void func which takes n as input. All right. Now what's happening here is that we have a loop, we have another loop, we have another loop. So these are subsequent loops. So by subsequent I mean that first this loop is running, it is doing all its work, then it is terminating. After which this loop is going to run,
it is going to do all of its work, and then this is going to terminate. Then this loop will work, it will do it all of its work, and then it will terminate. All right. So in such loops, what we do is that we add the order of growth of all the loops. Suppose here the loop is what? I is 0, I less than n, I plus plus. I plus plus means I is equal to I plus 1. So we have seen the growth of this loop, which is what? N, right? Now here is this loop, I is equal to 1, I less than n, I plus plus, I into I is equal to I into 2. We know the order of growth of this one. We have studied it just now. Log of n is equal to second example. I is equal to I into c, which is some constant. Here the constant is 2, right? And if we see this loop, so as you can see, this loop is not dependent on n, which is our input. Hence, this loop is going to be of constant order of growth. So for constant, I have written 1, or you can write c or anything, all right, but I have written 1. Because see, whether n is 100, n is 1000, n is 10,000, this loop is every time going to run for 99 times, right? So this is going to be our final order of growth of this loop, which is n plus log n plus 1. Now, if we have to find the time complexity, what we'll do? We'll ignore the lower order terms. 1 will get ignored, log n will get ignored, only n will remain. Hence, time complexity becomes theta of n. Easy? Yes. Now let's look at this example. Here also, like, this is inside a function void func as we declared above, and we have passed input as n. So this is here we you can see there is nested loop. By nested loop I mean a loop inside another loop. See, this is the first loop where we have declared a variable I, which is 0, which is initially 0, and it will run till I become more than n, and after every pass we are incrementing it by 1. All right. Now inside this loop we have another loop. All right. Here we have another iterator for this loop j, which is initially 1. We are running it until j becomes more than n, and after every pass what we are doing, we are increasing j by a constant, by multiplying it by a constant, which here is 2. All right. So what would be the time taken by this loop n? Yes. What would be the time taken by this loop? Log of n? Yes. Now in case of nested loop, what we do is that we multiply the time taken by first loop into time taken by another loop. Hence it would be this. All right. And you can see it logically also. We are doing some constant work inside this loop. So this loop will do some constant work for log n times, and this loop is going to run for this number of time n times. So it is going to be log n plus log n plus log n till n. Hence it would be n log n, right? Hence the time complexity here would be theta of n log n, right? So I hope this is also clear to you. Analysis of multiple loops and how to find time complexity in subsequent loops or in nested loops. And please try to understand it thoroughly, because this is going to help you a lot in future upcoming programs when you have to find the time complexity of different algorithms. All right. So on this note, I'll end the lecture today.
Hello everyone. So today we are going to learn about space complexity. So space complexity is order of growth of memory size or RAM space amount taken in terms of input size. So as you can see, it is very similar to time complexity, which is, as we know, order of growth of time taken in terms of input size. But here, instead of time taken, it's memory taken or RAM amount taken. Alright, now let's see few examples to understand better about space complexity. Alright, so let's see this function first. So in this function, we are returning the sum of first and natural numbers, and here we are using the direct formula. Alright, and I get, and I'm assuming you must be knowing about this formula. Alright, okay. So can you tell me the number of variables here? The number of variable is only one, n, right? And we can see that space complexity is order of growth in terms of input size. All right. So suppose if n is 100, then the number of variables would be still one, right? And suppose n is 1000, the number of variables would still be one. So number of variables is not depending on input size. So we can say that space taken by this function is constant. So we can write space complexity as theta 1, right? Okay, let me tell you that as long as number of variables are constant, okay, meaning it's not array or list of variables, then the space complexity would remain constant. Hence, you can see that space complexity here is theta of 1 or constant space taken. Alright, now let's come to this example, this function. So what this function is doing, it is also computing sum of first and natural numbers. But here we are adding numbers one by one in this function, alright, as you can see in this function, as this loop, alright. Now count the number of variables here first, alright. It is, n first variable, sum second variable, and I third variable. Now if I ask if we change n, suppose let's take n 3, then the number of variables would be 3. If n is suppose 100, the number of variables would still be 3 and some I. If n is 10,000, then the number of variables would still be 3. So we can see that number of variables is not depending on input size. So we can say that the size taken by this function is constant. So you can say space complexity of this function is theta 1 or constant space. Alright, as I told you before that if the number of variables are constant, irrespective of changing our input size, the space complexity would be constant. Alright, now let's come to this example. Alright, this is a very important example. So here what we are doing, we are having a function which takes parameters as an array and its size, array size. Alright, and then we find the sum of all the elements of array through this loop and then we return the sum. Alright, simple function. Now tell me the number of variables here. So one variable n, one variable sum, and one variable I. Alright, three variables and one more important thing, number of elements present in this container, which is our array container. Right, this will also contain elements, so this will also contain variables which will have elements of this container. All right, now suppose n is 100, then how many variables would be there? One variable, second variable, third variable, plus 100 more variables, the elements of our array. Right, if n is 1000, then elements would be what? 1 2 3 plus 1000 elements, because n is input size of array. So array would contain 1000 elements. So we can see that number of elements here is directly proportional to input size, which is our n. So we can say that space complexity here is theta of n, right? So this is how we calculate space complexity. I hope this gets clear to you. Alright. Now let's talk about one more important term called auxiliary space. Auxiliary space is order of growth of extra space or temporary space in terms of input size. Alright. By extra space I mean the space created in memory other than input or output. Alright. So let's see this example. So here this is the same function as we saw before. It is having parameter as array and size of it, and we are computing the sum of all the elements of array and returning the sum. Alright. So we did see that space complexity here is what? Theta of n. Alright. Now if I ask you what would be the auxiliary space here. So what did we say about auxiliary space? That it is extra space created which is not related to input or output. Alright. So as you can see in this function, it only takes this array as input, and no extra array is used for computation. The only auxiliary space here is the declaration or space taken by these variables, sum and I. Alright. And if we change the size or if we change the input size, which I mean n, then still the number of variables would remain constant. Hence, auxiliary space would still be constant, which is theta of 1, right? So I hope this is clear to you that what is auxiliary space, right? Now, if I ask you like if we have to compare two functions to find the efficiency, then what would be the deciding criteria? So, a direct answer, it would be auxiliary space. Alright. Now, you might be wondering why. Alright. Now, let me tell you about it. Suppose if you talk about array problems, list problems, or any problems which use input containers, then they're going to use theta n space for input, right? For passing array into their parameter, like in this function, right? So space complexity would be theta n. So if I use an extra array here of suppose a, right, of size n, okay, so the time complexity array, the space complexity would still remain, theta n, right? Okay, let me tell you, what would be the space taken by this one? It would something be c1n, right? What would be the space taken by this one if there was this function? C2n. And then there are some variables which would take time something C3. So it would be the total space taken. C1n plus C2n plus C3. Right, so we can club C1 and C2 and we can say something C4. So it would be C4n, right, plus C3. Yes, and if we find the order of growth, what would it be? We'll ignore the lower order terms and we'll ignore the coefficient of leading term. So it would be n, right? So this is what I was talking about. If we at this, we'll still have the space complexity of theta of n. But what would change here? This auxiliary space, right? Auxiliary space would change here. It will then become theta of n, right? So this is what I was talking about. We are, more concerned about auxiliary space or extra space taken by the function. All right. Okay, let me tell you about something about sorting algorithms, which will come later in this series. Suppose if you talk about sorting algorithms such as bubble sort, quick sort, insertion sort, etc. What they do, they don't take any extra array to sort. Alright, so their auxiliary space would be theta of 1, right? But there are some sorting algorithms such as merge sort, which requires an extra array to compute the sorting. Alright, so its auxiliary space becomes theta of n. Now in all these sorting algorithms, we have to pass input array into the functions, right? Whether it be bubble sort, quick sort, or merge sort. So in every case, the space complexity would be theta of n. Alright. So what would be the deciding criteria? What would be the deciding criteria then? It would clearly be auxiliary space, because in sorting algorithms such as bubble sort, quick sort, we have space complexity as theta n. But we have auxiliary space as theta of 1. And in sorting algorithms such as merge sort, we have space complexity as theta of n. But we also have auxiliary space as theta n. So we have to find the efficiency. Since the space complexity is same, we'll go to auxiliary space. So this is how we compare the efficiency of programs in terms of size they take. Alright. So this was all about the space complexity and auxiliary space. And this is the last video of asymptotic analysis. And from the next video, we'll start a new topic. And I'll end this lecture today. So before jumping to some topics, I would want you guys to be familiarized with two mathematic, operations. Okay. One is divide. Let's look something like this straight line. Divide, right? And one is percent sign, like this. All right. So let me tell you about these through the examples. All right. Okay. Suppose we have a number here, x, which is 4123, right? Can you remember the last digit of step x? It is what? Going to be 3, right? And if I ask like what would be the value of x if I remove this 3 from here? It would be what? 412, right? Now, can you tell me in programming or when we are writing a program, how will you find the last digit? So many of you guys still be knowing, but let me still tell you. What we'll do is we'll this is our x, which is variable here. We'll percent it with 10. Alright. So what this percent sign does, it returns the remainder when x is divided by any number here. Suppose here is 10. So we'll return 3 here, right? Because if we divide 412 by 10, right? 4123, sorry. Yes. So it would be, 4120, and the remainder would be 3. And this x% n would return 3. Alright. Now another thing I want to ask you guys is, how will you find a number after removing last digit? Suppose x41 is 4123 here, and I want answer to be 412. Then how would you do in programming? So what you'll do is, you'll return x divided by 10. Alright. So this is a simple division which we do. Alright. Since x is our integer, so x divided by 10, if we store it in a variable, integer variable, x would be what, 412.3. But since we are storing it, or you know outputting it in in integer form, hence the answer would be 412 or 412.3. So answer would be 412, right? And we'll discard the point form, and hence the last digit would be discarded, and we'll get the number 412. Alright. So these are the two functions which I wanted to tell you. These are very important one. Alright. Now let's jump to some questions, or I would say, yeah, basically the topics, not questions exactly. Alright. Maybe this would come handy in future programming questions. Okay. Suppose we have to find number of digits in any number. Alright, suppose here our input is 433. What would be our output? It is going to be 3, right? 1, 2, 3. Suppose the number is 3, 2, 3, 4. The number of digits here is 4, and the output would be what? 4. Right. Now pause this video and try to come up with a solution to find the number of digits. Alright. So here's a very basic and very easy solution. This is going to be an iterative solution. Alright. So what we are going to do is, we have number n, which is what? 433. Right. Now we'll run a loop, and we'll going to divide n by 10 continuously until n becomes 0. Alright, when this happens, we'll come out of the loop, and we'll have a variable count which will store the number of times the loop would run, and that would be our answer. Alright, so let me tell you by doing a dry run. So initially our n is what? 433. Suppose our variable which will have a count is going to be 0. Alright, now in the first one what we'll do is, we'll divide 433 by 10. So now our n would be what? 43. Yes. C will become what? 1. Alright, cool. Then we'll divide n again by 10. Now it would be what? 4. C will become 2. Yes. Now what will happen? We'll divide 4 by 10 again. Now the now n would be 0, and C would become 3. And as soon as n becomes 0, we'll come out of our loop. Alright. So this is the basic idea of this solution, to find the number of digits in any given number. Alright. Now let's try to code this solution. Okay. So first of all, let's include our header file. Then namespace std. Let's make a main function where we'll have n and we have a user defined n. Alright, and then we are going to see out count digits n. Alright, now let's make a function of by name count digits. Let's pass n as its parameter. Alright, now let's have our count variable here. It is going to be initially 0. Right, now we'll make a loop that states that where as long as n is more than 0, this loop is going to be run. Now what we are going to do is, what did I tell you? We'll divide n continuously, and every time we are going to increment count, and count would be the number of digits. Then we will return count, right? See here, C is our count. Yeah, C when the loop ends, C is 3, and if we see the output is also 3, hence it is the correct solution. The C is going to be the number of digits, right? So this is going to be our function. Let's save it and try to run it. Let's take the example 433 only. Alright, 433. See, we are returning 3, right? Okay. Now next time let's take 3234 here. 3234. Number of digits are 4, hence the program is running. Alright, so this was a very easy solution, right? Sorry. Now let's come to palindrome check. Alright, suppose our input somewhere is 3434, then our output is gonna be false, and if input is something as 12121, 12121, our output is gonna be true. Alright, yes. Now you might be wondering what is palindrome check. So let's understand what is a palindrome. So palindrome means if I read a number from left to right and if I read a number from right to left, then answer would be same. Alright, for example, let's see here. If we read from left to right, it is going to be 3434, right? And if I'm going to read it from right to left, it is going to be 4343. So 3434 and 4343 are not equal. Hence the output would be false. Alright. And suppose at any point, now let's go to another example here. The example is 12121. Alright, if I read it from left to right, it is going to be 12121. Alright. And if I'm going to read it from right to left, it is going to be 12121. Hence 12121 and 12121 are equal. Hence output is going to be true. Right. Now again, pause for 2 minutes and think for the solution here. Alright. So let's jump to solution. Now what you have to do is, what you can do here is, you can have a variable rev, right, where you'll store the reverse of the number. Alright, in this case, you'll store the reverse of the number as 4, 3, 4, 3, right? Here, reverse would be what? 1, 2, 1, 2, 1, right? And then you compare reverse with the original number. Alright, with the original number. And if reverse is equal to original number, we'll return true. Like in this case, original number is this and reverse number is this. Both are same. So we'll, return true. And here, yes, here. The reverse number is not equal to the original number, hence we'll return false. Alright. Now, the main question arises is how you'll find the reverse of a number. Alright. So here the percent sign which we studied earlier in this video will come in handy. Alright, what we'll do here is that we'll use a loop here, and what we'll do is we'll find the units digit, the last digit. Alright, okay, let's have a dry run so you'll understand it. What I'm trying to say is the number is what? 3434, right? So what I'm trying to say is find the unit digit of it. It's going to be what? 4, yes. And then divide the 4. Okay, if you have to read it from here to here, you need to find all the digits from right to left one by one. So our first digit comes out to be 4. Now if I have to find next right to left digit, what I have to do? I have to eliminate this one. So what you'll do? You'll divide this number by 10. Hence this number would come. Yes. Okay. Now here what you'll do is you'll find this digit, the units digit here, which is going to be what? 3. And now what you'll do is to find this digit you'll eliminate this one, right? You'll eliminate this one. So your new number becomes what? 34. Right? Now here unit digit is going to be what? 3. Sorry. 4. This one. Now if I have to find the next right to left digit, I have to eliminate this one. Right? Now it will come out to be 3. Now to find this digit, what I'll do again is, the percent 10. I have this digit and now I'll again, divide it by 10, so answer would be 0. So as soon as we hit 0, we'll come out of the loop. Okay. As soon as we reach 0, we'll come out of the loop. So 4, 3, 4, 3. This is going to be, this way we are going to have a reverse number. But what we have to do is, if I directly add, these numbers, so these will result in what? 4 plus 3, 7, 7 plus 4, 11, 11 plus 3, 14, right? So what I'll do is that every time when I add this number to this reverse variable, I'll multiply the reverse variable by 10. Alright, so here it would be 4 into 10, 40, right? And then when I add 3 here, it is going to be what? 43. Now here I'll again multiply it with 10. It is going to be what? 430. Then I'll add this number. It will become 434. Then again I'll multiply this with 10 and then add this, and it becomes 4, 3, 4, 3, right? So this is going to be the main idea of how to do this question. First, for the basic idea is to find the reverse of this number. And how to find the reverse of this number, I told you about it, alright. Now let's try to code this program. Okay. So we'll add a header file here, first of all, and then namespace std, right? We have a main variable, main function. We have variable n. We'll take it from user. And if let's name our function as spal. Alright, spal n cout true, else cout false. Alright, now let's have our spal function. We'll have it as a boolean function. Alright, I'm hoping you might be knowing what is a boolean function. So what boolean function does is either returns true or false. So by this condition, if spal n, this means that if this function returns true, then we'll see out true, and else we'll see out false. Okay. So now let's have a reverse initializer to 0, where we'll store the reverse number. We have a temporary variable on which we'll operate of doing that divide operation, because see, if we do it on n, then how we'll compare it with reverse number, because then n will become 0 after the while loop. Hence we'll have a temporary variable which will have the same value as n, and we'll do the operations on it. Alright, so we declared the temp variable which is equal to n. Now what we are going to do is find temp more than 0. Let's have let's have it unit digit. Unit digit as 10%, 10, right? Now what did I tell you what we'll store in ref? We'll have ref percent 10 plus unit digit. Alright, and then we'll have 10 plus 10 by 10. Alright, and then what we'll gonna return is return temp is equal to reverse is equal to n. So what this line is going to return is that we'll check whether ref is equal to n. If this is true, then we'll return true, and else we'll return false. Alright, so this is the final program here. Let's try and run it. Let's have the same example which is, let's check for 3434 first. Let's put value as this. Alright. The answer is false. Okay. Now let's run it again and have another example, which is 12121, and let's try to run it. Oh my bad. Yeah, 12121. Okay. True. Alright, so hence this is a palindrome number. Alright. So I hope you got the understanding of percent and divide operations, which is which comes in very handy in programs, and then some basic functions like counting of digits and palindrome check and how to reverse a number. These were the key takeaways from this lecture.
Hello everyone. So today we are going to continue our basic mathematics series where we are going to look at some important basic mathematic formulas and tricks which will help us in our future programs. Alright. So today we are going to learn about factorial of a number. Right. So before jumping to coding, let's talk about what is a factorial. So if I say factorial of n, it is represented by this n with an exclamation mark. So this is equal to n, alright, into n minus 1 all the way to 1. Alright, hence n factorial means multiplication of numbers from n till 1. Alright, like n into n minus 1 into n minus 2 till 1. Alright. For more understanding, let us see these examples. So suppose our input is 4. So what would be the factorial of 4? 4 into 3 into 2 into 1, which is going to be what? 4 into 3, 12 into 2, 24 into 1, 24. Alright. Hence our output is 24. Now suppose if our input is 6. So it is going to be what? 6 into 5 into 4 into 3 into 2 into 1. So what this value is going to be? 6 into 5, 30, 30 into 4, 120, 120 into 3, 360 into 2, 720. Alright, hence output is going to be 720. Now, how are we going to code this? So it is very easy coding part where you'll use, a loop where you'll have an integer where you'll multiply n, and in every pass you are going to decrease n, and this loop will run until n becomes equals to 1. Alright, so this is what the coding part would be. So let's try it. First, let's include header file, then using name space std. Let's have a main function. Let's have n, which will be a user provided number, and what we are going to do is we are going to use a function called fact. So what this fact is going to do is it's going to have input as a parameter, and it is going to return the value of the factorial of that number n. So for that, let's have a variable which will store the factorial value, and now let's have a loop which is going to be I, which is initially going to be equal to 2, and we'll run this loop till I becomes equal to n, and we'll increase it at every increment. All right, and now res is going to be what? Res into I, right? So what res would look like? 1 into 2 into 3 into 4 until I becomes n. So this loop will run till I becomes n. All right, and then we'll just simply return our value of res. So let's try and run this program. Okay, let's take the example values. Let's have input as 4, its output is 24. The factorial of 4 is 24 as we saw it before. All right, now let's have 6, 720. Hence the code is working. All right, so I hope this was clear to you what is factorial and how to find it through programming. Now let's talk about trailing zeros in a program. All right, now let's have input as 6. Okay, what is output? 720. All right, and if we have input as 10, then what would be the output? What would be the factorial of 10? So it is going to be 3, 6, 2, 8, 8, 0. All right. So if I ask you what would be the number, what is the number of trailing zeros? Trailing zeros means right to left consecutive zeros. Suppose here it is 1, and if our input is 10, the number of trailing zeros are what? 2. All right. Now our task is to find the number of trailing zeros and write a function about it. All right. Now you may pause the video for 2 minutes and think about the solution, brainstorm for a while, and then come back to this video for the solution. All right. Now what is the factorial of a number? It looks like this. If I ask about factorial of n, this would look like this: 1 into 2 into 3 into until n. All right. Now if I ask you like how many zeros would be there in this list, so I'll simply say that if we find the number of 2's and 5's as a pair in a number, they will result into number of trailing zeros. Yes, because 2 into 5 becomes 10, and any number multiplied by 10 results
in a trailing zero. Suppose if a number is 72 and if we multiply it by 10, number is going to be what? 720, right? Suppose your input is 6. So what would be the factorial? 1 into 2 into 3 into 4 into 5 into 6, right? How many number of 5s and 2s are here? 1 5 and 1 2. There would be like 2s here also. Yes, 2 into 2. And 2s here also. 2 into 3. But if you have to find the number of pairs of 2 and 5, so it is going to be 1 because there is only 1 5. Alright. So this is clear to you. And there's also one more interesting fact here, that in a factorial, number of 2's would always be greater than number of 5's. You can clearly see that even in the factorial of 6, small number, we have only 1 5 and the number of 2's are 1, 2, 3, 4. So at any point, the number of 2's are going to be more than or equal to number of 5's. So hence the task is reduced to find the number of 5's in this whole trail of numbers. Alright. Now you can see that after every 5 turns, we are getting a 5. Like here is a 5. Then somewhere here we will be having 10. So there is a 5. Then at some point we are going to have 15 where we'll find a 5. So we can say that in a factorial, number of 5's are going to be what? N by 5. Okay, these are going to be minimum number of, at least there would be these number of 5's at least. So now I might be wondering why I'm saying at least. See, there is one more number, 25, which is going to have how many number of 5's? 2, right? But since we are dividing n by 5, we'll only get 1. And there's also going to be a number 125 here somewhere. So how many 5's are going to be here? 3, but we are only counting 1. So effectively I can say that number of factorials are going to be n by 5 plus n by 25 plus n by 125, and this list goes on, right? So now you might be wondering that how can we stop this this infinite trail, right? So if n is less than 5 per k, we'll stop after k minus 1 passes. Suppose our n here is 27, right? So we'll find this one, n by 5, n by 25, and then but we don't have to compute this because this is going to be 0, right? And the future values are also going to be 0. Suppose n is 127. So we'll find n by 5, we'll find n by 25, we'll find n by 125, but we won't find the other numbers, right? Because there's no point because it is going to be 0, right? So this is how you're going to find the factorial, trailing zeros in a factorial. Alright, now let's try to code this thing. Okay, let's have a header file here first of all. Let's have, using namespace std, let's have our main function.
let's have n as user defined number, and then we'll see out trail of n. So we'll have a function of trail which is going to have input as a parameter, and what we are going to do is we are going to have a variable int res which is going to be equal to 0. Now we'll run a loop. We'll initialize iterator as 5. We'll run it until I is less than or equal to n. And now what we'll do is we are going to initialize I as I into 5, because we saw that n by 5 plus n by 25. Hence we have to increase I by a multiple of 5 every time. Now what we are going to do is we are simply gonna add n by I to res. Alright. Now if I go back to Blackboard, what did I tell you? Res is going to be what? Res n by I. So initially res is what? 0. Hence what I can say here is that this thing in the loop represents this, because initially I is 5, then it will become I by 25, then it will become I will become 125, and so on. And as soon as I becomes more than n, then it will break, right? So this was it, and now what we'll do is we'll simply return res, right? Now let's not wait a minute. Yes. Now let's try to run this function. So we had 6 as a example input. Let's have it. Number of trailing zeros are 1, right? See, number of trailing zeros are 1. Now let's have another example input 10. Number of trailing zeros are 2. Yes, you can say number of trailing zeros are 2, right? So yeah, these are the two programs which I wanted to tell you in this lecture, and I hope you got what is factorial, how to find it, and how to find trailing zeros in a factorial. So yeah, that's it for this lecture.
Hello everyone. So today we are going to see a new topic, greatest common divisor of two numbers. Alright, so let's brush up about it. So greatest common divisor means the greatest number which divides both of these numbers. Alright, so let's take few examples. Suppose there are two numbers 4 and 6, right? So what would be the greatest number which would divide both of them? It is going to be 2, right? Now let's have another example, 100 and 200. So there would be many common divisors such as 2, 5, 10, etc. Right? But what would be the greatest number? It is going to be 100, right? 100 is going to divide 100 obviously, and 200 also, right? And there would be no number greater than 100 which would divide both of them. Okay. Now let's talk about this example 7 and 13. So as you can see that both of these are prime numbers and there would be no greatest common divisor. So only one would exist which would divide both of them. Hence answer is going to be 1. Alright. Now the question arises, how do we compute this through programming? So let's talk about algorithm which we use. So the algorithm which we use here is Euclidean algorithm. Alright. So the basic idea of this algorithm is, suppose we have two numbers A and B, and B is smaller than A. Then we can say that GCD GCD is short form of greatest common divisor, right? So GCD of A and B is going to be equal to GCD of A minus B and B. Now you might be wondering how. So we have the proof here. So the proof is, suppose G be the GCD of A and B, right? So we can write A as Gx and B as Gy. And since G is the greatest common divisor, so there would be no common divisor between x and y, hence GCD of x and y is going to be 1, right? So if we subtract b from a, then what would we get? G x minus y, right? And what would be the greatest common divisor of, or what would be the multiples of a minus b? So one would be g, right? And one would be x minus y. And if I tell you like what would be the GCD of a and a minus b, since x and y don't have any GCD, the GCD is 1, so they won't have any common divisor. So the only term left is g, right? So g would be the greatest common divisor of a and a minus b, and similarly, GCD of b and a minus b is also going to be g, right? So the main idea of the program would be to have this x minus y, or x minus y as 1. So how can we achieve that? So what we are going to do is that unless a is not equal to b, we'll use a loop, and what we're going to do is we'll continuously subtract the smallest number from the biggest number. Suppose that after 2 or 3 loops a is greater, so we'll subtract b from it, and after that loop, suppose b becomes greater, then we'll subtract a from it, and this goes on until a becomes equal to b. So suppose there is no common divisor, so 1 would be the answer. So there would be a point when a and b both becomes 1, and that case would also have a is equal to b, and so we'll come out of the loop, and then we can return either a or b. Okay. Now here I have one example, 12 and 15 as a and b, and let's try doing a dry run here. So we'll use a while loop to compute the GCD, and we'll use a loop until a becomes equal to b. And inside the loop, what we are going to do, we are going to subtract the bigger number from the smallest number. All right. So now b is greater here, so a minus b becomes what? B minus a becomes b now becomes 3, right? And what does a become now? It is still remains 12. Now after this pass, a becomes greater than b. So what we are going to do is we are subtracting b from a. Hence value of a becomes 9, right? And b still remains 3. Alright, now after this loop, a is still greater than b, then we'll again subtract b from a. So now a becomes 9 minus 6, which is equal to 9 minus 3, which is equal to 6, and b still remains 3. Now we see a is again greater than b, then we'll again subtract b from a, then a is going to be 3, and b is going to be 3. Now this is our condition of while loop, right? A is equal to b, hence we'll come out of the loop and we'll print either of them, right? Hence this is the way how we can find GCD. Also you can check that GCD of 12 and 15, since these are small numbers, you can check GCD for yourself. Hence it is going to be 3, right? Now let's try to do the coding part here. So let's first include the header file here. Yeah. All right. Now let's have our main function. We will have two variables. Let's have them a and b. All right. And let's have them as user input. All right. And then what we are going to do is we are going to simply cout gcd a and b. All right. Let's have a function gcd where we will declare two variables, int a and int b. All right. Now what would be the, now there is going to be a while loop, right? So let's have a while loop. So what would be the condition? That a not equal to b, the loop would run till then, right? Now what we are going to do is we'll check if a is greater than b. Then what we are going to do is subtract b from a, right? Else b would be greater than a. Then we are going to subtract a from b, right? Now we are going to return a. You can also return b because both are going to be same, right? Hence this would be the code. Okay, now let's try and run it. Let's have the, let's have a as 12 and b as 15. Okay, let's see, let's have a as 12 and b as 15. Hence output is 3. This is 3 here, right? Now let's have another example of 100 and 200. All right. Okay, so 100 and 200. See, GCD is 100, which we saw in our example. All right. Now from GCD, from Euclidean algorithm, you can also find LCM, right? I must be wondering how. All right. So recall that you have read a formula somewhere, that is multiplication of two numbers is equal to GCD cross LCM, right? Now what is LCM? LCM is, least common multiple, meaning the least number which is multiple of both of the numbers, all right? So if you have to find the LCM here, what you have to simply do, you have to find n1 into n2, which you can easily find, right? And then you have to find GCD through the above Euclidean algorithm, right? We also saw the coding part of how we have to do it. And then you will just simply divide the product of both the numbers by GCD. Alright, and that's how you find the LCM. Okay, so I hope Euclidean algorithm and how to find GCD through it is clear to you, and you also got to know how to find the LCM. Alright, so that's it for this video, and see you later. Hello everyone. So today we are going to see another basic maths concept. Alright. So in this lecture we'll talk about prime numbers, and we'll write a program to check whether a number is prime or not. Alright. Now let me brush up your memory and tell you about prime numbers. So prime numbers are the numbers which are only divisible by 1 or themselves. Alright. For example, here suppose the number is 13. So what would be the numbers which will divide 13? 1 and 13 only, and that is going to be a prime number. Suppose input is 16. So what would be the divisors here? It will be 1, 2, 4, 8 and 16. So output is, no. Alright. Now suppose input is 101, the divisors would be what? 1 and 101, hence it is going to be a prime number and its output is yes. So this is how this is the definition of prime numbers. Alright. Now pause this video for 2 minutes and think about a solution. Alright. Now first talk about the basic solution which many of you might have guessed. So this is going to be the nice solution which many of you would have guessed. Alright, here we have a function, this prime function where we take n, user defined n as a parameter, and inside this what we have done, if n is 1, we'll return false, right? Now what are we doing here is we are running a loop, iterator I, which begins from 2 and goes till n minus 1, and we check if at any point I divides n, right? If at any point I is going to divide n, we are going to return false. Alright, we are going to return false. Okay. And if there is no such I, we will then simply return what? True. Yes. Now what would be the time complexity of this live solution? It is going to be what? Big O of n. The worst case would be when I is not when I is prime number, then it would be the worst time complexity, and we have to write it in 3-ton in asymptotic notation. It is going to be big O of n. Alright. Now try to think of a solution which would be better than this nice solution part. Okay. So pause for 2 minutes and think of a solution. Alright. Now let me tell you about the better solution. So here is the idea which we'll use for a better solution. So the idea is that divisors always occur in pair. Right? For suppose 30, divisors would be what? 1. For 1 we have 30, right? Pair. For 2 we have 50, a pair. For 3 we have 10, a pair. 5 we have 6, a pair. Right? Similarly in 60, 160 pair, 230 pair, 320 pair, 415 pair, 512 pair, and 16 pair, right? Now 25, 1 and 25, and 5 and 5, right? So these are the pairs. Now from this idea, can you improve the search or improve the time complexity of the prime checkers code? Then so let me tell you about it. Here is our thing. So if x and y are suppose a pair, then x cross y is equal to n, right? And suppose one is going to be smaller number and one is going to be bigger number, or they can both be equal. Suppose x is either smaller or equal to y, right? So here this equal to can be substituted with this sign and we can put x in place of y. This formula would come, right? Now here is square, x square is less than equal to n. As you can say, if x is equal to or less than n, right? So we can say that every number will have, if not prime, will have a divisor which would be less than or equal to the square root of it. Right, here x. Suppose there is a y also, there is a y divisor also, but it will have a smaller pair, divisor pair x, which would be less than root n. Right. So instead of running a loop for I less than n, we can run the loop for I less than or equal to root n. The time complexity in that case would become big O of root of n. So this is going to be a better solution, right? So this is the better solution. Alright, now let's try to code this. Okay. So let's include header file. Okay. And let's have this one. First of all, let's write our main function. We'll take in from user. Alright. And what we're gonna do is here we'll write function is prime n cout true, or we can write not prime, and here we can write prime. Right. Now let's write the function here as prime. Okay. Now we'll have the condition of we'll explicitly check for 1, right? If n is equal to 1, we'll simply gonna return false. Okay. Now what we are going to do is we are going to for int I is equal to 2. Now instead of running I till n minus 1, we are going to run I till less than or equal to n. So square root of n, for that we have used I into I greater than equal to n. We have simply done I plus plus. Alright. If n percent I is equal to 0, we will do what? We will simply return false, or else we are going to return true. Okay. Okay. There is some problem of. Okay. Yeah. Yeah. Okay. Yes. So this is going to be our program. Let's try and run it. Alright, suppose let's take the examples which we used earlier. 13. Okay. 13 prime. That's what we saw in the example as well. Let's try for 16. Not prime. Yes, that was the expected answer. Alright, yeah. 100 prime expected, right? So this is the better solution to the prime checker. So from this video, I hope that you learned about that there are, as we talked in the previous videos of asymptotic analysis, that a program has many solutions, right? And as a developer, your task is to find the most efficient one, which takes the least time. So I am pretty sure many of you have guessed about this nice solution that we'll run a loop from 2 till there's another number, and if then I divides and will return false. But very few of you have thought about the better solution, which works fairly better than the nice solution. This is your task, to decrease the time complexity and make your program faster. Alright. So I hope you understood how the prime checker function or a program works. And this was all for this video. See you next time.
Hello everyone. So today we are going to look at another basic mathematics question to find prime factors of a number. Alright. So in the previous video we saw how to find a prime factor, right? And what is a prime number? Alright. Now see here. Let's start with this example here. Input is what? 12, right? So what would be the prime factors of this number? So to brush up your memory, let me tell you about prime factors. So prime factors are the factors of a divisor, which in this case here input is the divisor, which is 12, and the factors of this number which are prime, right? Yes, all right. So what would be the prime factors of this number? 2 is going to be a prime factor, 2 is again going to be a prime factor, and then 3 is going to be a prime factor. So in basic elementary school level, what we used to do was we'll divide the number, right? 6, we'll divide the number again, we'll get 3, then we'll divide 3 and then we'll get 1, and this is the prime factorization of this number, right? And this is what we have to find. Suppose input is 315, right? Then what? Let's divide by 7. Yes, then let's divide it by 5. Yes, let's divide by 3, and we'll then again divide it by 3 and we'll get 1, right? So this is what we have to find, right? Hence our output is this. All right, now pause this video and try to find a solution for this. Okay, now I hope you must have tried a solution, so let's talk about it. So there are basically two ideas of the solution. First, that divisor will always appear in pair, right? For suppose 30, this is thing. So we can say that x is less than equal to n and square root, right? We talked about this in the prime checker video, right? And then we are going to say that number can be expressed as multiplication of powers of prime factor, which we saw here, right? And you can see it here also. Okay, 12 is 2 into 2 into 3, 450 is 2 into 3 into 3 into 5 into 5. Right. Now I have seen the idea which we are going to use in the solution. So try to find the algorithm on your own. So the algorithm would work like that. We'll have a loop where we'll declare a iterator I, which will run from 2 till root of square root of n till this number, because divisors always appear in pair, and this is how we'll find a prime number, which will, if there is a prime factor of a number which will divide it, so we'll find it in under root n time in under root n, right? Okay, then what you're gonna do is you're gonna divide it. You're gonna divide n or the number as long as it gets divided. Okay, as you can see, 12. 12 is first. Our first prime number which will divide it is going to be 2, right? 12 will divide 2. 12 will now become what? 6. You can see that 2 will again divide it. So we'll again divide it by 2. The 2 will come out to be 3, and then we'll divide it by 3, right? In the same way we are going to do for 450. We're going to divide it by 2, right? It will become 225. We'll divide it by 3. It will again get divided by 3. Then we'll divide it by 5, and it will again get divided by 5. And that's how we'll find it, right? Now let's try doing a dry run for it. So first our I would be what? 2. So we're gonna print 2. Then we are going to divide 450 by 2. Now n is going to be 450 by 2, which is 225. Alright. Now and we can see that 225 will not divide by 2. Now alright. Now what we are going to do is we'll put I as 3. Alright. So what we are going to do is we are going to print 3, and we are going to divide 225 by 3, which is going to be 35, sorry, 75. Yes. And then we'll check if 75 will get divided by 3 again. Yes, it will. It will come out to be 25, right? Now we're going to take I4. We can see that it will not divide 25, hence we'll skip this. We'll go to I5. Then we can see that 25 will get divided by 5, hence we'll print 5. Now our 25 by 5 becomes 5, sorry. Yes. Now we'll again print 5, and then we'll divide 5 by 5, which is going to be 1. Hence this is going to be the correct output, right? So this is the algorithm which we are going to do for this problem. So let's try and code it. Alright, let's include the header file first. Let's have a main function where we'll have the divisor. It will be a user-defined divisor, and then we are going to call a function print prime, which will print all the numbers. Now let's make the parameter is going to be user-defined input. All right. So first, see if n is equal to 1, what we are going to do is cout invalid, right? Because see, n is not a prime number, so or n is n won't be having any prime divisor, right? You can see that it's common sense. So now we'll have a loop here where we have I as 2. We'll run it for till here, right? Till root n. And now what I'm saying is while n, if we, okay, this sentence means what? That I is a prime factor of a number, right? If it is, equal to 0, we are going to do what? See out I. Let's have a break in every prime divisor. And now we are going to change n as n divided by I, right? So this is the idea, like which, see, suppose I is 3. So we can see that 225 will get divided by 3. So we printed 3 first. Now what we did is we changed n to n by I. It becomes 75, and then we have a while loop. So we'll see that n, which is now our 75, is again getting divided by 3. So we'll print 3, right? So this is how we are proceeding with this loop, right? So that's how this program is going to run, right? Now suppose n is 13, right? A prime number. What would be the prime factors of a prime number? The number itself, right? The number itself. So for that, we'll simply use the loop. If n is greater than 1, we are simply going to see out n. Alright. Now, if you are having a little bit confusion about this thing, I'll make it clear to you. Okay. Suppose n is a prime number. 101. It is a prime number. Yes. So for this, we are going to use loop till 101 root. We can say like roughly to 10. Right. Since it is a prime number, there would be no prime factors of this number, right? So till 2 to 10, there is not going to be a prime factor of this number. Hence, our n would be unaltered and it is going to be only this. So we just said that if n is greater than 1, we're just going to print that number. Okay, so that is how this code is going to work, right? Now let's try to run it for a solution. Suppose 450, right? User input is 450. Okay. I guess we're printing something. Oh yes, sorry, my bad. This loop you can see is going to be outside this, right? Yes. Now let's run it for 450. See, 23355. That was the required output. Yes, let's try and do it for suppose 12. 223. Yeah. See, that is the solution here. So I hope you got it clear that what is prime factors and how to find a prime factor of a number through program. All right. So I'll end this lecture for today and see you next time. Hello everyone. So from this video onwards, we are going to look at a new topic, a new data structure, arrays. All right. So first of all, let's talk about definition. So array basically means it is a collection of same data types stored at contiguous memory locations. All right. So array is basically a container which stores data of same types, either int or char or anything, right? and it stores at contiguous memory locations. Alright, now suppose see, this is an example of array. It contains 5 elements of same data type int, right? 10, 20, 30, 40, 50. These all are integer data type and they are stored in our array. Okay. Now let's talk about contiguous. What do we mean by contiguous memory locations? Alright. So see, this is our array, right? 10, 20, 30, 40, 50. And suppose address of this array is x, right? So first element would be at x, and suppose size of elements is y. Okay, for char it is 1 byte, for integer the default size is 4 bytes, right? So that is our y. So if array is stored at position x, okay, so if array is stored at position x, like here, the next element would be stored at x plus y. And similarly, next element would be stored at x plus 2y. And this goes on. Suppose there is one more element like 60, the size would have been x plus 5y. Alright. For example, suppose x is 1000 here. Right. And y would be what? 4 for integer. Alright. So 10 would be stored at what? 1000. 20 would be stored at location of 1004. Similarly, 1008, it is going to be 1012, and this is going to be 1016. So this is how the elements are stored. All right. Now the big question here arises is that why? Why is the need of arrays, right? Why cannot we just create, 5 variables? So let me tell you, it would be a very complex code. All right. First, you have to declare 5 variables, then you have to take the input and so on. And it is not just 5 variables. You can have 100, thousands. Okay, let's take a real life example. Suppose we have an array with the name of friends of your Instagram account or followers of Instagram account. So it may be 100, it may be 1000, it may be 2000, right? So declaring 100 variables, 1000 variables, it is, very complex code and not efficient, right? So that's why we need a container type data structure arrays. There are many other data structures which, store datas of same types like linked list, stack, but that will come later in this series. Okay. Now let's talk about type of arrays. Okay. So in general, or not in general exactly, but see, there can be like 100 of ways to differentiate the arrays, right? So here I choose types of arrays differentiated factor as size. Okay. So there can be two types. One is fixed size arrays and second is dynamic sized arrays. Alright. So fixed size arrays means that they don't allow any other items than current size in which they are declared, right? Suppose here fixed size array is declared. Okay, this is int air 100, right? So that means the size of this container is 100, like it can at most store 100 elements, right? If you want to add 101 element, this will give you an error. right? Same goes for this int air n. All right. Now n here is user input. All right. Now another way of writing this code is this term. Int star air is new int n. All right. So let me tell you about this thing. This is stack allocated. Okay, I cannot place it properly, but you can see like this stack allocated. Both of these are stack allocated. So okay, I'll put it in the middle. And both of these are stack allocated. And this is heap allocated. All right. So these are basically the type how they are stored. Okay, so in simple language, what I can say is that if you have this term, if you declare array like this, you have to have the value of n. All right. So what you are going to do, you are going to declare a variable and then you are going to have the user define the variable first, and then you can write the syntax. Otherwise, it will give a error. But in this case, you can simply write this before or even after the user input the variable. All right. So this is more better as if we use arrays in functions. All right. Now let's talk about the second type, which is dynamic sized arrays. So dynamic size arrays are they automatically resize them when we add more items. Okay, dynamic arrays are which resize them automatically. So in C++, we use vectors for it. Okay. Vectors are basically arrays. Okay, but here if the size automatically increases or decreases as we insert or delete an element from it. Okay, so I hope that is clear to you. And in other languages such as Java, we use ArrayList for dynamic arrays, and in Python we use list. Okay, so this was just an intro video of arrays to help you get familiarized with what are arrays and what are its different types. So in next video we are going to see the operations on vectors, because I'm guessing like vectors would be something new to you, but you must have studied arrays in basics of C++. So we'll talk about vectors in our next video. It is going to be quite interesting, right? So I'm going to end this lecture today and see you next time. Hello everyone. So today we are going to learn about vectors. So as I told you earlier, for dynamic size arrays, we use vector class, right? Now you might be wondering like what is the problem with simple arrays, traditional arrays which we use. So the biggest problem with them is memory storage issue. All right. So, okay, let's take an example. Suppose you are given a task by a university to have a database of 500 students, right? Or you can say like of all the students which will take admission in 2022. All right. Now the number of seats in your college is suppose 500. So obviously you will store the students data in an array table, right? So for that you'll use an array. Now suppose you made an array of 500 students. Now it is not, suppose it is not necessary that all the students will take admission, right? Suppose only 400 took admission. So your size of array, which is 500, 100 memory is, wasted, right? And in the same way, suppose your university in the same year increased the seats to 600, 650 something. Now how you will, add more data of the students. So that's why we use vectors. So the main advantages of vectors is, first of all, as I told you about the dynamic size, I think it is rich library function. All right. There are many vector functions which are, directly help us in coding, like finding a number or, deleting a number. So it helps us in that. All right. Now let's try and code some. So let's first of all let's include our all right. Now first of all let's talk about how we'll declare a vector. So it's very easy. You'll write vector and then you are going to write the type of your vector. Suppose here I'm taking int and then you'll have a variable. All right. So you can use char, long, anything, right? So this is how we declare a vector. All right. Now next thing, what let's see how we'll add elements in a vector. So it is very easy. You'll do v, which is a variable name, right here. V dot push back. See, our IntelliSense is already completing it, so I'm just doing that. And number. Suppose I'm adding 10. And suppose I add 20. And I add 30. Alright, so this is how we enter the numbers in a vector, right? Now, how will you access this vector table? How you will, print the values? So for that, what you can do is, I'm going to tell you three ways for it. Alright. So first way is simple array for int I is equal to 0, I less than, okay, one more vector function is v dot size. So v dot size returns as the size of the vector. Here it is 3. So this loop will run till 3 and I plus plus, right? Now simply just see out vi and alright, easy code. Let's try and run it. Okay, it is taking some time. Yeah, here is the result 10, 20, 30, right? So this was one way. So let me, all right. So I commented this. There's another way which is for int x belonging to v, cout x enter. All right. Now what is this? What are we doing here is we are having a variable x which will access all the values of v and we are going to every time see out our x. Also one more interesting thing is suppose you don't know like what are the values in your vector. Like you don't know okay, vector is character or string or sometimes you can forget it when you write big codes, right? So instead of int what you can write is auto. All right. So it automatically detects the element in V, and then we see out the X, right? So let's try and run it again. See, it's again 10, 20, 30. So let me comment this as well. Okay, now third is very interesting. All right. All right. So here what we are going to use is we are going to use iterator. All right, we are going to use an iterator, which is going to be a pointer, of course. I'll explain the code. Don't worry about it. All right. Now you might be wondering what is this thing which we have written here. All right. So iterator is basically a pointer, right? Let's go back to our table. What are the elements which we took? 10, 20, 30. All right. Let's have, like this 10, 20, 30. This is like this. So this is our vector vector. The table looks like this, right? Now see what I have written. For it v dot begin. So v dot begin is also a function of vector. So what it does is it tells us the first element, which is 10. So iterator pointer is pointing at 10, right? And can you tell me what is v dot end? Think and tell me. So many of you might have thought wrong, and it's all right because it is the first time you are hearing about it. So v dot end always refer to this. All right, to the space which is next to the last element. So that's why we have written till it is not equal. If it is not equal to v dot end, we'll increase it. All right. So first it is at 10, right? V dot begin. After that, it will go to 20. It will print 20. After that, it will go to 30. It will print 30. It will come here, which is v dot end. So this condition will get violate. This condition will get violate, and hence will come out of the loop. Alright, and since it is a pointer, so to access the value of the pointer, we are using star here, right? Simple, cool. Let's try and run this code as well and see. See 10, 20, 30, which is our desired value. Alright. So till now, what you have learned how to insert an element by v dot pushback, and you have learned v dot size, which returns the size of the vector, right? And what else? You have learned 3 ways how to access elements, right? And what else? What else? What else? What else? Hmm, v dot begin. You have learned, which helps us get the first element, right? You learned about vend, which refers to this part. All right, and well, yeah, so that's all you have learned. Okay, let's code this also so you will understand better. All right, cool. Now let us talk about deleting an element. How you will delete an element. So it's very easy. What you'll do is v dot pop back. Yeah. So what it does is it will always delete element from the end. Alright, so if I write v dot pop back, it will delete this element. Alright, so if you want to try it, let's write it here and I remove this. Alright, and run this. Output should be 1020. See, 1020. So it always deletes the element, deletes the last element, v dot pop back. Alright. Now, what else we can see about this? I already told you about. Okay, there's one more function, v dot insert. Okay, so what does v dot pushback does is it will always insert element at the end, right? Suppose if I write v dot pushback 40, v dot pushback 40 would come here, okay, and then the v dot end would come here, right? But suppose if I have to like put here in the starting, what would I do then? So we'll use insert function. So it takes two parameters. First is, the position where you want to put it, and second is a value. So for position, we always use v dot begin, alright, which tells us about at the first element, and the value could be anything. Alright. So instead of v dot begin, if you want to add it to the v dot begin would, we'll add 3 at the first place. Suppose if I have to put it at second place, or yeah, suppose if I want to put it at the second place, so what I'm doing is I'm just simply add 1. Alright, so I'll erase this one. Alright, I'll control X this one. Alright, let's do this and let's try to run it. See, it is added to the second position. Okay, easy code. Right, another thing. So yeah, you heard about we don't pop back, which removes the last element, right? We told about you. But if you want to, delete any other element, what you can do? You simply will do v dot erase, and you write the position. Again, we'll do the same thing. We'll do v dot begin. So v dot begin will, obviously remove the first position element. If I want to remove the second position element, I would just simply add 1, right? So I'll just copy this and add it here so you can check for yourself. Alright, whether the element is deleted or not. Alright, control S, right? Yes. See, initially it is 10, 3, 20, 30. But now we have removed the third element, so it is 10, 20, 30. Alright, cool. So that was, v dot erase. And suppose now if you want to remove all the elements of, the R vector, you will simply write v dot clear. Now if you write to check, we'll write c dot v size, and comment all of this out. Let's see 0 because we have removed all the elements, so size v dot size would return 0, right? So I guess that is all. These are the basic functions of vectors which you should know, all right, which will help you in the array problems, all right. There are many more vector functions which you can obviously check on net, all right, but trust me, these are the main functions which you'll be using most of the time in your codes, all right. Okay, one more thing I want to tell you that see, I here what I have done is I have pushed back the numbers from the computer, right? But what if I want what if the user, wants, what if I want the user to input the number? So what I can simply do is that I'll have something like int v n user size, all right, and simply I'm going to do is, all right. Now what I'm going to do is I'm declaring a variable x. We'll have x and then v dot pushback x. All right. So this would come in handy to have user defined inputs. All right. So I guess this was all for this video, and this was all for the vector part. So I hope you understood vector functions, how to use them, and see you next time. Hello everyone. So today we are going to look at some operations on arrays, which are going to be basic operations. All right. So this is going to be part one of the video, and there would be another part where we'll talk about some more basic operations. All right. So mind that we are going to do it on, um, fixed size arrays. So we won't be using vectors because doing these things in vectors is going to be easy because it has rich library function, right? So that's why. Cool. Now first of all, let's see searching in an unsorted array. All right, unsorted array means the elements are randomly there in the array. All right. So suppose our input array is something like this: 25, 7, and 25. Cool. Now, if I'm saying that if I have to find a number which is equal to 5, so how will I do that? All right. So first of all, what would be the output here? Found. See, 5 is here. It is there in the array. And let's take another example. We have the same array 25, 7, 25, and suppose the target element is 15. So our output is going to be what? Not found, right? Because 15 is not there in the array. Cool. So what are we going to do is we are going to traverse the array from the beginning element till the end element, and if at any point uh, we check all the elements, and if at any point the element is equal to target, we'll return true. Cool. So let's try to code this. Cool. So let's include mm, 1 minute. Cool. First, let's write a main function where let's have input variable n, alright, and have array element, alright, int star ar. I told you about this expression. This expression is used to, um, declare a array of n size when n is, not yet defined. Alright. So let's have, scene n. Cool. So, and then we'll, scene ari. Alright. We'll have a function of, let's name it, we'll have a boolean function found. So found, which will take r and n, if found is equal to true, what we're going to do is see out found. Alright. Else we are just going to simply see out not found. Okay, and then just return 0 here. Okay, now let's have a bool function found which takes array as an argument and input size as an argument. Alright, so what now we are going to do is what we are going to do here is alright, one more thing after this, let's have a target element, the element which we have to find here. Alright, and here let's have the target element. Alright, now we'll traverse the loop. So I've declared an iterator I, which will start from 0, will go till n minus 1. And what I'm saying is, if ARR of I at any point is equal to, target, at any point if it is equal to target, I'm just simply returning true. Cool. And I have a statement here as return false. Okay. So, great. Yeah, cool. So what is happening here is I'm checking all the elements of of my array, and if any element is equal to target, I'm just returning true. Suppose if there is no element matching here, so what will happen? I will go from 0 to n and we will come out of this loop. And if we come out of this loop, that means there's no element which is equal to our target element, hence we'll just simply return false. And if it is present, we'll just simply return true here and we'll come out of this whole found function. Cool. So this is how this code is going to work. So let's have this only. So n would be 1 2 3 4 4. Okay, let's have 4 here, and we'll have our element as 25 725 20. Okay, and the target element is 5. Found. See, 5 was there. Now let's try doing another example. 4 20 5 7 and 25, and target element is 15, not found. Cool. So this was an easy function, right? Let's go to second operation. Insert a number in an array at any point. Right. So okay, first of all, as I've told you that array is um, a fixed size array. We are using a fixed size array. So if suppose the array size is 100 and there are 100 elements in the array. So we cannot, have the target element inserted in it. All right. So we must have, empty space in the array. Okay. And suppose, let's say target is 7 and the position is 2. So 2 is where at 10, and we'll shift our 10 and 20 by one place. So our new output array becomes 5, 7, 10, 20. Okay. So can you think how to write this code? So what I'm going to do is, see, our position is given. So position is always from one indexed, right? One index means this element is at first position, second position, third position, and so on. But in array nomenclature, we use a zero indexing, right? So this is at zero index, first index, second index. So suppose a position is given as 2. So our index would be what? 1, right? So what we are going to do here is we'll run a loop from 1 till n is the number of elements present, and we're just simply going to shift the numbers one by one. So what I'm saying is that it is okay. Let's write like this. So what I'm saying is from index 1 we'll shift one position. So it is like something like 5, 10, 10, and 20. And then we'll just simply, you know, have this number as our target element, 7. All right. So this is, the working of the code. So let's write the function here. Um, let's, first write our main function. So here I'm not having the inputs as user input. You can obviously take it, but for the sake of simplicity, to help you understand the code better, we are not going to take it as anything as user input. So suppose our array size is 5, all right, and we'll have a cap value which is going to be 5, the maximum size of the array, and then we are going to have n as 3, which means the number of elements present in the array. Cool. Now let's have ARR 0 as 5. Okay, ARR 1 as something 10, and ARR 2 as 15. Cool. Okay, now what we are going to do is we are going to do two things. So cout before insertion simply cout ARRI. Okay. Okay. Now what we are going to do is let's have target element as 7 and the position as 2. Okay. Now simply what we're going to do is insert int array n x cap and position. All right. Now let's okay. So I'll tell you about why we are putting n as this. When we'll write the insert function, you'll get it. Okay. So first of all, I was using it here. Okay. This is going to be like this. Cout after insertion. Okay. We are just going to simply cout arr. All right. So this is the main function. So what we did in the main function is we declared array of size 5. Okay. The maximum cap or the maximum numbers which can be there is going to be 5, and then you have the number of elements present as 3. Okay. And then we initialized the 3 elements as 5, 10, 15, and then we see out like the array elements before insertion. Okay. Then what we did is we have the element which we have to insert as 7 and at position 2. Okay. And for that we are going to use the function insert, which we are going to write right now. Okay. So one thing I want to tell you is the initial array would look like this, right? And the modified after insertion would look like this. Okay. So we have to achieve this one. Okay. So for that, let's write the array function. Cool. Int arr, int n, int x, int cap, and int x. Okay. Sorry, it's going to be position. Okay. So suppose n and cap is given by user. So for that also we'll use this function or this thing. If n and cap equal, we will simply return n here. Because you cannot modify, because there are the maximum elements which can be entered are already there in the array, so we cannot do anything. So we'll just simply return n. Okay. Now we're going to have index as position -1. I told you about the 0 indexing and 1 indexing. So we'll have index as position -1. Now what we're going to do is for int I is equal to n-1, I more than equal to index I minus minus arr I plus 1 arri. Alright. So take 2 minutes and think about what I did here. So what I'm saying is there are, we can have 5 elements. So initially our pointer is here and I is here. We are shifting 15 to here. So after first pass, it is going to look like 5, 10, 15, 15, and this. Okay. After second pass, this element would be here. It would look like 5, 10, 10, 15. All right. So this we have achieved. Now simply we'll just, at index, we'll put 7. Okay. Easy. So here now we are just simply going to have here our index as x, okay, and simply we are going to return n plus 1. Now you got it why we are having n. See, if I added 7 here, initially n is what, 3, now n has become 4. So here n now becomes 4, and here alright, if suppose n is equal to cap, we cannot modify anything, so we'll just simply return n. Okay, so this was the whole code for insert. Let's try and run it. Okay, we don't see, before insertion code was like this, 5, 10, 15, and after insertion the code becomes 5, 7, 10, 15. All right, so I hope two operations which we did today, one is searching in an unsorted array and one is inserting in an array, is clear to you. And that's it for this video, and see you next time. Hello everyone, so today we are going to continue our topic operation on arrays from our last video. So in our last video we saw two operations on our fixed size array. One was finding a specific element in our unsorted array, and second was insertion of an element at a specific position when an array is not fully filled. All right. So today we are going to look at deletion of an array. All right. So suppose our input array is somewhat like this: 3, 8, 12, 5, 6. Cool. And if I say delete x12, so the new output should be 3, 8, 5, 6. All right. Similarly, if we again take the same array and if we delete 6, 6 would be deleted and only 4 elements would be left. All right. So pause this video for 2 to 3 minutes and think of a approach to solve this problem, and try to write the code yourself. So I guess you might have gave a thought of how to solve this or something. All right. So let me tell you how to solve this. Okay. So what are we going to do here is we'll search this x element in our input array. All right. Suppose x come here, right? 12. Okay. 0, 1, 2. And its index is what? 2. So what are we going to do is we are from index 2 to 4. 4 is what? N minus 1. Alright. From index 2 to 4, what we are going to do is that we are going to put array I as array I plus 1. Alright, so instead of this term 12, okay, for like let's write this code. So it is like 3, 8, and this is what array I would be written as array I plus 1. So this would be what? 5. 5 would become 6. So sorry, this would go till n minus 2. Alright, it would go till 3. 0, 1, 2, 3. And we'll discard this last element. How we'll discard it, we'll see in the video. Alright. So this will go till n minus 2. In this case also, see, x is 6. So this we'll discard the last element and we'll get this array. Alright. In this, I is itself n minus 1. So we'll just discard the last element. We don't have to, shift the elements like in the first scenario. Alright. So I hope like you have got a basic idea of how the basic idea of this code would be exactly. Okay. Also note one thing that this problem is, see, if there are like multiple occurrences of x in our array, so only the first occurrence would get deleted. Alright. Suppose here one more 12 would have been here. Still only this 12 would have been deleted. Alright. If we have to, like delete multiple occurrences, there's a more complex code which will come later in this series. So for current scenario, let's assume that all the elements are distinct, or if you are assuming that there are more occurrences of our x, so just only the first occurrence should get deleted, right? So let's try to code this. Okay, let's include our header file first. All right. Let's try and write a main function. So let's have array as the example array. You can have the user input array, but for the sake of simplicity, I'm having my defined array, which was there in the example. This was there in the example, right? And let's have x as 12, okay, and size of array as 5. All right, now let's do one thing. Let's write this like before deletion. All right, and yeah, and let's have n as delete. All right, and array, let's pass x, let's pass n. All right, and let's have this code. after deletion. So let's again run this. All right. So you must be wondering, what is this n? Like, why are we like substituting this value? So let me first write the delete code so you'll understand better. Okay, let's have delete code here. Let's, yeah, delete. All right, let's have int air, int x, and int n. Okay, now let's try and think. Let's have I as 0. All right, and let's run a loop from I to 0 till I less than n and I plus plus. And let's say that if at any point ARR I becomes X, break. Alright. Now there can be instances like when the element, the X element X is not present in the array. Alright. For example, let's suppose X here is 13. So there's no 13 present here. So there would be no deletion operation. Hence our array would be intact. So in such case, what would be the, like, what would you do in such case? So what you're going to do is, see, we have our variable I would run till n. Okay, so this loop would run, and as soon as, see, if x is not present here, what will happen? I will reach n and it will break. Okay, so let's put this condition that if I is equal to n, we'll return n. So basically in our delete function, we are returning the size of the element. So if suppose if we delete the element, n would become n minus 1 and the size would reduce, and we're reducing the n here. And suppose if the element x is not present in our array, we are simply returning n because the array would remain intact. Cool. So this was one scenario. Another scenario is that there's the x element is present in our array. All right. And we found it and we broke this loop. And now we have I as the index of x element. For example, give me 1 minute. Let's erase this a little bit. All right. Yes. So suppose in this I is x is at 12. All right. We'll have I initially as 0 and we'll run through this. And at this point, our ARR would be equal to, x, and the loop will break. Hence, I would be 2 here. So I would be 2. So now we have, our element, the index of the element to be deleted. And what did I tell you, that from this till n minus 2, we are going to run this operation. ARRI is equal to ARRI plus 1. All right. So now what we are going to do is, for int j is equal to I, this will run till n minus 1 less than n minus 1, meaning n minus 2, j plus plus, and what we are going to do is arr j plus 1, return n minus 1. All right. So what are we doing here is, we did this thing. All right. So Now you must be wondering how we discarded this. So I guess this is clear. We'll have 6 here, but what we are doing is we are returning only this size, 3856. So at no point we are saying the size of our array is the same. Since we have reduced the size of the array, this element would get eliminated. Only 3856 would remain. Alright. Because size has decreased by 1. Okay, so we have returned n minus 1. nr n. And this loop will run for I equal to 0, I less than in n, I plus plus, and we'll just see out arri. Okay, let's save this and try to run it. See. Okay. Okay, 1 minute. What happened here is we didn't put cout ender after this. Now it would be like more clear to you. Right. See, before deletion, there is 381256. Okay. And after deletion, our array is 3856. All right. We have, you know, deleted the element 12. Now if we put x's as 6, now what will happen? Let's try and run it. See, 381256, 38125. Hence, the code is correct. All right. So I hope you have understood how the deletion operation on arrays work, and the previous video and this video combined covered the basic operations on the fixed size arrays, which could be done easily on vectors, which are dynamically sized arrays. But since we have to demonstrate you some operations on the fixed size arrays, so we did some basic operations of insertion, deletion, and searching. All right, so I hope this is clear to you, and I'll end this lecture today, and see you next time. Hello everyone. So today we are going to look at a new question based on array data structure, which is finding largest and second largest element in our array. All right. So let's see this example. All right. See, this is our array of size 4, and there are some elements in it, 10, 5, 8, 20. Now what we have to do is we have to return the index of our largest and second largest element. Okay. So what is the largest element here? 20. So index of 20 is 3. And second largest element is 10. So index of 10 is 0. Alright. Another example is array of 5 elements. And here we have to find the largest and second largest element. So the largest element is here what? 30. And we have its index as 2. Right? 0, 1, 2. And second largest element would be 20. All right. So this slight error. Okay, the second largest element is 20 and its index is 0. Okay. So this is the the basic idea which we are going to see here. I want to find the largest and second largest element. Okay. Now what I want is you may pause this video and try to come up with a solution on your own. Okay. So I hope you might have tried it and you somewhat reached the solution. Okay. So let me talk about it, what we are going to do here. Okay. So see, for largest element, I guess most of you might have figured it out, but let's talk in detail. Okay. So what we are going to do is, suppose this is our array, right? What we are going to do here is we are going to have a variable res. All right, res is short form for result, which I have taken here, and we'll put its value as 0, or you know what, let's erase this, and okay, what we're going to do is we are going to have res, okay, which is going to store the element, all right, and we are going to have res I, which is going to store index of element. What are we going to do here is initially we'll put res I as 0 and res as 10, or 0th element. All right, now what we're going to do is we are going to traverse this loop from I1 till in minus 1 like this, and we'll check whether res is greater than this or not. Okay, suppose res is what, 10 is greater than 5, we'll continue. What we'll see here, 10 is greater than 8, we'll continue, and then we'll come here. Now what is going to happen here is that we'll see that 10 is less than 20, so 20 is the largest element. So what we are going to do is we are just going to uh, put the value of res as 20, okay, and res I becomes equal to I, okay. So this is the basic things which we are going to do in the maximum to find the the largest element, okay. So okay, so let's try and write at least this much, okay. Let's have int AR as, let's first of all let's have this 10, 5, 8, 20, okay. 10, 5, 8, 20, okay, and let's name the function as func, okay. We'll put array and size of it, which is 4, okay, and we'll do this. Cool. Now let's try to run this func. Wait, some error is coming here. Let me check. Okay, what is this error? Too many arguments in the function call. Okay, sorry, we haven't defined the function yet. Let's have this. Okay, let's have size of it. Okay. So what did I tell you? We are going to have a res I, which is going to be 0, and a res, which is going to be AR of 0. Now what we are going to do here is for int I is equal to 0, I is equal to 1, right? I less than n, I plus plus. We are going to do two things here. Okay. First is if a of I is suppose greater than a of res. Sorry, res. What we are going to do? It's AR, sorry. Yes. So what are we going to do? We are going to change res as AR of I, and we are going to change AR of I. Wait, what we are going to do is we are going to put res I as I. Okay. So okay, yeah, cool. So yeah, so this is what we have to do here. Okay, right. So this is how we'll find the maximum element here. All right, yeah, yeah. So that's how we'll find the maximum element, the largest element in the array. Now, since we have talked about the largest element, in a similar or very close way, we'll find the second largest element. Like, can you think about it? So, okay, don't worry, let me tell you. Let's have two things. S res, okay, which will store the second largest element value, and S res I. Okay, this is going to store the second largest element value, and this is going to store the second largest element value index. So let's first of all let's declare it here. Okay, or wait, we'll declare it later. I have to tell you something. So see, we have declared this, you have declared this. Now the thing is, what we are going to do is, see, there are two things. Either the element would be the greater than the largest element, or it would be less than the largest element. Suppose the element is greater than the largest element, res. So we'll put the res as this and this. Cool. But the second largest element would then become res. Are you getting it? What I'm trying to say? See, in this example, till here, till 20, our res was 10. But as soon as ARR I, here 3, ARR 3 becomes greater than your res, we'll just put res as 20 and res I as I. But this 10 is, the second largest element, alright? Which is, the previous value of res. Okay. So this is I'm trying to say is that as soon as the largest element changes or the value of res changes, we'll first of all put the value of largest element here and res I value as res I value as res I. Okay. This is the first case. And suppose there is another case where ARI is not greater than res. It is smaller than res, but it could be potential second largest element. So we'll check it with sres. Okay. Now can you tell me like what would be the value, like here suppose I put sres I. Okay, I put sres I. We can skip it, but can you tell me the value of sres, what we can put the value of res. Now see, sres cannot be 1. Okay, this is a very common sense. SRS cannot be 1 and we cannot start the loop from 2. Okay, otherwise complications would arrive. So what we are going to put here is int min. Okay, so what is int min? Int min is, it is an integer variable. It specifies that an integer variable cannot store any value below this limit. And value of int min is 2147483648. Okay, so this is the the lowest value of our integer type. Okay, so we have put it as sres. So here we are going to have conditions. Sres will first of all become res, and sres I would become as res I. Cool. And we have another thing else. So what I'm going to see is we'll check if ARI suppose is greater than sres. We're simply going to put sres as ARI and sres I as I. Okay. So this, I agree, this code is a little bit confusing, but it might help you if you understand this code. So you may see this video 2 or 3 times, but it is very important you get this part, what we are doing here and what is int min, as I already told you. Okay, and so let's do one thing. Let's have this example. Okay, here initially we'll do a dry run here. So initially res is what, 20, and res I is what, 0. Okay, we have to put a value to res I also. Can be, suppose, okay, it's 0. It's not a very big issue. This is what we're comparing, alright. Okay, this is value of res, this is value of res I, and value of sres I is also 0, and value of sres is int min. I'm just putting I. We'll traverse the loop from here. Okay. So initially what we are going to check is whether sres is greater than 10. It is greater than this. See, sres is, ARI is not greater than res, means res is greater than ARI. So we are not going to go in if loop, we'll go to go in else loop. So we are going to check whether 10 is greater than sres, which is int min, which is the lowest value of a integer. Hence obviously 10 would be greater. So this would become 10 and this would become 1. Alright. Now we'll come to this. Let's have a little space. Okay, yeah. Now we'll come to this. We'll check whether sres is greater than 30. It is not. So this will become 30. This will become 2. This would become 20. This would become 0. See, sres becomes equal to res, sres I becomes equal to res I, and this is res becomes ARI and res I becomes equal to I. Now we'll see for this element 8. 8 is obviously not greater than 30. We'll go to else part. We'll check whether 8 is, greater than 20. It is not. So we'll come to this. Again, same thing happened. 12 is not greater than 30. We'll go to else part where 12 is also not greater than 20. So we'll go to another. I will, become out of bound and we'll come out of the loop. Hence, our numbers would be 32 and 0, 20. Okay. Now what we are going to do here is simply see out the res s res I. Okay. Let's see out the numbers. Okay. And try to run this code. Let's check whether this code would run or not. 20 and 0. Why is it coming 0? Oh, my bad, sorry. It is going to be sres, right? Now let's try and run it. 20 and 10. Yeah. What we're doing here is we're printing. We're not printing the index, we're just printing the numbers. So output here is, the index, and there we are printing the value. So you get clear like y20, y10, right? See 23 index, 0, 10 index. So let's try and run for this 20, 10, 38, 12, 20, 10, 38, 12. So what was it? 20. Okay, I forgot the numbers. 20, 10, 38, 12. Size would change. It would become 5. Let's save it and run it. See 30, 20, which was our desired result. 2 is 30, 0 is 20. Good. So I hope like this would have been clear to you how to find the largest and second largest element. Alright. So there was some logical approach here, which if you would have understood, it will help you better. And there was very important concept here about about int min. Okay. Okay, one more thing. Let me put it as comment, which is there's also a thing called int max. Alright, so int max is like int min, but instead of giving you the smallest value, it gives you the largest value. So there could not be any number greater than int max in our integer array. Alright, so I hope like this would have been clear to like what is int min, int max, how to find the largest element, how to find the second largest element, and things. Alright, so I hope this video would have been beneficial for you, and we are going to end this lecture today, and we will continue this array series more. And yeah, that's a wrap for today, and see you later. Hello everyone. So today we are going to look at another problem based on our arrays. So in previous some of the videos we talked about what are arrays and how to declare them, and we also talked about dynamic sized arrays, vectors, and we also talked about some basic operations on our fixed size arrays. And in this video we are going to check if an array is sorted or not. Right. So in this video I'm going to check whether the array is sorted in increasing order or not. Similarly, you can also check whether the array is sorted in decreasing order or not. So you will get an idea like how to do that question. Okay. So let's see example here. Suppose our array is 8, 12, 15. So we'll check whether the array is sorted. If it is sorted, we'll print yes, otherwise we'll print no. Okay. So see here, 8, 12, 15, the array is increasing, right? So it is sorted in the increasing order, so our output is yes. Similarly here you can see 8, 10, 10, 12. Array is still increasing. See, it is not decreasing here. So 10 and 10, like there can be same numbers. So we won't say that array is not sorted. We will still say that array is sorted. So this would increase. Alright. And another question. Okay, I have not written the output here. Okay. Tell me the output. So very clearly the output is going to be no. Alright. Now pause the video and think of the solution for 2 minutes. Okay. So I hope you thought of how can this problem be solved and everything. Okay. Well, let's try like what can be the approach here. So see, what we can do is we can use a loop which runs from this number, the second number, till the last number, and we are going to check whether the this number is greater than or equal to its previous number in every loop. And if at any point this condition does not satisfy, we just return the false, or else we'll return true. Okay, so that is the whole idea of this code. So let's try and code this. Let's add a header file. Yes, name cd. Let's have a main function. Let's have our array as, let's see the second example, 8, 10, 10, 12. Alright, 8, 10, 10, 12. Alright. Now if check for, you will simply see out yes, cool. Let's write our check function. Four is the size of the array. It is like common sense, okay? And we have like check function as boolean function, which will return either true or false, right? What we are going to do is simply we are going to run a loop from int I is equal to 1 till I less than n I plus just write if array I is less than array I minus 1, we'll simply return false, otherwise we'll return true. Okay, so like how this code is going to work is you went inside the loop and one by one you are checking for every number whether it is smaller than its previous number. If at any point it is smaller than its previous number, it's simply going to return false. Otherwise what will happen, I will reach till n minus 1 and then you will break out of this loop, and hence that means that there's no such number which is the smaller than its previous number, meaning the array sorted, and then we will just simply return true. Alright, so let's try and run it whether it is going to be correct or not. Yes, right? That's what was expected. Let's try third example, 100, 20, 200. Alright, we'll have to change the size to 3 and erase this, and now let's try and run it. No, expected. So that means the code is working, right? So I hope it is clear like what is the meaning of sorted, and how to check whether an array is sorted or not. And please understand this code because this code is really going to help in the future. All right. And I'm going to end this lecture today and see you in the next one. Hello everyone. So today we are going to look at another problem in our array series. So in this problem, what we have to do is we are given an input array. Okay, suppose here our input array is 1, 2, 3, 4, 5, 6, here 30, 25. And what we have to do here is we have to reverse this array. Reverse means since first element here is starts with 1 and goes to 6, so a new array should start with 6 and should go till 1. Similarly, in this case, it is 30, 25. So in the reverse case, it should go like 5, 20, 30. Okay. So this question is, very important because we are going to learn a new approach called two-pointer approach. Okay. So, okay, you might take 2 minutes and try to think of a solution. Okay. So what we are going to do here is, let me write the array. 1 minute. Okay, that's good. Okay, so what we are going to do here is basically when in all the previous videos when we are dealing with arrays, you only use one iterator I, right, which runs from here till here. Okay, but what we are going to do here is we are going to take two iterators. One is I, which will point to the starting element, and one iterator we'll take here. We'll call it J, which will point at the last element. Okay, so now what we are going to do here is we are going to swap the values at I and J. Okay, so suppose what I do here is I swap the value of I and J. So it will look like 6, 2, 3, 4, 5 and 1. Now what I have to do? Can you think of the next step? Yeah, so what we are going to do is we are going to move our I to one place ahead, meaning our I would point here, and our J will move one place back, meaning J will be here. So new array would be, if we swap I and J, it will look something like 6, 5, 3, 4, 2 and 1. And now our I would point here and J will point here, right? Now what will happen again? Let's have some space here. Okay, we'll again swap I and J. 6, 5, 4, 3, 2, 1. Cool. And now our J points here and our I points here, right? Now as you can see, our array is reversed. Okay. So just by mere observation, you can tell like what would be the end of this loop of swapping elements at ith position, jth position, and moving I one place ahead and j1 minus. So till how long this process will go? Till until I becomes more than j. Okay. So this condition for this loop would be that as long as I is smaller than j, this whole loop will run multiple times. And as soon as I gets ahead of j, then that would be the end of this loop. That means our array has been reversed and we'll come out of the loop. Okay. You can take example of this as well. Suppose our I is here and our j is here. We'll swap. So what happens? It becomes 5, 20, 30. Now both I and j points here, right? So you can also say that until as long as I is less than j, a loop would run, right? If I becomes equal to j, this loop would break. You see, swapping 20 by 20 doesn't mean anything. So only this part would remain correct. Okay. Now let's try and run, try and code this. Okay. Let's have a header file here. Right. 1 minute. My bad. Yeah. Let's write a main function here. And let's have a array as okay. Let's write as before reversal I equal to 0, I less than till 5, yes, and I plus plus C out AR I. Okay. Next, we'll write a reverse function where we have array and 5 as a size, and here we'll write cout after reversal okay. And one more thing we can write here is cool. Okay, so this is what we have to do. This is simple main function. We'll write a reverse function where we are going to take AR and size as n. All right, cool. Now we are going to have two pointers. Let's name our first pointer and initialize it at 0. Let's have our other pointer and let's initialize at n minus 1. Okay. What I'm going to do is what did I tell you? This loop would run as long as our first pointer is less than the second pointer. So while low is less than high, our loop is going to work. So what we are going to do is we are simply going to swap AR low with AR high, low plus plus, and high minus minus. Okay. See, and when we add this header file, bits slash std++.h, we get swap function. Okay, we don't have to write our swap function. But since many of you don't know how, many of you might not be knowing how to write a swap function. So let's talk about that also here. Okay, ampersand sign, this ampersand sign which we are using here is, it means we are having pass by value. Okay, see what happens is if I simply write int a and int b, it is passed by reference. That means we'll create two more new variables in our another function. All right, and whatever changes you do here will not reflect back to our original one. Okay, so that's why we use ampersand sign. What we're going to do here is we are going to have a temporary variable. In that temporary variable, we are going to store a. In a, we are going to store value of b, and b will get value of temp, which is having the value of a. All right, this is how this works. Okay, and what else? Okay, we have written the swap function. We have written the reverse function where we have used two pointers, low and high. All right. We talked while low is less than high. We did our operation of swapping and increasing low by 1 and decreasing high by 1. And we have written our main function. So yeah, this code is completed. Let's try and run it. Okay, what's the issue here? Okay, my bad. It is still 6. Sorry. This will also go till 6, and yeah, this will also go till 6. Let's try and run it again. Okay. See, before reversal, this is our array 1, 2, 3, 4, 5, 6, and after reversal, our array is modified to this. So that means our code is working correctly. Okay, cool. So yeah. So yeah, that was all of reverse and array question. See, there's very important concept which you learned here is that usage of two pointers, which will help you a lot in the further questions. Okay, and that's it for this video, and see you next time. Thank you. Hello everyone. So today we are going to look at another question in our array series, which is move zeros to the end. So in this question, what we are going to do is, suppose we are given an array which includes some zeros at different places. Suppose here it is at second index, it is at third index, it is at last index. Okay, so what we have to do is we have to take all the zeros and put them at the end, like three zeros at the end. Okay, and we have to put the rest of the numbers to the left side without disturbing the order. So without disturbing the order means, see, if we look at the non-zero numbers here, they are in order like 10, 5, 8, 9. Okay. And when we, modify our array, the numbers should be in the same order, like 10, 5, 8, 9, 10, 5, 8, 9. All right. So this is the main idea. Cool. Now pause the video and think of the solution. Okay. Now let me tell you how you can like solve this. First, let's talk about a nice solution. And I guess like many of you might have approached and cracked this nice solution. So what is happening here is yeah. So what is happening here is we are using a loop which runs from let's write our array first of all. Okay, 10, 5, 0, 0, 8, 9, 0. Cool. What we are doing here is we are running a loop from 0 till n till less than n, and here what we are doing is that if at any point our array I is equal to 0, okay, suppose here our array I becomes 0, right? Now we will use another index j which will run from this part and will go till here, okay, and we'll see if there's a number which is not 0. See here, if array j is not 0, so suppose 8 is not 0, so what we are just going to do is we're simply going to swap our element at ith index, which is 0, and element at jth index, which is 8. So our array now looks something like 10, 5, 8, 0, 9, 0. Now I gets incremented here, right? Again, see if ARR is equal to 0, we'll run j from this point to this point. We'll see that this element is not equal to 0, so we'll just swap this element 9 with 0, and this would be our resultant output 10, 5, 8, 9, and we'll again run for this. Okay, it will again check ARI is equal to 0. Then we'll run a loop from j till n, but we won't be finding any non-zero numbers, so this is how the loop would end. Okay. Now talking about the time complexity here is, see, there is this loop and there's this loop, and see that both are these are nested loops, one loop inside the other. So time complexity of this loop can be said as n. Okay, and this is n, so the overall time complexity would be n square. Okay, this is 2. Cool. O(n) square. Now since we have talked about the nice solution, now think of another solution, a more efficient solution, a solution which can be done in big O of n time. All right, think for 2 minutes and try and solve it. Okay, let's talk about efficient solution. Cool. So what are we saying here is that we need to solve it in big O of n time. A better solution would be big O of n, right? So yeah, okay. First of all, let's write our input array 10, 5, 0, 0, 8, 9, 0. Cool. 10, 5, 0, 0, 8, 9, 0. Okay, now we have to use a loop. We'll have our iterator I here initially, Okay, now let's talk about an intermediate position when I is some random number. Okay, so since we are using a single loop, if our suppose there is an array and these are some of its number and I is pointing somewhere here and there are the rest of the numbers. All right, I is somewhere here. Here are few numbers, suppose A1, A2, etc. etc. And I is pointing here. So what I'm saying is that this A1 till let's say I minus 1 A0, let's say it A0. These numbers would be the, in the correct form. Okay, meaning that these numbers would be sorted in the way they should be. Okay, that means that the non-zero elements would be at the left side and the zero elements would be at the right side of this. Okay, so let's talk about this solution. Okay, suppose I here is I is points are pointing here. Okay, let me clear a little bit. Yeah, cool. So what I'm saying is, suppose I is here. So see, I'm till I minus 1, the array is as the way we want the numbers. Okay, and suppose I comes here, we'll see that the non-zero numbers are to the left side and zero numbers to the right side. Okay, so this would also pass. We'll come here. Okay, we'll see that the non-zero numbers are to the left side and zero numbers are to the right side. Okay, now the case would arise that whether this number is 0 or non-zero. If this number is 0, we'll just simply move forward. Like in this case, what we did, saw this number is 0, we just simply move forward. But here it is a non-zero number. So what we have to do here is we have to replace it with the first occurrence of a 0, which that is this number. Okay, we have to replace these two numbers. So we have the index of this number as I, right? And what would be the index of this number? Can you tell me? Think for a bit and tell me. Okay, you may have found the correct answer. It is the number of non-zero numbers occurred before. Okay, think for a bit. Think again. What I'm saying is the index of this element is the number of non-zero elements before it. Suppose, see here, the number of non-zero elements are what? 2, right? So index of this is 2. So we'll just swap this and this number. It becomes 10, 5, 8, 0, 0, 9, 0. Now our I will reach here. See, for 0 to I minus 1, the array is the way we want, non-zero numbers to the left and zeros to the right. Now we'll see this element, this is a non-zero element. We'll swap it with the first occurrence of 0. What would be the first occurrence of 0? What will be the index of it? The non-zero elements before it, 3, right? So 0, 1, 2, 3. This element index is 3. We'll swap this with this, right? And this would become 10, 5, 8, 9, 0, 0, and 0. Okay. So this is what we have to do. Now see, our I will come here. It is a 0 number. It won't do anything. It will just increment. It is again 0. it will increment, it is again 0, it will increment, and I would become n, and we'll come out of the loop, and we'll get the correct array. Cool. So let's try and code this. Okay, let's make move zeros dot cpp. Cool. Let's include header file. Okay, let's have our int main function. We'll have int ar as it is 10.5.0.0.8.9.0 10.5.5.0.8.9.0.0. Okay, is okay. This will also work, right? Or we can do one thing is, let's have another element here. Cool. There are like 0.809.0.0. Okay. Let's have like cout before operation is equal to 0 while less than. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. We will simply cout I. Alright, now let's do this. And we'll have ARR, comma, size of it. Okay. And we'll write cout as after operation end cout okay, this will work, right? And let's make our move 0 function now, which is our main part. Let's hide the index int main part, int arr 10. Okay, arr is what? Input size, input array, and n is input size. Okay, let's have a variable int count. So what this variable is going to do is, this variable is going to have the count of non-zero elements. Okay, now let's write a function for int I is equal to 0, I less than n, I plus plus. In this loop, suppose if arr I is not equal to 0, what we are going to do is we are going to swap arr I with arr count, and we are going to increase the number of non-zero elements. Okay, and if the element is 0, we are just going to simply pass it. Okay, now you might be wondering like how we can just swap this ARR right with ARR count. And okay, let's have a dry run here. Okay, what I'm going to do is I'm going to clear a bit here, and we are going to have a dry run of this code. Okay, readable. This is readable, right? Let's see the code again. What we are doing here is we are maintaining a variable count, which will count the number of non-zero elements that occurs, and we'll put them to the left side. And we are going to use a loop, and at any if we encounter a non-zero element, we're just going to swap it with the element at the count index, and we'll just increase the count variable. So okay, at initially I is what, 0, count is what, 0. We'll see that this is I, right? We'll see what, that I is what, 0. See, if error I is not equal to 0, error 0 is what, 10, which is not equal to 0. So we are going to swap it with error count. What is C, 0? That means swapping 10 with 10 itself. So that means the 10 would be here, and then we are increasing C plus. So in the second iteration, C becomes what, 1, and I becomes what, 1. What did we see? This is also not a 0 element. So we'll swap AR I with AR C, which is 5 itself. So we'll swap 5 with 5. So no changes till here. I will now become 2. C will become 2. It will come here now. It is a non-zero element. We won't do anything to C. We'll just increment I. Now I will become 3 and C will still remain 2. We'll come here. We'll check that it is a 0 element, so we'll just increment I to 4, and C still remains 2. What is 0, 1, 2, 3? Then we'll come here. Now what we check here is that this is a non-zero element, so we'll swap this with a count with number. Count is 2, that means we'll swap it with this. So this will become 8, and this will become 0, and count will increase. I becomes now 5, count is what, 3. Okay, 5 is here. We again encountered a non-zero element. We'll swap it with the count index, which is 3. This is 3, right? So we'll swap this with this. So this will become 9, and this will become 0. Okay, now I'll become 6, C becomes 4. Again, there's a 0 element. We will just increase I, and now I will get out of range, and we'll just come out of the loop and see the array is being modified. Okay, so this was the code. So this was the whole code for this question, move zeros to the end. So here you learn two important things. One is that this algorithm can be used where maintain a variable for a specific thing, and you can replace it with another things. All right, and in the starting of the starting of this series, we talked about the asymptotic analysis and why is it important. So you can see the importance here. We talked about a nice solution, right? It is an easy code, but what did we see here? That this nice solution does the work in O(n) square time, right? But the efficient solution works in O(n) time. So the second solution is obviously better. So we talked about that also. So I guess the solution of this problem would be clear to you, and this was it for this lecture, and see you later.
Hello everyone. So today we are going to look at another problem in our array series called leader of an array. So before starting, let me first of all tell you that this question is super important. All right, and has come in many interview problems and coding rounds. So let's look at it. So first of all, let's talk about what is leader of an array. So an element is called leader of an array if there is no element greater than it on the right side. All right. So let's talk with an example here. Okay. So what we are going to do here is see the last element of an array is always going to be leader, right? Because there is no element to the right side of it, so it is going to be there. Okay, 2 is there. Then we see 5. We see that 5 is there's no greater element than 5 at the right side. All right, so we write 5 also. Then we look at 6. So we see that there's no greater element than 6 on its right side. So 6 is also leader. Now if we see um, look at 3, we see that 6s are greater than 300 is at the right side of 3, so 3 is not going to be a leader. Similarly with 4, 6 is greater than 400 at the right side of it, so it is also not going to be leader. Then we look at 10, so there is no element at the right side of 10 which is greater than it, so 10 is also a leader. Now if you look at 7, we see that 10 is greater than it and it is at the right side of it, so 7 is also not going to be an leader. Hence, we can see that our output is going to be 10, 6, 5, and 2. Right? Now what we see here is another example. I already told you like the last element is going to be, you know, leader. So 30 is the leader, and if you look at 20, 20 is not a leader, 10 is also not a leader because you can reduce it on your own, right? Now, let's talk about how you can solve this problem. Okay. So the basic algorithm here is very simple. What we're going to do is we are going to have a variable array leader, all right, and we'll run a loop from this element. Okay, we'll run the loop from this element till the first element, the second last element till the first element, and we are going to have a variable called, you can call it anything. Let's call it current leader. So see, 2 is anyhow going to be the current leader in any case. So we'll just, have us see out 2 here, and then what we're gonna do, we are going to store the current leader as 2. Now we are going to we're going to do what? We are going to traverse the loop from here till here, and we're going to check if the current element of an array is, greater than the leader. If it is greater than the leader, we will, print that element. And then what we're going to do is we are going to change the current leader value to that number. Okay. And this is how we'll traverse the loop. Let's have a test case here, dry run. So let's have current leader as 2. Now our I is what? 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 5. All right. So at 5, array 5, mm, it is greater than, currently number. So what we are going to do, we are going to print 5. Okay. And we are going to change C as 5. Okay. So now we have C as 5. We will decrement our I by 1. So I will become 4. Now at I is equal to 4, 6, it is greater than 5. So we'll print 6. Now our C becomes 6, our I becomes 3. At I is equal to 3, we have element 3. No change would be here. Now I would become 4, I will become 2. We'll decrementing I. So I2 is also not greater than 6. So nope, nope. Okay, now we'll have I as 1. Now at 1 element is what? 10. So we'll print 10, 6, 5, and 2 is already there as C. We'll print 10. We'll change C as what? 10. I would become 0 now, right? And we'll see that I0, which is 7, is not greater than C. We decrement I and we'll come out of the loop. And what we have printed here is 2, 5, 6, and 10. Alright. So this is the working of this algorithm, and we have discussed the try case. Now let's dive into coding. Okay, so I am guessing like you might have understood the coding, and it would be recommended that you do the coding part on your own, but for the sake of understanding better, I'm still going to code it. Alright, so let's have the header files. Okay, now let's have our int main. Okay, let's have int ar as what was our as 7, 10, 4, 3, 6, 5, 2. Okay, so this is going to be our int array. Now let's call our function as leaders. Now this function is going to have parameter as ar, comma, size of it. Size of this array is going to be 1, 2, 3, 4, 5, 6, 7, 2, 3, 1, 2, 3, 4, 5, 6, 7, 7, right? Okay. Now let's write our like this. Let's have ar. Let's have this. Okay. Now what did I say? Let's have a variable cr, current leader, cl, and we'll assign it to the last element. We are just going to simply cout cl, right? Okay. Yes, because see, we are always going to have this element as a leader, so we are just simply going to print it outside the loop. Now, what did I tell you? We'll run the loop from n minus 2, right? I greater than equal to 0, I minus minus. Now, if at any point CL is less than our array I, what we're going to do? We're going to change value of a CL as RRI, and we're just going to simply cout CL. Okay, okay, and yeah, that 1 minute. So you can see the better output I'm having indel after every line here. Okay, yeah. So that's it. That's the whole code here. So here we have, void leaders where uh, we declared a variable CL, which is our current leader, right? And first we have assigned it as our last element, and we have estimated CL, right? And what we have done, we have run a loop here from n minus 2 till first element, and we're decrementing our I at after every iteration. And if at any point our current leader is smaller than our array element, we're simply changing the value of our current leader as the array I, and we're just simply um, printing it, right? So yeah, this was the whole code of our leader array question. So as I told you earlier, this is a very important question. So see, let me tell you a little bit of advice here, that questions like this, like after seeing the solution, you might have wondered like this is a easy question, and most of the questions are like this, but it's just like you don't you know you don't find the algorithm to how to you don't uh, think, like you cannot think the solution. So that is the main thing here. If you find the algorithm, like how you will come up with the solution, then that's great. All right. So that's it. Yeah. So that's it for this video, and we'll see you next time. Thank you.
Hello everyone. So today we are going to look at another problem in our array series, which is left rotate an array by 1. So what we have to do here is we have to rotate our array by left towards left by 1. So what does this mean is, let me show you. So this is our input array 1 2 3 4 5. What we have to do is we have to shift every element towards left by 1. That means 5 will come here, 4 will come here, 3 will go here, 2 will go here, and 1 will go at the end. Alright, like we are supposing that the array is in a circular manner and every element is shifted towards the left of it. Right. So after doing the operations, our output would look something like this. 2 shifted here, 3 shifted here, 4 shifted here, 5 shifted here, and 1 shifted to the end. Alright, so this is how we left rotate the array by 1. Now, think of the approach, like what can you do here, and try to write the code on your own. Alright, take 2 minutes and try to write the code on your own. So I hope you would have, tried how to solve this. Now let me tell you the approach. So the approach here is quite simple. From this question, you will learn like how we can, store an element of array for our future use. So simply what are we going to do here is we are going to run a loop from I is equal to 1, meaning from this element till here. And what we are going to do is we are going to store the previous value. Suppose this is our array and our iterator is I minus 1 as its next value. Alright. So from this thing, what we'll achieve? We'll achieve, and this will run till end of the loop, right? So from this we'll achieve this pattern, right?
Now you must be wondering how to have this first element, which is here 1, how to handle this case. We have to put this at the end, right? So what we are going to do here is we are going to create a variable temp. All right, which is going to store our first element, which here is 1. All right. So you'll first store this thing, then you are going to run a loop inside which you are going to do this operation. And after the loops, our array would look something like this. And then what we are going to do here is simply we are going to change this term as we'll store temp here, right, at array n minus 1. So after doing this, what will come? 1 will come, and 2, 3, 4, 5, 1. This is our desired output array. So this is how you can solve this question, left rotate an array by when. Look at another example, 30, 5, 20. After left rotating it, 5 will come here, 20 will come here, and first element, which is 30, would go here. Similar, so here also we are going to store temp, which is going to be 30, right? And array I we are going to do this operation, array I minus 1 is equal to array I. So our array would look something like 5, 20, comma 20. Now what we are going to do here is we are going to change this element to temp, which is 30, right? And this is our output desired array. Now let's try and code this solution so you can like understand better. All right, so let's come here. Let's have our header files first. Let's write our main function. Let's have our array as 1, 2, 3, 4, 5. All right. Then has 5. Let's write cout before rotation. Let's write a loop to to see out the values. Let's simply write cout I. All right. Now let's have rotate as a function which takes our array and size of it. Okay, now what you'll write, cout after rotation, right? Again write the same thing for display. Right. And one more thing, after doing this, simply add a indel here so you can see in a more better way. Now let's have rotate here and have all right, better. Now what did I say? First of all, create a temp variable which will store our first element. All right. Now what we are going to do here is we are going to run a loop from I is equal to 1 till I less than n, I plus plus. We're simply going to do one thing, air I minus 1 equal to air I.
Alright. Now what we are going to do here is simply put AR n minus 1 as temp, right? So yeah, that was all. So this code was very simple. Just you have to, do one thing, which was how to store an element of an array so that we can use it in future reference. All right. Now let's try and run this code, see if it works. It will take some time. Let's see. All right. See, our array was 1, 2, 3, 4, 5, and after rotation, the output is 2, 3, 4, 5, 1. See, our output array should have been 2, 3, 4, 5, 1. All right. Now let's try and run this for another example. Let's take it 5. Okay, let me check what was the other example. 35, 20. All right. 35, 20. Change I to 3. Okay. And yeah, save it. Let's close this terminal. Let's run it. Let's check if the output is correct or not. See, before rotation it is 35, 20, and after rotation it is 5, 20, 30. See, our output array is fine, 5, 20, 30, right? So yeah, this was all about this question, which was left rotation of an array by 1. So in this question was very simple. You just have to shift elements of the array to the left one by one, but you have to handle the corner case explicitly, which was how to handle the first element. So you learned that you can save the element or any specific element inside a variable, temporary variable, and you can use it in the future reference, like we did here, where we had our first element, we stored it in a temporary variable, and we then switched the last element of our array as our first element by switching the last element by temp. All right. So yeah, that's it for this video, and I hope you learned the main concept of this question, and see you later. Bye bye. Hello everyone. So today we are going to look at another problem, which is called left rotate array by d elements. So in the previous video we learned about like how to left rotate an array by one place, where what we did, we just had a we just simply shifted every element to the left by one place, and we stored our first element into a temporary variable, and just after running the loop we just stored this element at the end of the array. Right. So what we are going to do here is, what the question asks is, we have to rotate the array by d elements. Here d is 2. That means we have to rotate the array by array by 2 times. Okay, we have to rotate array by 2 times. So suppose if we have to rotate the array one time, what would be the output? 2, 3, 4, 5, and 1. And we have to rotate array one more time. So it would be like 3, 4, 5, 1, and 2. Alright. So every element is shifted by twice. Every element is shifted twice. 4 in the end has come here, 3 has come here, 5 has come here, 1 has come here, and 2 has come here. Alright, so this is what we have to do. Now take 2 minutes again and think of a solution like how you can reduce this. Right. So let's first of all let's talk about a very nice solution. So this is a nice solution. So similarly, like left rotate an array by 1, we are simply doing the same thing. What we are going to do here is we are having a temporary array of d size. Alright. And what we are going to do here is we are going to store first d elements inside this temporary variable. Okay. And then simply we are going to shift every element by d places, and after that we are going to have the temporary variable in our array, similarly like what we did in the previous question, left rotate an array by 1. So let's have a dry run here so you can understand it better. So what we have here is 1 2 3 4 5. All right, and inside our temp we have 1 comma 2. Now what we have here is we have I is equal to d, I less than n, I plus plus. That means we have to solve our array from 2, yani from here, right? Now what it states that array I minus g is equal to array I. So array I minus d here is 2 minus 2 0, right? So that means this element would be replaced by array I, which is this element. So that means 3 comma 2 comma 3 comma 4 comma 5. Now a pointer would be here. Now array I minus g. Now array Ri is 3, 3 minus 2 1. That means this element would be replaced by 4. So it is 3 comma 4 comma 3 comma 4 comma 5. Now our I is here, which is 0 1 2 4. I is 4, D is 2. So second element, second index is this. This would replace by 5. So it would be somewhat 3, 4, 5, 4, 5. So we can see that after this operation, only a last d elements, which here is 2, needs to be adjusted. Otherwise, this part is according to our solution. All right. Now what we can do here is we just have to simply put these elements here. All right. So what what we do here is we replace array of n minus g plus 1 by temp I. Now you must be wondering why we are doing this, because okay, suppose n is what, 5 here, right? And what is d? 5 minus d. D is what, 2. 5 minus 2 is 3. Plus, okay, this is not 1, this is I. Alright, 5 minus 2 plus 0. That is 3. So R3, which is this element, is going to be replaced by temporary 0, which is this one. So it turns out to be 3, 4, 5, 1, 5. Alright. Now our I becomes 1. Now what will happen? N is 5, D is 2, but our I now becomes 1. So this overall becomes 4. That means this element would be replaced by our temp I, which is this, right? So our final array would look something like this. Alright, our final array would look something like this, right? So this is our final value. Now, what would be the time complexity of this question? The time complexity of this question is going to be big O of n. And what would be the space complexity? It is going to be big O of or theta of d. Right. Because see, we are always going to have a temporary variable of d size. Now come up with a solution which takes big O of n time and theta of one linear space. Okay. Now I hope you have given a try to that question, and I know that the solution which I'm going to tell you is a very observational algorithm. It is not an algorithm, it is just an observation. All right, and I'm pretty sure you might not have found it, and it is all right because this is just an observation. So what we do in this algorithm is, since we have to left rotate an array by d, what we are going to do here is we are going to reverse array from 0 to d, which means we have to rotate this part, reverse this part. Then we have to reverse the part from d till n minus 1, which is this part. And then we have to reverse the whole thing. So first we have to reverse this thing, that is 2 comma 1. Then we are going to reverse this thing, which is 5 4 3. Cool. Now what we are going to do is we are going to reverse this whole thing. So the whole thing would be 3 4 5 1 and 2, right? So see, reversing this thing, rotating this thing, there's no serious connection, basic connection here, right? A concrete connection is not here, but since we are still doing it because we have observed this thing, that if we reverse this part, and if we reverse this part, and if we reverse the whole thing, we'll get this thing. All right. So I am again saying it is all right if you could not find this solution, but now since you have seen you can do this thing also, you must keep this algorithm is also in your mind, that if you have to rotate a thing by d places, if you have to right rotate a thing by d places, you can reverse the thing and reverse the whole thing. All right. So this algorithm now you must have, you can do it in the further questions. This can also be an approach to further questions. All right. So what did I say here is, again I'm telling you, for elements 0 to d minus 1, reverse them. Then from elements for d to n minus 1, reverse them, and then reverse the whole array. Alright, so this was all you have to do here. So the time complexity here is what? Theta of 1. But auxiliary, but time complexity here is theta of n, right? And space complexity is theta of 1, right? Now let's try and code the solution. Let's have our header file, our using namespace. Let's have our int main, where we'll have int ar as right, n as 5, comma d as 2. Again cout before rotation. All right, write it as for int I is equal to 0, I less than n, I plus plus cout I. Cool. Okay. I did some mistake here. Alright, now it's good. Yes. Okay. And this, okay, why is this error coming here? And I let's see why this error is coming. Let's have the terminal open. See this problem. Okay. Let's write this again. All right. I guess I didn't put the array thing here, right? Now I guess, yeah, now it is solved. Good. Now what we are going to do is derotate. We'll name a function derotate. We'll have int arr, int n, and we'll have int d. All right, and let's have cout ended here. Now we'll write cout after rotation. We are going to again, run our loop from I0 I plus, and we are again going to simply cout our arr I. Alright, so this was the basic main function. Now let's write our void d rotate int arr, int n, int t. Alright, now we have to solve this thing. So what did I tell you? We have to first reverse reverse our array from 0 to d minus 1. Then we have to reverse our array from d till n minus 1, and then we'll just simply reverse our array from 0 to n minus 1, right? Now what we are going to do here is we are going to have a function void reverse. We are going to have int arr, we are going to have int low. This is a reverse function which I already told you, but since this question needs it, we are going to make a reverse function. Right, what we're going to do here is we're just going to simply swap arr low with arr high, and we're going to do low plus plus and high minus minus, right? What is the, why is this error coming here? And okay, 1 minute. Yeah, now there should be no error. Let's see. All right, yeah. Okay, I have already told there's a swap function present already here. Okay, there's also reverse function, right? Okay, what we're going to do is we are going to name it reverse, right? And we are going to name it reverse. Cool. All right, this is not correct. I did few basic errors here. So these things also happen sometimes, right? These things might happen with you also, but okay, bear with me. So yeah, now the code is correct, right? So let me tell you again what we did here is we have our main function. All right, we have now a derotate function. So what we do here is we reverse it from 0 to d minus 1. Right, let's do it here. What we are going to do is we are going to reverse this part, right? Then we are going to reverse d to n minus 1, meaning from here to here, and then this we will achieve this thing. And then what we are going to do here is we are just going to simply reverse the whole array. Yeah, which means we are going to simply reverse the whole array, which means 3, 4, 5, and 2. All right, and we have written the reverse function where you can write a swap function on your own, or if you have included the bit header file, the swap function comes along with it. So let's save this thing and try to run it. What do it was not declared in the scope. Okay. Oh, all right. We have to, have it here. Right. Now let's try and run it. All right. Give me 2 minutes. Let's now run it so you can have a better view. See, before rotation it is 1, 2, 3, 4, 5, and after rotation it is 3, 4, 5, and 2. 3, 4, 5, and 2. Yeah, that is the correct output. Right. So yeah, that's it. So that was the whole code. Right. So here also we discussed two approaches how to solve this. The first approach was, taking theta in space, theta d space, and another approach was taking theta 1 space. So the efficient approach was the second one. The second one had some observational algorithm where we observed from the example, like how we can do this thing, and then we did it. All right. So I am like, it is fine if you couldn't find the efficient approach, but now you know that there is an observational algorithm also, which you can, um, apply now in the further questions in the series. And yeah, that's it for this video, and I hope you got the key concepts from it. And yeah, that's it for this video, and see you next time. Hello everyone. So today we are going to look at another problem in our array series, which is a maximum difference problem. So first let's talk about the details, like what is the question exactly. So the question exactly is that we have to find the maximum of array j minus array I, where j is always greater than I. Meaning we have to find the maximum difference of two elements, where the first element would be at an index greater than the second element. All right. So suppose, let's take this example. Here, if you observe, you can see that the maximum difference which will occur here would be 10 minus 2, which is 8, right? And here the maximum difference which can be is 9 minus 7, which is 2. And here it would be 30 minus 10, which is 20. Okay. So first let's talk about nice solution first, right? So here is a nice solution. All right. So what we are doing here is exactly is we are storing the maximum difference in our variable res. Right. First we have initialized it as first element minus second element. It can be negative. That is not an issue. All right. Then what we are going to do is we are using two loops.
Alright, so what we are doing here exactly is, for this index I, we are having j from I plus 1 till n minus 1, and we are like subtracting array j minus array I. So we will do 3 minus 2, 10 minus 2, 6 minus 2, 4 minus 2, 8 minus 2, 1 minus 2. And what we are going to do is, we are going to update our result as maximum of result or array j or minus array I. Alright. For suppose in our first case, our result is what? Our result is array 1 minus array 0, which is 1. Okay. Now what we are going to do is, we are initialized I as 0, which is here, and initialize j as I plus 1, which is here. So res would be first of all what? 3 minus greatest of 1 and 3 minus 2, so it is 1, right? Now j would come at 10. Now the greater would be what? We have to find the greatest of these two, which is what? 8. So 8, rs would be updated to 8. So this is how the function would work. After j comes here, the loop will end. Raise it a bit. Alright. Yeah. Now what will happen? We'll push I here and we'll run it. We'll run j from I plus 1 till n minus 1. Similarly, we'll do in this thing and this thing. Right. So that's what we have written in this code. Now, calculate the time complexity of this. Since this is our first loop, this is our second loop, and these are nested loop, our time complexity is going to be big O of n square, right? So we have discussed about a solution which takes big O of n square. Now you may pause the video for 2 minutes and think of a better solution, the one which we can handle in big O of n time. Alright. Now, since you may have given a thought about it, let me discuss a little bit how you can solve it. So, in one pass, how are you going to solve it? See, we'll have a variable res which will store our maximum difference. So initially we'll initialize it as array 1 minus array 0. Now since we have to do it in one pass, we are going to maintain a variable min val mv. Initially it would be what? Array 0. Alright. It is going to be array 0. Okay. Now what we are going to do is, we are going to have a loop which will run from I is equal to 1 till this point. And what we are going to do is, exactly what we are going to do is, we are going to have maximum of either res, right, or ri minus min val, right. See, when will the maximum difference occur? When we have the greatest number which we can have through this thing in the first loop, in the first first iteration, in a single loop basically, right? And we'll have a minimum value which we'll keep in check every time. So first we'll do this, And then what we are going to do is we are going to update minimum value also. Minimum value would be minimum of MV or RI. This is RI. Alright. So this is what we are going to do here. Okay. Now let's have a dry run. At this condition, R is what? 1. Minimum value is what? 2. Okay. We can have another thing. Let's take the example 2 parts. We will understand it better. Here, what is our res? Res first of all is 2. Cool. And our minimum val is 7 at first case. Now we'll run I from 1, which won't affect much. Now I will become 2. What we are going to do is we are going to subtract 5 minus 7, which is minus 2. So maximum of either 2 or minus 2. 2. So res would still be 2. But minimum value now would become 5 because 5 is less than 7. Now I will come here at 6. What we are going to do, we are going to have maximum of either res, which is 2, or AI, which is 6 minus minimum value, which is 5 1. So obviously 2 is greater, so R would still remain. Yeah, R would still remain 2. M would still remain 5 because MV is what? Minimum of MV or RI, right? Now we'll come to this thing. Maximum of either res, which is 2, or 3 minus 5, which is minus 2. Obviously 2 is greater, so we'll still have res as 2. But our minimum would become 3, right? Now we'll come here, we'll again see R would be 2, but minimum would become 2. Now we'll come out of the loop. R is going to be 2 and surround is going to be 2. Alright, so this was the efficient solution which would take time of theta or big O of n. Okay, now let's code this thing. Okay, let's first of all add header file, then let's have std, let's have a main function where we have int ar as, let's take a first example, 2 3 10 6 4 8 1. 2 3 10 6 4 8 1. Alright, and let's have n as, what is the size of this? 1 2 3 4 5 6 7. Now let's simply see out max def yara comma n. Okay, easy question. Now let's have max def function which will have yara comma size of it. What we are going to do, we are going to have a res variable which will initially have value of as yara 1 minus yara 0, and we'll have a minimum value which is going to have value of yara 0. Right. Now we'll have a loop from so we are going to have this loop. We're going to do two work here. First, we're going to update res as either max of either res or array I minus MB. Cool. and MV would become either min of MV, comma ARRI. And in the end, what we're going to do, we're just simply going to return our res. All right. So this is all we have to do here. Okay. Now let's try and run this code. So for it, all right. See, our output is 8. Now let's try it with another example, which is 79563.2. Okay. It is 7, 9, 5, 6, 3, 2. Our n would become 1, 2, 3, 4, 5, 6. Okay. Now let's erase this thing. Now let's try. Okay. Output is 2, which is our desired output. And let's do the third example also, just to verify it once more. Let 10, 20, 30, right? Output should be 20. Output is 20, right? So yes, this was all for this video in the maximum distance problem, where we discussed two approaches for the same question. One was taking big O of n square, another was taking big O of n. Right. So I guess you understood like how you can solve this question, right? And yeah, that's it for this video, and see you later. Thank you. Hello everyone. So today we are going to look at another problem in our array series, which is called maximum consecutive ones. Pay heed to this problem because this is a very common and very popular interview problem, alright, which comes in coding round. So let's talk about the description of this problem. So basically what this problem asks is basically you are given a Boolean array which contains 0 and 1 only, right? And there can be like many ones in it, right? And there can be like many consecutive ones, and there could be a 0 between them, and then there could be like a series of 1, and then there could be a 0. So what you have to tell is that the maximum ones in that array, for suppose in a first uh, example, there are there's this series of ones, then there's this series of ones, right? Then there's a breakage, then there's a series, and there's a breakage, right? So you have to tell me the maximum consecutive ones. See here, how many ones are there? 2. And here, how many ones are there? 3. So maximum consecutive ones is obviously going to be 3. And the output is 3. Similarly, in this case, this is the corner case where all the numbers of an array are is 1. So what would be the output? 4, right? And in this part, there is also corner case where there is no 1, right? All are zeros. So what would be the output? Simply 0, right? So this is basically, this is, my bad, yeah. So, okay, let's do this. Okay, so this is basically what we have to do in this question, alright. So, you can like think of two approaches, alright. What you can do is, in a live solution, what you can do is, with every element, like suppose for this element, you can have another loop which will run from this element till here, and you will count the maximum ones it can find. Right. Suppose for this element it is 0. Since this element is 0, we won't consider this. Now we'll come here. This element is 1. Now we'll have another iterator I, a j, which will run from this part till this part. Let me clear a bit. Okay, yeah. We have one iterator I here. Since array I is 1, we'll have another iterator j which will run from I plus 1 till this part. Alright. Now we'll run this loop till n, and we'll increase the count if we find 1. Like here we found 1, right? But here since we found 0, we'll just break out of the loop using break. Alright, I've not written the nice solution because I want you guys to try and run and try to execute this nice solution so you can get a better grip on this thing. Right. Now you come to this thing, you find that this number is 0, so you won't have a j loop. Now we'll come here, you'll see that 1 is what? 1 is like this element is 1, so you will run a loop for I plus 1, that means from here till here. So for every one you're going to increment, and at this point you'll just break the loop, right? So this is the basic solution, nice solution. In this you will use two loops, one of I, one of j, and these would be nested loops. So the time complexity would be big O of n square, right? Now pause the video and try and think of a solution which can be done in big O of n time. Okay, redo. Okay, my bad. Yeah, sorry for that. Right. So let's talk about the efficient approach. So what we are going to do here is we are going to have two variables. One is res, one is curl. So what we are going to do here is we are going to run loop from first element till last element. And what we are going to do here is that if we find element as 0, we'll put cur as 0. We'll reset the value of cur. Initially cur is going to be 0, res is also going to be 0. And if we find a number like a 1, we'll increase our cur. Alright, what we are going to do is we are going to do this thing. Right. And what we are going to do is we are going to have res as max of res add cur. Like every time we find a 1, we are going to do this thing. So here we found a 1, we increased cur is 1. Now maximum of res and cur is cur obviously, so our res also becomes 1. Now we come here, cur becomes 2, res also becomes 2. Now we come here. As soon as we encounter a 0, what we are going to do, we are going to reset the value of cur. Now cur becomes 0. Now we will come here. We found a 1, our cur becomes 1. Now we check res is equal to max of either 2 and 1, which is 2, so res is still 2. We'll come here, this will become 2, res will become max of 2 and 2, which is 2. Now this will come here, cur will become 3. Now res would become 3. Now we would come here, so our cur would become 0. See, that's it, right? So this was, the efficient approach. Okay, and Let's try and code this step. Okay. Let's open. Visual Studio Code. Let's include header file, user namespace std. We have int main. Let's have int array. Okay. Add our initial one 0 1 1 0 triple 1 0. Right. 0 1 1 0 triple 1 0. Okay. Let's then have how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay. Let's name our variable as count1. We're going to have ARR and M. Let's return this. Okay. Now let's make our int count1 function. So we'll have int ARR and size of it. What did I tell you? We'll have two variables. There is 0, Kara 0. We will run a loop for int I is equal to 0, I less than n, I plus plus. Now what did I tell you? If A R R I, alright, yeah, if A R R I is equal to 0, what we are going to do? We are going to have curl value as 0. Else, what we are going to have here is we are going to increase curl value and we are going to have res as max of res or curl. Okay. And then we are just going to simply return res, right? So that was all for this code. Let's try and run it. Three, that is our divide output. Let's check it for corner cases as well. Let's have it 1, 1, 1, 1. And we'll have n as 4. Now let's run it. 4, right? That is our divide solution. Let's 0, 0, 0. So that's 3 standard 0. Yeah, so that is our desired output. So yeah, that was all for this question. We again discussed two solutions, one taking big O of n square time and one taking big O of n time. And this is a very popular yet easy interview question. Alright, so you may be like prepared for such questions also. Alright. So yeah, that's it for this video and see you later. Thank you. Hello everyone. So today we are going to look at another problem in our array series called frequencies sorted array. So what this question asks is basically what are the details of this question says we are given an array with the elements are in sorted order. Okay, like 10, 10, 10, 20, 20, 30. Alright. Now what we have to do is we have to, tell the frequency of every element. Suppose here there are 3 tens, so first 10 and its frequency. 20 has 2 elements, its frequency is 2, so 20 and 2. 30 has a single element, 30 and 1. Alright, let's see the other example where all the elements are same. So we'll just count the numbers 1, 2, 3, 4, up to 10 and 4. Here all the elements are distinct. So the output is going to be 10, 1, 21, 31. Alright, cool. Now this is what you have to print here. Now the biggest question which comes in your mind, it would be how to like do this. Like the you must have get the basic idea that how can you solve this thing, right? But the biggest thing is the implementation. So see, the basic idea would be what? That you run a loop from this element and this element, and you see that while array I is equal to array I minus 1, you will increase the frequency, and as soon as it is not equal to, you just see out the frequency, and then you look for another thing, another array, still I comes, I reach here. Okay. So that would be the basic idea. You might have like figured it out. But the thing is that such questions have a little tricky implementation. Like you must have like uh, figured out what to write, but you don't. But you get stuck up in the implementation. Okay. So with these things in your mind, you may like pause this video for 2 or 3 minutes, and you might want to try the code, want to write the code on your own. And if you get stuck up, uh, you'll see like I'll obviously with the coding parts you can see that. Okay. So now let's jump to coding part. Let's add header file here. We have using name space std. Let's have our main function here. Let's have our intervals 10, 10, 10, 20, 20, 30. N is equal to 6. Let's write the sprint freak array content. Now let's make a function print freak. Let's pass the arguments here. Let's have a size. Alright. So we'll have a variable frequency which will have the which will keep the count of frequency. And now we'll have an iterator as 1. Now while I so while wondering why did I restart we are starting at from 1 is because what we're going to do here is we're going to start our iterator from this point and we'll go to here and we'll check that if array I is equal to array I minus 1. Alright. So that's why we are doing that. Value I from I is equal to 1. So this is we are going to do. Another thing we are going to do is that while I is less than n and I till r I minus 1 is equal to r I, we will do two things. We will increase the what? We will increase the frequency, right? And we will obviously increase the I. So in this case, let's do this thing. First I is here, right? So frequency initially is what? 1. we see this is equal to this, frequency becomes 2, r I comes here, right? Now we see that this element is equal to this element of frequency becomes 3. Now Ri becomes here, and it is not equal to this, so we'll come out of this loop. Alright, now we'll write the frequency for the data 10. Right. So we are going to do here is I'm going to simply see out and this one, and then frequency, and then right, space. Now what we are doing here is C. Now what we do here is we have to now find the frequency for this, so we will reset the frequency. So our new frequency now becomes what? 1. Now element becomes 9. Because as we reset the frequency to 1, we are already having the first appearance. So we just ignore this and we jump to 1. So yeah, this is what we're doing there. Okay, and we check this again. We see that area I multiplied by minus 1, frequency becomes 2, and comes to here. And so what would be the frequency here? It is going to be what? 2. Right. So now we just have to change the frequency. So yeah, that was all for this code. Right. Let's try and run this thing. Okay, right. We are missing one thing here. Okay, that is while I was less than 1 log apart. See, I will come here. Right now, what will happen that I will go to this part. Right. So what we have to do here is that suppose, so this is a corner case basically, when we have last element as only a single frequency. Alright, what will happen is we have to have a mode cout, so it will be array minus 1. Okay. So and minus 1. Okay. Now try and run this code. Yes, the output is correct now. Right. So yeah, this was all for this video where we talked about like how to find the frequency of elements in a sorted array, right? Where the idea was very simple, but the implementation was a little bit tricky. So yeah, that was all for this video, and see you later. Thank you.
Hello everyone. So today we are going to look at another problem in our array series, which is the problem is called maximum sum subarray. So what we have to do here is we have to find the maximum sum of a subarray. So what do I mean by subarray? Means any part of our array which contains one or more elements. This can be a subarray, only -2. -3 can be a subarray. 4 minus 1 can be subarray. -2, 1, 5 can be a subarray. -2, 1, 5, -3 can be a subarray. So this is what we mean by subarray. Alright. We have to find the maximum sum of our subarray. What can be our array subarrays? -2, -3, sum is what? -5. It can be these three terms or can be a subarray. It is what? -1. And these three terms can be a subarray. The sum would be 0. So similarly, we have to find a subarray whose sum is maximum. Alright. So in this case, what would be our maximum sum subarray? This, right? What is this? 5, 6, 10, -2, -1, 7. Okay, our output is going to be 7. In any other case, the maximum subarray would be, the sum of our subarray would be less. Alright. Now the question arises how to solve this question. So we have an algorithm for such question. Here the algorithm's name is cadence algorithm. Alright, so in this algorithm what we do is that for every element we find out maximum sum of subarray which must end with this element, and our overall result is going to be the maximum of these values. Alright, so what I mean is, to see this is our array, so what we are going to do is we are going to traverse element from here to here, right? And for every element we are going to have two options. Either we are going to have this element, we are going to include this element in the previous subarray which is already going on, or we are going to have a new subarray which will begin from this element. Okay, so suppose here, what would be the subarray maximum subarray sum for this element? It is going to be -2 only, right? For this element, this has two options. Either it will join this -2 and will become -5, or it can be a new subarray element. So it would be obviously a new subarray element. Our output is going to be what? -3. This element have two choices. Either this element or having some of previous element. So this is going to have element of its own, right? Now we have this element. Either we can have -1 or we can have 4 -1, that is 3, right? So 3. Here also what would happen? We have two choices, right? So the two choices here is -2 or um, have some from here till here, which is what? 1, right? Now if we come here, it can be either 1 or 1 plus 1, 2. So obviously we'll have 2. Now here, what would be the value? The value would be either 5 or 2 plus 5, 7. What would be the value here? Or value would be 4, right? the maximum of these elements, the maximum of these result would be our output. So this is going to be our output, right? So this was, the basic coding of like basic algorithm of cadence algorithm. Now you must like pause this video and write a function which will take an input array and size of it and return the maximum sum of the sub array. Okay, now let's begin our coding part here. Let's add header file. Alright, let's have int array as, let's see the element here, it is -2, -3, 4, -2, -3, 4, -1, -2, -1, -2, 1, 5, -3. Alright, let's have size as how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 8. Alright, now just simply see out max sum ar comma n int max sum int ar comma int n. Alright, now this is the main coding part which will happen. Alright, so what did I tell you? We are going to have for final result, we are having it as r0. Alright, and we'll have an intermediate result int max ending, which is also going to be r0 right now. Now what we're going to do is we are going to run a loop from I is equal to 1, I less than n, I plus plus. Max ending is going to be max of arr I, comma max ending plus arr I. Alright, and this is just going to be the max of either res or max ending. So what we're doing here is that these values which are coming -2, -3, -4, -2, -3, 4, 3, 1, 2, and 4. This is our max ending value. Alright, what we're doing is suppose at 4. Max ending is going to be the maximum of this element or maximum of max ending plus this element. That means -3 plus 4, which is going to be 1. So obviously 4 is greater, and before that res is -3, so obviously res would also change here. Alright, so this was a very basic and easy code. Now just return res. Well, let's just save this code and yes, run it, right? Okay, I guess we're having some error here or something. We are returning res here, we are having it as at int, and in the end we are having cout max sum ar and n, right? So there's no problem. Let's try and run it again. All right, so there is some problem with my compiler right here. So, but the code is absolutely right. Oh, okay, wait a minute. There's not a problem with my compiler. There was problem in the code. All right. Now let's run this thing. See, 7, right? Yeah. So, yes, so this was a question of maximum sum subarray where we used cadence algorithm, right? And we solved it. And in another video, what I'm going to do is I'm going to have a question of Geeks for Geeks. That is a very great site. There you'll be solve your like first interview environment question, which would be based on cadence algorithm. All right. So we'll see it there, and I'll tell you more about like Geeks for Geeks environment IDE environment. And yeah, that's it for this video, and see you later. Thank you. Hello everyone. So as I mentioned in the last video that in this video we're going to solve a question on Geeks for Geek site where you will get the real interview coding environment, like how you have to solve questions in your coding rounds especially. So this is how we do it, and like we discussed a very special and very important algorithm, cadence algorithm, in the last video. So similarly in this video also we are going to do the same thing. All right. So this question is longest subarray of even and odds. All right. So this is a medium level question. So let's first of all let's read the details of this question. So the question says that you're given an array of size n, and we have to find the maximum possible length of a subarray such that its elements are arranged alternately either as even and odd or odd and even. Alright. Now the example is size of our array is 5 and our array is 10, 12, 14, 7, 8. So the output would be 3 because see the maximum subarray of even and odds could be the last 3 terms. This is even, this is odd, this is even. Alright, and in between there is no, like, you cannot have any other subarray of even or odd, so it should be longer than 3. Similarly, in this example, this is a corner case. The array contains both the elements are same, so we can only choose either one element as that will be the maximum subarray. Alright. Now, what is our task here is that we don't need to take any input. We have to just complete the function of max, even, odd that returns the maximum length. So here there are two things. There are two driver code. See, let's open this driver code. See, it includes our header file. It includes our using namespace std. All right, let's open this header file. So here, like, this is our int main function where we do the like how the our max even odd function will be called and stuff. All right. So what we have to do is we have to just complete this function which has like input which has uh, parameters as array and its size. And what we have to return, we have to return the maximum uh, array length of even and odds. Right. Now I gave you a hint in the previous video that this video is going to be based on cadence algorithm. So you may like pause this video for 2 or 3 minutes, might try to think of the code, and after that you can like implement it and see if your code runs or not. All right. Okay, now let me tell you how to do this question. Let's take this array. All right. Let's have a little gap here everywhere. All right. So similarly, what we are going to do is we are going to run a loop from here till here, and at every element, okay, we'll like not consider this element, we'll start the value from here. So everywhere there is going to be a value. Either we'll include this element in our previous subarray, or we'll start a new subarray from here. So what we are going to see, this element is even, so we'll check if the previous element is odd or even. It's even, right? So value would be 1 here also for the first element. Every time the value is going to be all right. Now in this element is also even, so the value is going to be 1. Now this element is what? Odd, and its previous element is even, so this is going to be 2. Now this element is even and its previous element is odd, so it is just going to have increase of 1, right? So it is going to be 3. So this is our current values of every element, of sub-array values of every element, and we have to find the maximum of it, and this is max. Right, so this is the max of it. Now this is, the basic, no, I mean, you know the cadence algorithm, so this is just how to, implement the cadence algorithm in this question. Now you may write the code on your own. All right, and see the question number is like, just write GFD 23, and the expression will arrive, and try to complete the function max even out on your own. All right. So let me complete this function for you. We'll have two variables. One is res, one is going to be cur. So these values 1, 1, 1, 2, 3, these are, we are going to store this in cur. Now, and the maximum of these values is going to be stored in res. Alright, so for the first element, we are not going to consider this element, so our res is also going to be 1 and our cur is also going to be 1. Okay. Now what I'm going to say is that if array I %2 is equal to 0 and array I minus 1 %2 is not equal to 0, and array I %2 not equal to 0, okay, let's write it in a bracket, yeah, and what array I %2 is equal to is not equal to 0, and array I minus 1 %2 is equal to 0. What we're going to do is we are going to have our curve increased, and res is going to be max of res and curve. Okay, what we have written here in this condition is that if our current element is even and our previous element is odd, then we are going to increase curve, right? Because it would be alternate. And in the odd condition, we have written if our element is odd and its previous element is even, which also satisfies our condition of alternate. So in both the cases, we are going to increase the current, and in the rest, we are going to have the maximum res and current. Suppose this is not the case. If our element is even and its previous element is also even, or if our element is odd and its previous element is also odd, what we are going to do? We are going to have a new subarray from this element. So our curve will become 1, right? Easy. And now what we are going to do simply is we're just going to return res. Okay. Now let's try and compile this code. There's some problem here. Okay, I did a major. I didn't add the for loop here. My bad here. Okay. Now let's compile and run. Let's see if it works. Okay, our output is 3 and our expected output is also 3. Let's try and submit this code. Okay, yeah, so problem solved successfully. Okay, so yeah, this was all for this video. Here we have like did another example on cadence algorithm. Since I have solved 2 problems on it, you can like deduce yourself that how important this cadence algorithm is, right? And second thing is like you also learned how to solve problems on Geeks for Geeks. Try solving other easy problems or like the problems which you solved previously. And this was like the coding environment which you'll have in your interview rounds. You'll be like given the details of the question, some examples. Also one thing, you are given the expected time complexity and expected auxiliary space, right? And you are be given your task. If your expected time complexity was of n, and we did the same thing. We did it in only one single loop. Okay. So yeah, what I was saying, this was like this is the like real coding interview environment, and you will be given like a function to complete and not write the full into main code. So here, try and solve more questions on GFG, which we did previously in this series. And that's it for this video. And see you later. Bye. Hello everyone. So today we are going to look at another algorithm in our array series called window sliding technique. Alright, this is a very popular algorithm asked in many interview problems. Alright, so this video is going to be very important. Alright, now we look at a problem based on this window sliding technique, and in between I'll tell you like how this technique is applied and why is it like more favorable than the like brute force approach. Okay. So the question here is maximum sum of k consecutive elements. Right. So what we have to do here is like we are given an array, we are given a k. So what we have to do is we have to find the sum of k consecutive element and get the maximum one. So the k's consecutive elements could be these three elements, these three elements, these three elements, these three elements, right? So you find the sum of every three and you'll return the maximum one. Okay. Now there are like two approaches. What we can do is we can use a for loop where I is going to be from 0 till this is part 4. Alright, now there is another one j, which is going to run from I plus 1 till j. Alright, so what this means is for this element, we are going to have this part, j will run from I plus 1 to in here, and for this is going to be I minus k. Okay. Something is wrong here. The j part would run obviously from I plus 1 for suppose it would run for this part till what element? J is going to run for J is going to run for yeah, it is going to run for I minus k. Alright. Even like you can deduce it is going to run for this element at the end of the element, or like if the k is bigger than for like more elements. Alright. So what will the time complexity here? It is going to be big of O square. Right. So what window sliding technique does is that this technique shows how a nested loop in problems can be converted to a single for loop to reduce the time complexity. So you have to solve this question big O of n time, and for that window sliding technique is going to help us. Okay. So what happens in window sliding technique is we are going to have a variable cursor which is going to have value of first sum of first three elements. These three elements. It is going to be what 39. All right. Now what we are going to do is we are going to run a loop for I from k plus 1 till I less than n and I plus plus. All right. And what is going to happen here is we are going to have cursor as cursor plus array I minus array I minus k. So what this means is that now see our I is k plus 1. Suppose I is here. So what is going to happen is we are going to remove this element. We are going to add this element. Now sum is what? 33. But since 33 is less than 39, we are not going to change our cursor. In the next iteration, we are going to delete this element and add this part. It is 45. So obviously 45 is greater than 39. So we'll change the value here as 45. Now the next element, what would happen? We'll remove this part. We are going to add 27 here, and the sum is going to be what? 22. 22 is less than 45, obviously. So cursor would remain 45. Now I would become equal to n. We'll come out of this loop, and we are going to return this sum. This is the output here. All right. So this is what we do in window sliding technique. That means we slide the whole window we slide the whole window by the by part doesn't matter because it depends on the question. Okay. Now, like you have understood the algorithm, how this question, like how the algorithm is going to work. So yeah, you may like pause this video and try to solve and try to code the whole question. Like try to code the whole code on your own. Okay. Now let me tell you how to do this one. Okay. Increase the size a little bit. Okay. Let's add the header file in std. Let's write the main function first of all. What is our array? 1830, 1830 minus 5, 27. K is 3 and n is going to be 6. Okay. Now int yeah, so this is right. Okay. And okay, so this is basically done here. Now we are just going to simply see out ksum. Ksum is a function which will return the maximum sum of key consecutive elements. This will include AR, K, and now let's make our ksum function. It would have int ARR, int K, int N. Okay. Now we have a cursum as 0. We're going to have okay. So we have a res which will contain the resultant, and initially we are going to have it as equal to cursum. Now we are going to have a loop from k. Alright, and cursum is going to be what? Cursum plus ARRI and ARRI minus k. Okay, easy. And yes, one more thing, our res would become either of max of res or cursum. Okay, we are just going to have return res here. There's some error here, and all right, this was the error. Okay, so yes, this is the code. Let's try and run it. $67. Res is max of res and res. We are simply going to return res. Initially, res are equal to cursum, and cursum is okay. What I did wrong is this thing, right? Obviously, this is going to be k. Find the sum of its k elements. Now let's enter in this code. 45. Alright, this was the expected output, right? And yeah, this was all for this code. I hope you have understood like what window sliding technique is. And in the next video, we are going to look at another problem based on the window slide technique algorithm. And we are going to do that question on our Geeks for Geeks portal. is just where we have to like write the function and like what we did in the previous video. Okay, and yeah, that's it for this video, and I'm going to end this lecture for today and see you later. Thank you. Hello everyone. So like we discussed in the previous video about the window sliding technique. So like in the previous video also, like I told you, like we would be solving a question on geeks or geeks. So the question name is subarray with given sum. Let's first of all let's read about the details of this question. So it goes like given an unsorted array A of size n that contains only non-negative integers. All right, and then we have to find a continuous subarray which adds to a given number s. All right. In case of multiple subarrays, return the subarray which comes first on moving from left to right. All right. Now let's look at this example. It's n is equal to 5, s is equal to 12. Output is 2 and 4. So what we have to do here is we have to like return the starting index of our window and the last index of our window, and mind that this is not zero indexing, this is one indexing. See here, it is element 1, element 2, element 3, element 4 and element 5, and it is like from element 2 to element 4 our sum is equal to 12. So it is, that means 2 3 7, element 2, element 3, element 4, this equals to 7. It's like 7 plus 3 10 to 12. All right, and there's another subarray 7 and 5, 7 plus 5 12, but we have to return the first subarray which is 2 3 7. Okay, now let's look at this example. It is like 1 2 3 4 5 6 7 8 9 and 10. We have to return the s as 15. It is saying that sum of elements from first position to fifth position is 15. That means from this till this. Let's add this 2 plus 3 5, 5 plus 4, it is 9 plus 5 is equal to 14, and first element is which is 15. All right, so this is like what we have to do in this question. So you can see that the size of the window is not fixed. Okay, so that means what we have to apply here, we have to apply sliding technique. Okay, let's go with this example. Okay, let me change the numbers a bit so we can have a hang of it. Let's do this. Okay, now what we have to do, we have to make a window and we have to like keep the check of its first element and the last element of the window. All right, so here is a window, like okay, yeah. So first of all, this element would be in our window, right? A window starts from this element, obviously. So element number is what? 1. Okay. Now our target sum is 12. So 1 is obviously less than 12. So what we are going to do is we are going to expand a window, and we are going to have the start element as this. So we expanded a window. Now last element is this. Okay. Now the sum is what? 5 plus 1 6. 6 is also less than 12. So we'll again expand a window. Sum becomes what? 9. But our last element would be changed to this. 9 is still less than 12. Now what we are going to do, we are going to add this element, 9 plus 7, which is what? 16. The last element becomes this. As soon as our array becomes more than a target sum, what we are going to do, we are going to reduce the size from the starting. Okay, that means we are going to remove 1 from here. Okay, 1 minute. Like it couldn't be achieved sum, so let's write it as like this. Okay, yeah. So 5 is removed from our window, and starting is changed to 1. All right. So currently our window is 137 with starting as 1 and last element of this window is 7. The sum is 11, right? 11 here. Okay. And 11 is what? Less than 12, right? Now what we are going to do here, simply add another, expand a window, remove and change the last element. Last here comes here. Now our sum becomes 13. 13 is more than 12. What we are going to do, we are going to reduce our window from the starting. 1 is removed from here and 1 comes here. Okay. Like the starting index come here. So it's starting is last. And yeah, now the sum becomes 12. We come out of the loop. We are going to return this part. Okay. So let's try and write this thing in the code. Okay. So what do we need? First of all, we need a start, which will contain the starting index. We'll have a last, which will contain our last index, and we are going to have a flag, which will be a Boolean flag. We'll have the sum as 0. Now what we're going to do, while last is less than the last element, obviously our loop is going to run. Now what are the conditions which I told you? That one, if sum is less than our targeted sum, which is S here, right? So what will happen here? We are going to add last element. Okay. And we'll increase the last part. Okay. Next thing which I told you is, if sum is greater than S, then what we are going to do? We are going to subtract the starting array, like starting element of the array, starting element of our window, array start, right? And then we are going to have start plus plus. Okay. Next thing is, what if sum is equal to S? Then what we are going to do? We are going to change our flag to 1, obviously, and then we are going to break this thing. Okay. Now what will happen is there can be two cases. Either flag would be 0, that means we didn't find the window, and if the flag is 1, we found the window. So if we found the window, that means the flag is equal to 1. We have to okay, one more thing. See here, like it's we have to find the have to return a vector of a pair, right? We didn't add the vector here, so let's have the vector also here. Okay, subarray. All right. Now, if flag is 1, what we are going to do, we are going to push back. This I told you in starting videos about vector STL. Okay, so it is subarray push back start plus 1 because it is 0th index, and it is subarray dot push back last. Okay, and then we are just simply going to return our sub array. All right. And there can be another case also, that if flag is not equal to 1, that means we didn't find the sub array. So what we are going to do here is, since we have to return a sub array only, so we'll just add -1, right? And then we are just going to simply return our sub array. That means we're just returning a sub array with -1 in it. which means we didn't find it. See, if no such array is found, return an array consisting only one element, that is -1. Alright. So okay, let's try and run this code, see if it works. See, our output is 2, 4, expected output is also 2, 4. Let's try and submit this in. Okay, there's some segmentation fault here. Let's see what can be the fault here. All right. Let's see, like, segmentation fault is happening here, right? So while last is I'm going to run a loop, okay. Okay, and it is key while sum is less than n, sum is equal to sum plus array last, and we did last plus plus. We're saying while sum is more than s, sum is equal to sum minus array start. What we're going to do, we're going to have start plus plus. Okay. If sum is equal to s, we are changing a flag to 1 and we are doing a break. If flag is equal to 1, okay, flag is equal to 1, we are doing subarray dot pushback start plus 1, subarray dot pushback last, and we're just simply returning a subarray. Otherwise, what we're going to do here is we are going to have this thing. Alright. So I don't think we have a segmentation fault anywhere here. Let's try and submit it again. See, okay, all right. See, this might happen with you also, like you will have a segmentation fault in your code. This might be error of your compiler also, so like try and compile the code 2 or 3 times. Submit the code 2 or 3 times. Now see, in my attempt also this happened, segmentation fault occurred, but then I submitted it again without changing anything, and we got the correct output again. Okay, so okay, yeah, so let's come back to the question part. So this was all for this code, where what we did, let me brief you about it. We started from our first element, and what we did is we started making a window with having windows first element and last element. And like we are like, if the sum of the window is less than the targeted sum, we are increasing the window by increasing the by changing the last element to +1 of it. And if sum at any time becomes greater than s, what we are going to do is we are going to decrease the size of the window by changing the starting of it. So okay, yeah, so that was all for this code, and okay, yeah, that's it, and see you later. Thank you.
Hello everyone. So today we are looking at a very nice interview question, which is a very important question. And this question is known as trapping rainwater. All right. Now let's see what are the details of this question. So let's read the problem statement. So it goes like, given an array of size n non-negative integers representing the height of blocks. All right. If width of each block is 1, compute how much water can be trapped between the blocks during the rainy season. So what is happening is that water is being collected in like between the blocks after rain, and now we have to tell that how many, like we are given the height of the blocks and we have to tell the how much water would be stored. Okay, so let's see this. The height of the blocks are like this: 3 0 0 2 0 4. Output would be 10. See here, bars would be what? 3 0 0 2 0 4. Total trap water would be what? Here it would be 3. Here it would be 3. Here it would be 1. Here it would be 3. So output would be 10.
Similarly, in this case, 7409. Let's draw this one, 7409, and that would be like tell us in a better way. So this is 7, this is 4, this is 0, and yeah, cool. Okay, my bad. Somewhat like this. It is what? 7, 4, 0, 9. Okay. Now let's do one thing. Here some water would be stored, which would be this part. Here some water is going to be stored, which is going to be this part. How much water here? It is going to be 3. How much water here? This is going to be 7. So output should be 10. Okay. So now, how to solve this question? All right. Let's look at a few observational things. So what is happening here is, suppose for the 0th block, for the like second element, it is 0. Okay. What is the height of the water here? 3. And for this 0 block, what is the height of water here? It is also 3. All right. For this block, what is the height? 1. And another observational thing that is, like that is to keep kept in mind here is this block and this block won't be storing any water in them. Like for this element, second element here 0, it is storing some, third element is also storing, this element is also storing, and this element is also storing. But the first and last elements won't be storing any water because there would be no, for this there would be no right part to contain the water, and for this there would be no left part. Okay. So this was one thing. All right. Now let's look at this example. For this element, what is the water? Like what is the height of the water stored here? 3. And what is here? It is 7. Okay. An observational thing that you can see here basically is, for every element, what we are doing is we are going to remove the height of the largest part from this side, largest part from the left and from the right of that element. Okay. Okay, let's do one thing. Yeah, this was the first example. Cool. Let's talk about, let's change the color. Yeah, let's talk about this 0th element. It is starting from this side. This is the element what is stored here. This is what is stored how? Between this element and this, between the left most largest element, between the right most largest element. The water between this element is stored. Okay. And the maximum height that could go would be the minimum of the leftmost and the rightmost. Here it is 3 and here it is 4. So what is stored here would be minimum of the left largest and right largest, which is, for this element it is 3. For this element it is going to be 3. For this element also the largest would be 3. But the height of this element would be removed. Okay. So it is going to be 1, and for the here also it is going to be 3. So what did we observe here? We observed a few things. I'm going to repeat all of them. Okay. First of all, the first bar and the last bar won't be storing any water. That is like very obvious. Okay. And this block would be like storing water. Okay. And that water would be the what? Minimum of its leftmost part and rightmost part, which is here 7, minus height of its own block, which is 4. it is going to be 3. And for this block, it is going to be 7 minus height of it, 7. Output would be the addition of these two. Output is going to be 10. Okay, now we have like talked about the basic solution, like what we do here. Okay. Now, we can do one thing again. Okay. Mm, we have talked about how we are going to store the values, right? Um, but like how would you find the like left minimum of this, or like left max of this element and right max of this element? So for that, what we are going to do is we are going to make two arrays. One array would be left max, one array is going to be right max. These are going to be two arrays here. Okay. And left max would be containing the left max of all the elements. All right. Okay, one more observation which you didn't like under like you haven't like noticed would be like suppose this height would be 5. So maximum for this element is going to be 5 and what would be stored. So its left max or right max is it's both are going to be 5 and minimum would be 5 and height of this would be 5 minus 5 0. And what would be stored, so that corner case is also like done here. So left max would contain left max for the elements first element till nth element, and right max is going to be contained by this is going to second element from nth element, and this is going to first element from n minus 1. All right. Left max here of first would be the L max only. I mean the element only. What I mean is for this element, its left max is going to be the number itself. For this element, the right max would be the number itself. Okay. So we'll just like put the values. Okay. So this method is called pre-array, where we like construct an array beforehand before entering the procedure, and this like helps us in the question. Okay, so like this was the crux of the question. This question is a little bit tricky, so what I'm going to do is I'm going to write the code, and then like step by step I'm going to tell you everything bit by bit. Sounds fair? Okay, now we are just going to write the code where we have to return the result. So we'll have a value which we have to return. But I tell you, we'll make an array of size n left max. We'll make an array of size n right max. L max 0 would be what? R0, yes, and yeah, okay, yes. L max and R max n minus 1 is going to be having L n minus 1. Okay. Now we'll compute pre-array for L max for int I is equal to 1. L max I is going to be either max of R I or L max of I minus 1. Okay. And similarly for int I is equal to I is equal to, we are going to have to calculate right max, so it is going to be I minus 2, I more than equal to 0, I minus minus R max I is going to be max of R max of I plus 1. Okay. So what I did here is, okay, we'll have a dry run of this thing. So let's have the dry run for this part. Okay. We have this diagram here. Let's clear things a little bit. Take the eraser. Let's clear this part. Okay. Yes. Okay. Now let's do this. We are writing L max as LM, size of n. What is size? 1, 2, 3, 1, 2, 3, 4, 5, 6. 6 elements. L max 0 is array 0, 3. L max for this is either max of this element or L max I minus 1, which is 3 all. Okay. L max for this is also going to be 3. L max for this number is going to be either this number 2 or L max of its previous, which is 3. Okay. So we are going to have 3 again. Here L max is again like going to be 3, and L max for this element is also going to be 3. And now right max for, we have to start from the last element, right? It is like for this element we have 4. For this 0th element we'll have 4. For another element we'll have 4. For next element we'll have 4. For next element also we'll have 4, and for the next element also we'll have 4. Okay, so this is our L max array and this is our R max array. Okay. Now, what did I tell you? Like how to find the result is going to be for every element from I is equal to 1 till I n minus 2. What we're going to do is we're going to have result as result plus minimum of, for this element, minimum of its left max and right max minus this element. Okay. So we are going to write that part now, which is what? Okay, let's write it here. I'll tell you, we are going to have I is equal to 1, I less than n minus 1, I plus plus. What we're going to have is the result is equal to result plus min of L max I, R max I minus Ri. Okay, sounds right. Now we'll have just return res. Okay, now let's try and run this program, see if it works. Our output is also 10 and the expected output is also 10. Let's try and submit this code. Yeah, problem solved successfully. Okay, so let me revisit this question, like let me give you a brief of this question again. Okay, so this question goes like this. There are bars and there's like monsoon season and rain happened, and now we have to find the water stored inside like this thing. So we have to tell the amount of rain which would be stored here. Okay. So for last two elements, water won't be stored because this element won't be having a left part which will contain the water, and this part is not going to have the right part which will contain the water. But for every element in between, the water which is going to stored here is the right max of it and the left max of it and the minimum of them minus this element which we did. Alright. And this question uses the method of pre-computational arrays, which is our Lmax and Rmax. And yeah, that's it for this question. Go through this question again, try to solve it on your own again. Okay, you will understand like what trapping rainwater question actually means. All right. So yeah, that was it for this video, and see you later. Thank.
Hello everyone. So from this video onwards, we are going to start a new topic, linked list. Alright. So what are linked lists? So linked lists are basically linear or sequential data structures in which elements are stored at non-contiguous memory locations and are linked to each other using pointers. Okay. So like arrays, linked lists are also linear data structures. But as I told you before also, but that linked list elements are not stored at contiguous memory locations. Okay. They can be stored anywhere in the memory, but for sequential access, the nodes are linked to each other using pointers. Okay. Now, if you recall, I already told you that about contiguous memory locations. Suppose this is our array. Um, Suppose this is a sum of our array and there is some of its element here. Okay. And suppose the memory of this first element is 2000. Okay. Then the memory of the second element is going to be 2004. Suppose if the data types are integers and the next element memory would be 2008. That means the memories of all the elements of our arrays are basically continuous, like 2000, 2004, 2008, and etc. But this is not the case in linked list. Suppose this is one of the element of linked list. It's memory location is suppose 2000, and then there's another linked list element whose what do we say memory location is suppose 4000, and there is another memory location 6000 or something. But all these are linked. Okay, 2000 memory is linked with this one. This is linked with this one. Now you might be wondering how these um, elements are linked without having a contiguous memory locations. Okay, so let's talk about that. Let me first of all clear the screen. Okay, all right. Suppose let's talk about linked list. Like how does a linked list looks like? All right. So a linked list basically contains two parts. One is data. All right. Another is pointer. So suppose and data plus pointer consists of a linked list node. So this is a node. This is a node. This is also a node, and this is also a node. All right. Now, what happens in a node is that every node of linked list contains two elements or like two parts. One is data, right, and one is pointer. So, what is the data in a linked list? So, data inside a linked list is what we store inside it. Alright, this part basically stores the data or the value of the node information to be stored at the current node. Alright. And then is this pointer. So what a pointer of a node consists is, it consists of the memory address of the next node. Alright. Suppose the memory address of this first element is 2000, another element is 4000, another element is 6000, another element is 7000. So the pointer of this of first element would be containing memory address of this one of 4000. So this is like this is, these are linked. Here is also data and pointer. The pointer of this element would be containing a memory of 6000. These are linked. Then 6000 be containing 7000. So these are linked. Alright. This is how the linking of data works. Good. So now we talked about what are linked list and how does a linked list look like and what are its two parts. Alright. But you might be wondering like why do we need a linked list? Like array was also like nice. Why do we like what is the need of a linked list? Okay. So there are certain problems with our arrays. Okay. Now let me clear the screen a little bit. Yeah. Yeah. So I was saying that there is a problem in the arrays. These problems, let's discuss them. So the first problem is the size of the arrays is fixed. Alright. Suppose you are given a task of making um, a data sheet of a college. Alright. And like every data sheet of a student contains its personal information. And suppose the college says that it is going to take 4000 students. Alright. So you are going to make 4000 memories. But it is not necessary that 4000 admissions would come. So there would be the wastage of data. Suppose only 2000 students come. Then what? You'll be wasting the data part, right? And if you make the data of 2000 students and suppose 2500 students come, then your your data sheet would be destroyed. So, but this does not happen in our linked list because linked lists are basically dynamic. Because see, there are 2000 linked lists connected to each other, and if I want to add a new linked list, I'll just simply make a new linked list, add a data and a pointer to it, and I'll point the pointer of the last data in my original linked list to this element. Alright. And the other thing is that inserting a new element in an array is expensive. Because see, room has to be like created for the new elements. And to create room, existing elements have to shift. Suppose this is my array of like suppose 5 elements. And here are data 1, 2, 4, 5 and 6. Now if I'm given a task to insert element 3 here, what am I like what would be the procedure? I'm going to shift elements from 4 to 6 first of all and I have to make a new space. I'll shift the elements one by one from 4 to 6 here and then this space would be cleared and then I'll put 3 here. So this task is expensive, but what I can do in linked list is this is 1, this is 2, this is 3, this is 4, this is 1, this is 2 and this is suppose 4, this is 5 and this is my element 3. Now what would I do? I simply point this 4 element pointer to 3. I'll point the pointer of 3 to 5. As easy as that, right? So like this is the like main advantages of linked list over arrays. Alright. And the other thing like we discussed the advantages of arrays, advantages of linked list here. Now time to discuss the disadvantages of linked list. Okay. First of all, random access is not allowed. You have to go sequentially in a linked list, like 1, 2, 3, 4, and that. Yes, like that.
meaning you cannot use binary search and stuff in linked list, which we can use in array. Okay. And other thing is extra space for pointer is required with each element of the list. Pointer doesn't like require a lot of space, but still, if there are like 1,000 or 10,000 pointers, 10,000 elements in a list, so you need a 10,000 pointers also. So it is a big thing, right? And yeah, I guess that's it for the introductory video of linked list. And since we completed the array part, and like we concluded the array part in the last video, and yeah, that's it for this introductory video, and we'll talk more about linked list and implementation of it in the next video. Thank you for joining today, and see you later. Everyone. So today we are going to continue our linked list series, and today we are going to talk about linked list implementation. All right. So in this video, we are going to tell you like how a linked list is created and how you can like traverse. So this is going to be the first node, this is going to be the second node, and this is going to be the third node. All right. And let's see, the data of the first node is 10, data of the second node is 20, and data of the third node is 30. Now, the pointer of the first element is going to point towards the second element, and second element is going to point towards the third element, and third element pointer is going to point towards the null. N stands for null. This means the end of this linked list. And like see, a linked list contains two things: data and address. And such to form such data type, we are going to use a structure. Alright. Like you have read about structures in basic C++. Okay. Now let's begin the code. First of all, let's include our header file. Okay. Then I'm going to make a struct called node. Alright. This is going to contain a data thing, right? And it is going to contain node star. This is an interesting thing. See, data type of next is node, which is the same as the structure. So such structures are called self-referential structures. See, what is next? Next is a pointer, and it is going to point towards what? Towards another node. So the data type of this should be node. Right? Now we are going to have this thing. This is what? This is constructor of a node, right? So data is equal to x, and next is null. All right. So this is a structure. Okay. Now let's make a main function here. Oh, let me tell you, before making the main function, let me tell you the first element of every linked list is called head.
Alright, this is an important thing. But then most of the question that is just written that about like question regarding head. So you must know like what head is. It is always the first element of any linked list. Now, how to make a node? You write node star name of the element, name of the like the first element basically, and write new node and see this thing is basically constructor type. So data of head is right now x10 and the its pointer is pointing towards null. Okay. Now I can write head next is equal to new node 20. So this means that first of all, let me tell you like what happened here. We formed a node called head. Alright, and head was pointing towards what? Null. Alright, this happened in this slide. We made a new node head with data 10, and since we haven't passed any, you know, we haven't pointed the pointer towards anything, so its next is null. That's right. Now, alright, yes, here. Yeah, so this is what is written here. Now, what I did is like head next, meaning next is what? Head's pointer. So head's pointer is now pointing towards a node, a new node whose data type is 20 and whose pointer is now null. Right. So what happened here is we made another node 20 pointing towards null. We also did that pointer of a first element head points toward this element. Okay. Now what I'm going to do is simply node head next we go to new node 30. What I did here is heads next is going to point towards a new element 30 and this thing gets removed and the default constructor point is given here. Alright. So this is the linked list we have formed here. Okay. So this was what was needed here. 10 should point towards 20, 20 should point towards 30, and 30 pointer should point towards null. This is happening. 10 is pointing towards 20, 20 is pointing towards 30, and 30 is pointing towards null. Alright. Now, you might be wondering like how to traverse this linked list, right? So let's start displaying this linked list so that you can like have an idea like how to traverse a linked list. Let's write a function display, and what we are going to do is we are going to do this thing. We are going to pass head. We are going to write void display. Since we are returning like we are passing pointer head, which is here. Right. Now what I'm going to do is I'm just simply saying while okay yeah while head is not equal to null. What we are going to do, we are going to simply print head's data. Okay, see, when we pass a pointer, we are actually passing the original pointer, not the reference. So to like not change the head, what we are going to do, we are going to have a node
star cur is equal to head. Alright. So that our original head don't change. We have while cur is not equal to null, C out cur data handle C out handle and simply do this. Right? So what is happening here is cur is at this point in the beginning. What happened is that we printed 10. Cool. Then what we do is that cur is now shifted to cur next. That means cur is shifted here. Right? From there cur has been shifted to here. And after this what is happening? That after having cur here, what's going to happen is we are again going to remove this thing. We have printed 20 and now cur is pointing here. Again this will print and now cur will point here. And now we have added a condition, right? Right? Yeah, while cur is not equal to null, so since cur is null, we come out of the loop. So yeah, that is the whole code here. Let's try and run this thing. Let's hope this thing runs without any fault. Yeah, 10, 20, 30. This is the required code here. Alright. So, okay, so in this video, what we did, we talked about how to implement a simple linked list and how to traverse a simple single linked list. In the future videos, I'm going to tell you how to add a specific number in a linked list and how to delete a specific number from a linked list. Okay. So, yeah, that was it for this video and see you later. Thank you.
Hello everyone. So today we are going to look at another video in our linked list series. So before starting this new lecture, let's revise what we learned in our previous lecture. Alright. So here we have the same code which we have written in our previous lecture. So let's have a very quick recap of what we did here. See, we made a linked list node, right? I told you how to declare it, which will declare the data which you have to put in it, and second you will put another address, right, in the linked list box. Cause I told you like linked list box looks like this. Here it is data, and here it is address, right? Okay, and after that, what we did was I told you like how to declare our linked list. So we declare the first element as head and put 10 in it. Then we reference heads next to another node which is 20, and then its next node to 30, and 30 would be pointing to null. That means that would be the end. Now we told you how to display it, and you can like see the code here. Alright. Now what I want to discuss is what if I have to like insert element in our linked list. Suppose here our linked list is 10, 20, 30, and here's our linked list is 10, 20, 30, and suppose I have been given an element I as 0, right? I have to insert this element here so that a new linked list becomes 0, 10, 20, 30. Alright. How to do this thing? Alright, so take 2 minutes, think like how you can solve it, and then resume this lecture. Okay, so basically when we insert an element somewhere, what we do is we declare, we change our head itself. So our new head is going to be, suppose the function's name is insert b, that at the beginning, and suppose this I pass head and 10. Is that fine? Alright. Now here I'll make new function called insert b. Since it is going to return node, its parameter would be going to be node. It's going to be node head. That is going to be int x. Alright. What I'm going to do is I am going to make a new variable called temp, which is going to be equal to new node x, right? So after this, what we are going to do here is we are just going to change the okay, we made a new node called temp, which is having the variable x and it is like pointing towards null. Now what if I change my address, which temp is pointing to head? You're getting what I'm saying? I'm saying if I do this thing and I simply return temp. Okay, so let me tell you what I did here. Suppose this was our array, this was our head was pointing here, this was pointing to 20. Minute, yeah. So this was pointing towards 20, this was pointing towards 30, right? This was my head. Now a temp variable is, this. It's pointing towards null and it has element 0. Now what I did is instead of here I pointed our temp towards 10 instead of null, instead is pointing at null. And if I erase head from here and if I put head here, so isn't it going to be like 0, 10, 20 and 30? Yes. So this is how we'll insert the element. Alright. See, I have returned the statement head insert b 10. Now let's take this code from here and let's try to one thing. I say cout. I say before insertion I'm going to have this thing. Now my head becomes this and I say cout after insertion I'm again going to display head, right? Okay, now let's try and run this code. Let's see. See, before insertion, okay, what happened here? Oh, right, my bad. What I did is, this has to be 0. Alright, we'll try and run it again. Let's erase this thing. Yeah. Fresh start. See, 10, 20, 30 and now after insertion it's 0, 10, 20, 30. And this is the desired output. Okay. Okay. Now if I say that, yeah, from here. Now This is the new array 0, 10, 20, 30. Now what I want exactly here is want to have like 40 also here. Like it's right now this. If I want to insert this element at the end, my new array, my new linked list would look like 0, 10, 20, 30 and 40. Right. Now how to do this? Okay. First I'll write the code and tell you there line by line what I'm exactly doing, and then we'll visualize it here in the whiteboard. Alright. Now, okay, one more thing we can do is see out. Again, I'll write the same thing. Before insertion at the end, what we can do is simply comment this thing, right? Or we can just simply comment this part also, right? And this part also, right? Yeah, okay. So yes, I have written C out before insertion at the end. We are just going to display our head. Alright, I'm going to add C out. Then I'm going to change head. We are going to have head as insert E. What we are going to provide it here, head comma 40. Alright. Right now let's try and write our function. Yeah. Node start insert E. Alright. Let's have a temp node which is going to point toward head. Okay. Now what I'm going to say is, suppose if head is equal to null, then what's going to happen? Or let's do one thing. Let's change this to new node x. Right? If head is null, it's going to simply return temp. But if it is not, then let's have a node star cur as head. Alright. Now, okay, let's first talk about the idea what we're going to do here. Suppose if I get the address of this element, like I have a temp here, right? And this is pointing towards what? Null. Now instead of null, if this points toward this, this is our output. This thing would be our output. So we need to access this element. How to access this element? Let me tell you. What we're going to do is while cur next is not equal to null, what we're going to do is going to simply do this thing, right? And assume that now the cur after this whole loop, what is going to happen? Cur is going to point towards here. Now what we are going to do simply here is cur's next is going to be our temp, right? And since there is no change in head, we're just simply going to return head. Alright, now we have done this thing. Let's write cout. After insertion at the end, we're going to write display head, right? Now let's try and run this code. Yep. See, before insertion at the end, the output, our linked list was like this, year 2030, and after insertion at the end, where we inserted 40 in the end, our output is this. Alright. So basically in this video, what we learned about linked list is how to insert any element at the beginning of a linked list and how to insert any element at the end of the linked list. Right? I told you the method, like you always have to return head in both insert at the end and insert at the beginning, and also like we revised what we learned in the previous lecture. Okay, so I guess yeah, that's it for this video, and see you next time.
So in the previous lecture, what we did was we inserted elements in the starting and in the end. Now how we inserted element at the end, let's talk about that. So what we did here was we made a new node cur, which first pointed towards head, and we traverse to the last node through this loop, right? And the last node's pointer, instead of pointing towards null, we pointed it towards temp where we stored the variable. Alright, and then we just simply returned head. Right. Now in this video we are going to look at how to delete elements from the beginning and from the end of a linked list. Alright, so yeah, so if we have to do this, let's make it a little bit, yeah, our input element is 10, 20, 30, 40, our output is 20, 30, 40. That means we deleted the first element, that is 10, right? Now tell me how you can like do that. You like take a few minutes, think of the approach and tell me, and you can like after that resume this video, so you might understand like how to exactly do that. Alright, okay, so if we delete this number, like simply you can delete it, but then you cannot like have the other linked list, right? Did you understand what I just tried to say right here? Suppose this was a linked list, right? Yes. Now if I delete this element, there would be no head and our array would simply be like this. Our linked list would look like this, but we won't be having any head right here. So how to like solve this question exactly? So for this, what you can do is you can shift your head from, wait a minute, yeah, from here to here. Initially head was pointing here, but now it is pointing here, right? You can easily do that. Okay, well, let's try and write the code so you will understand, better like what we have to do here. Right? Let's yeah, we'll just erase that data. Let's do cout before deletion in let's write before deleting the first element. We will simply display. Okay, now what we are going to do here is we are just going to write cout head as delete b head cout after deleting is going to write display head again. Now let's write the code of node star display, right? Okay, there are few things. There are corner cases. Suppose if head is null, what are we going to do? Return null. And if head next is equal to null, then also we are going to return null because we are going to delete the head, then there will be no element left in the linked list. So answer would be null. Another thing which you can do here is your new head becomes head next, right? And you will simply do what? Return head. Alright. Well, this is now let's try and run this code. See, before deleting the first element, our array would look like this, 10, 20, 30, 40, but after deleting it looks like this. And this is our desired output. Okay. Now suppose we have to delete the element in the end. If input looks like 10, 20, 30, 40, our output should look like 10, 20, 30. So how to do this question, like this thing? So what you can do is, always if you have to do something in the end, you should be having access of this element, like second last or last. Alright, so if we access this element and if we change its next address, which is pointing here, and instead of here, if it points towards null, we would get a solution, right? Let's try and run that. What we did was, so we just simply cout deleting the next element, right? It is like say before deleting the last element, we'll simply display head, right? And we'll delete the last element through this function delete end, and let's see after deleting. Now we'll display head. Right. Now let's make function node star delete e. Right. So how you do that? So you'll have a new node called curve. Should be having same address as head. And I'm going to write while curve next not equal to null. So we have curve is equal to curve next. So after this loop, what would be curve pointing to? Curve would be pointing to element whose curve would be pointing to element whose next element would be null. Right? So that if we look at 30, its next element is null. Right? So curve would be pointing towards 30. Is that right? Yes. Now since we have 30, we just have to change its next to null. Right? So we'll just write curve next is equal to null, right? And this we are going to simply return head. Now let's try and run this code. Let's see this thing. Yeah, let's try and run this code. See, before deleting the last element, like our linked list was this 10, 20, 30, 40, but after deleting it's 10, 20, 30, and the last element is deleted, right? And that is our side output. So I hope you learned the concept of how to delete elements from a linked list, right? And I guess yeah, that's it for this video. See you in the next one. Hello everyone. So I welcome you all to this new lecture of the linked list series. And so today we are going to start a new topic in linked list called W linked list. So in some of the previous videos, we looked at introduction to linked list and we looked at singly linked list, and we also talked about some basic operations that we do in linked list like insertion and delete, and how to declare a singly linked list. Alright. Now today we are going to start a new topic called W linked list. Okay. So first let me tell you what is a W linked list. Alright. So suppose if these are datas of a singly linked list, what would it be like? 10 would be pointing to 20, 20 would be pointing to 30, and 30 would be pointing towards null. Am I right? This would be the case. Okay, so what happens in W linked list is that 20 points towards 30 as well as point towards 10 also. 30 points towards null as well as point towards 20 also. Alright. And 10 also points toward null. Alright. So in a single linked list, we have a single relation between the elements which always go like this, right? But in a doubly linked list, we have two-way relation. One is like in this direction, second is in like this direction. Yes. So this is what we call as a doubly linked list. Alright. So let's talk about the implementation, like how to implement this code. Okay. Alright. Let's try and implement our doubly linked list. So let's add our header file here. Let's make our linked list structure. Let's name it as node. It will have a data, right? It will have a node called next. Right. This same declaration was there in singly linked list, right? So what is the new data? That 20 would also point towards 10. So for that we are going to have one more node called previous. Is that right? Alright. Now let's make constructor for this structure. We'll have next as null. We'll have previous also null. We'll have data as x. Right? Okay. That's good. Now let's write our main function here. Let's have node head. Let's have it as new node 10. Right? Now let's have another node called temp1, just pointing towards 20. Then we have another node temp2, new node 30. Alright. Now what we are going to say that head next is going to point towards temp1. Alright. And temp1 next is going to point towards temp2. Temp1 previous is going to point towards head. Alright. And temp2 previous is going to point towards temp1. Alright. Yeah, so that was the implementation of a basic doubly linked list. So the linked list looks like this. Here we have head, here we have temp1, and here we have temp2. Data in our head is what? 10. Data in our temp1 is what? 20. And data in our temp3 is what? Temp2 is what? 30. So I said, according to constructor, heads previous is going to point toward what? Null. And then we change heads next to pointing towards temp1. We also change temps1 next to pointing towards temp2. Since we didn't make any change in temps2 next, it is going to point towards null. Right. We also said temps1 previous to change to head, and temps2 previous change towards temp1. Right. So this whole thing is same as this which you wanted to implement, right? So this is basically how you implement a doubly linked list. All right. Now let's talk about the advantages which we can use here. Give me a minute. Yeah.
Alright, so like if we compare a doubly linked list with a single linked list, what are the advantages of a doubly linked list? Like why do we use it? First of all, it can be traversed in both the directions. Okay, so that means can be traversed in both the directions, right? What is the second step? In a single linked list, you can always insert or delete an element. Like if we have a given node, we can insert or delete element after the node, right? But here we can insert or delete before a given node. We can do both. Yes. Let's make it in. Alright. And what else? Yeah, that would be like the broad advantages, right? Okay, that's cool. Now let's talk about disadvantages here. Alright. Can the most common disadvantage that must be coming in your mind is that it makes the code complex, right? So code becomes complex because see, on a personal level, I'm saying when you work with linked lists, code tends to get complex because you have to work with pointers. Okay, in a single linked list also, but in a doubly linked list, you have to take care of another pointer called previous. And while working in a linked list, it's already complex and introducing a new pointer makes it more complex. So the biggest advantage of W linked list is it makes the code complex. Now the second point would be that your pointer that is prev, it requires extra space. So more memory allocation to be provided, so that is also a disadvantage here. Alright, so okay, let's do this. Cool. So yeah, so I guess I gave you a broad idea of what is a doubly linked list, how to implement it, and we also talked about advantages and disadvantages of a doubly linked list. So in the upcoming videos, we are going to look at the basic operations of a doubly linked list as we saw in singly linked list. That would be insert at the beginning, at the end, and delete at the beginning, at the end. Alright. So I guess that was it for this video. And see you next time. Thank you. So hello everyone. So in the last lecture, we saw introduction to doubly linked list. First of all, let's talk about what we learned in the previous video and revise it. Okay. So yeah, alright. So in the previous video, what we did, we made a linked list with 3 nodes whose data were 10, 20 and 30, right? Now what we did was, suppose this initially our linked list was 10, 20, 30. So what we did here was that head next would be equal to temp1, that means this thing, right? Temp next is going to be temp2, that means this, right? And temp1 previous is going to be head, that means this, and temp2 previous is going to be temp1. So this was the linked list. This is the linked list, right? It is a two-way relationship, you can see, right? So we understood like how to create a basic doubly linked list in C++, right? And in this video, we are going to learn insertion in a doubly linked list. We have seen insertion in a singly linked list in one of
the previous videos. So in this video we are going to see insertion in a W linked list. All right. So suppose we have to insert 0 here. So output would look something like this. Yeah. Now the question is how to make this thing. Take 10 minutes, take 5 minutes, and try to come up with this solution. Otherwise, you can continue watching this video. Right. Okay. Now here, let's make a node temp, which will be having new node value that is 0. All right. What do I do with it? Let's make a function for it. That would be better. Let's go ahead insert b, and now we're going to have it node. We are going to pass head and the number. Right. Let's make the function node star insert b. Node star head comma index. Alright. Have the variable temp as new node x. Alright. But we know if this has to be the first node, what we are going to have? We are going to have temps next as head, right? And we are going to have head previous as temp, and we are going to return temp, and this is going to be head is equal to constant p. I see we haven't made display function, so let's make the display function as well. It is going to be node star head, right? Let's have node star curve equal to head. Then say y curve not equal to null. We are going to have cout curve data and what else? Yeah, just move go forward. Yeah, that's fine. That's good. Okay. And okay, so we did this thing. Let's have it like we did in the previous singly linked list video. Before insertion, I'm going to write display head, right? And here also we are going to say display head, and one more line that would be cout after insertion. Okay. Now let's try and run this. There's one more thing. We have to have this here. Okay. Now let's try and run this thing. See, before insertion it is look like 10, 20, 30, right? And after insertion it will be like 0, 10, 20 and 30. Okay, that's good. So get desired output. Now let's do one thing. Yeah, let's comment these out, and let's have another one. Well, first let's talk about it. See, we have to now talk about insertion in the end. Linked list here looks like this. Right? We have to insert an element 40 in the end of the linked list, so that this looks like this. Okay. The rest things will look the same. Right? Now, how to do this thing? Okay, you may take your time, think about it, ponder on it, and come up with a solution. Otherwise, you can continue watching this video. So here, what we're going to do here is okay. Let's have one thing. Let's write C out before insertion. Okay. So to display head. Yeah. We are going to have insert E somewhere. We have head and let's write 40. We'll write C out. After insertion, we are going to have display head again. Alright? Yeah, good. Now let's write our display insert E function. Okay. That's right. Now let's have our temp variable, which is going to store x. Yeah. Now, remember what did I tell you in this singly linked list video, that we are going to access this last element, right? And how will we access this last element? We run a loop, and this element would be, suppose cur is the iterator here. So what will happen, that this element would be when cur's next would be null, right? So let's have that thing, that let's make another node cur is equal to head, and we write while cur's next is not equal to null. What is going to happen? That cur would become cur next. That is it. Alright. Now, after when this loop would be over, our cur would be here. Yeah, cur would be 30. Now, what we have to do? We have a temp as 40. What we're just going to simply do, that cur's next is going to point towards this, and temp's view is going to point towards 30. That is what we require. So let's write that simply. Cur's next is equal to what? Temp, and let's write temp previous is going to be what? Cur. Yes, and we are just going to simply return head. I guess that is it. Let's have head. Okay. Let's try and run this code. Okay. Yeah. Now let's run this. See, before insertion 0, 10, 20, 30, and after insertion 0, 10, 20, 30, 40. Okay, so yeah, that was all we had to learn in insertion and W linked list video. And in the next video, we are going to talk about another basic operation of W linked list, that would be deletion. All right. So that's it for this video, and see you later. Thank you.
Hello everyone. So today I welcome you all to another video of our linked list series, which is a part of our ongoing DSA playlist. So in this video, we are going to look at the operation deletion in a W linked list. So in previous couple videos, we saw what is a W linked list and basic insertion operation of a W linked list, right? So for revision, let me tell you what is a W linked list. So W linked list is a basically two-way relationship, right? Suppose there is a node 10 which is pointing towards 20. So 20 would also be pointing towards 10. Now 20 would be pointing towards 30 and 30 would be pointing towards 20. 30 would be pointing towards 40, 40 would be pointing towards 30, and 40 will then be pointing towards null. Right? And yeah, 10 is also pointing towards null. Yes. Okay. So this is what a W linked list look like. Now we have to delete the first element of our W linked list. Suppose this is a W linked list 10, 20, 30, 40. So after deleting the first element, that is 10, output should be 20, 30, 40. Now how to do that? What we can simply do is we can change head, which is currently here. We'll simply shift the head towards this, right? And we'll just delete this element. Okay, let's try and do this thing. Let's do one thing. We'll have cout deletion. Okay, we don't have a display function. I'll make a display function. Don't worry about it. Okay. Now what we are going to do? We're going to have delete big name. We did the same thing in the our singly linked list also. We made a delete b function where we passed on our head, right? And this is head, right? Okay, cool. Now what we are going to do is we are just simply going to have cout after deletion. We are going to have display head again. Okay. Now let's do one thing. Let's make our delete b function, right? Okay. Let's have node star head. Okay. I am saying if head is equal to null or head next is equal to null, what we are going to do, we are just simply going to return null. Alright? But now what we are going to do is we are going to have a node temp which will have the current head, and we are going to simply shift head towards next. Alright? And we are going to shift head previous to null. We are simply going to delete our temp. We are going to have return head. Okay. Now let's make a display function.
Okay, we'll have a node star cur which is going to point to your head, and while cur not equal to null, we're going to do two things. We're going to have cout cur data, and we are going to have and we are going to do cur is equal to cur next. Okay, and let's try and run this thing now. Okay, see, before deletion our linked list looked like 10, 20, 30, 40, and after deletion it's 20, 30, 40. Okay, that was the required output. Okay, cool. Now let's comment out this thing. Okay, let's okay, we'll do delete ending function. Okay, let me first of all write the things here. I'll tell you how to do it. Don't worry about it. Okay, we have delete E. Now let's see. So our array is like this. Yes. Okay. Now what I'm saying is we have to delete this element. How to do that? Remember in the singly linked list video, what we did was in order to delete the last element, what we do is we find the access to the second last element. Second last element would be, suppose the cur is our iterator, so cur next should be what? Null. That's how we'll reach here. Okay. Now then what we are going to do is we are just simply going to change its next to null, and we are going to delete this element. Okay. So let's try and do this thing. Okay. So our function name is node e. Now, as I spoke earlier also, that if head is equal to null or head next is equal to null, we are going to return null. Otherwise, what we are going to do is we are going to have a node star cur is equal to head. We are going to have a while loop where cur next is not equal to null. I'm going to have cur next. Alright. Now, since we have a previous we have a previous pointer also, so let me clear it out a little bit. Yeah, okay. Like this. Yeah. Currently I'm here. What I'm going to do is I'm going to change current previous next towards null and just going to simply delete cur. That would work. Yes. Okay. So let's do that. I said I change cur's previous next is equal to null. I'm just simply going to delete our cur and I'm going to return head. Okay. Now let's try and run this code. See, before deletion it was 10, 20, 30, 40, and after deletion it's 10, 20, 30. Okay, that was what was required. So I guess that was all in this deletion in a W linked list video, where we learned deletion in the beginning and deletion in the end. And that was all in a W linked list part. In the next video, we'll look at circular linked list, and after that we'll look at some of the interview questions on Geeks for Geeks or Lead Code, and that would complete your linked list. Okay, so thank you for watching this video and see you later. Hello everyone. So today we are going to look at another type of linked list called circular linked list. So in the previous videos, we saw this basic single linked list, we saw doubly linked list, and we saw the basic operations we can perform on them like insertion and deletion. And in this video, we are going to look at circular linked list. Okay. So first of all, let's talk what is a circular linked list. All right. Suppose these are the nodes of our circular linked list. So how will they be connected? So this node would be pointing towards here. Okay. This node would be pointing towards here. This node would be pointing towards here. And this node would be in our doubly and singly linked list. This node pointed towards null, right? Yes. But in this video, this node is not going to point here, but it is going to point towards the first element. So we can say all these nodes form a circle, right? Okay. Okay, so now let's talk about the advantages of this linked list. So we can traverse the whole linked list from any node, right? But suppose if it was a singly linked list, if we were at this node, we cannot access the previous element of it. Or if we were at this node, we cannot access these two elements. But if we are here, we can simply uh, traverse in a circular manner like this. Yes. Okay, cool. And the second advantage is we can insert at beginning and ending by just maintaining a tail. Yes. What do I mean by tail? Suppose this is our head, or let's do one thing. Yeah, let's clear this out. Okay, this looks better. Now 10, 5, 20 and 50. So suppose this is head and the last pointer pointed toward it is going to be tail. So the main advantage is we can insert at the beginning and ending by just maintaining a tail. Alright. We'll talk about it, how to do that. Okay, don't you worry about this thing. And the main disadvantage of circular linked list, as you can think, is that implementation of its operation become complex. Yes, because in a circular linked list, as we have to maintain a pointer for the last element as well. So every time, like if we insert at the end, we have to we cannot just simply direct it towards null. So that is it. Okay. Now let's
have a circular linked list implementation. Okay. Here we are going to have our struct node. It is going to have int data and node star next, right? And we are going to have node int x. Data is going to be x and next is going to be length. Okay. Let's have our int main function here. Let's have our node head as new node. Okay. Head next is new node this. Okay. Head next to be new node this. Alright, and again it's going to be head and not data, it's going to be next. Alright, and its next is going to be head. Okay. Okay, my bad. I have to make it like 20. This is going to be 30. And this is going to be 40. Okay. So this is how you maintain a basic circular linked list. Now the thing is how we can display it. Okay, let's make a function called display here. Okay, and we are going to have node. We are just going to simply have head here, right? Okay, and here let's make that function void display node star head, and I'm saying if head is equal to null, we are just going to return, nothing is going to be printed. Okay, now simply what we do in singly and doubly linked list was we simply just traversed by incrementing the operator, and as soon as we reach null we come out of the loop and print the answer. Now what are we going to do here? So here we are going to use this thing, do cout cur data. Cur is is going to point towards what do we say, head, so we'll mention it here somewhere, and we are just simply going to move cur to cur next while cur is not equal to head. Okay, so in the do part what we do is that, okay, 1 minute, so let's have node star cur is equal to head. Okay, so node cur is actually pointing towards head right now. When I do while loop, what happens, I'm assuming you know that, but let me explain it once. It performs the do operation first, regardless of anything, regardless of any restrictions, and then it goes to while loop. So that means this function will occur once at least, and then it will check the conditions. Okay. And let's have indel also. Right. Now let's try and run this program. See, output is 10, 20, 30 and 40. This was the required output. Alright. So I hope you got a gist of what is a circular linked list and how to form a basic circular linked list. In the upcoming videos, we are going to look at uh, insertion and deletion of a circular linked list, as already we did in our singly and doubly linked list. Alright. So I guess yeah, that is it for this video. And yeah, I'll see you later. Thank you for watching.
Hello everyone, and I welcome you all in another video of our linked list series. So in this video we are going to learn about insertion in a circular linked list. In the previous video we learned about what is a circular linked list. Let's have a quick revision of it. Yeah. So if these are the nodes of a linked list, these would be linked like 10 would be linked to 20, 20 would be linked to 30, 30 would be linked to 40, but 40 would be linked to back to 10. Thus, this part forming a circle. Okay. Now we have to learn how to insert in a linked list. Meaning, if I insert 0 in the beginning, so our linked list would look like this. Alright, and 40 will now link to 0. Okay, so you might be thinking this is a easy version, but it is a little bit tricky because see what is it, the problem here exactly is that in our singly linked list we can just simply insert 0, and suppose this is our linked list and this is our first element, and we can just simply link it and return this as head. Right, this is what we do in singly linked list and doubly linked list. But in this, 0 should, or like the last element, which here it's 40, should point towards 0. And how to do this thing is slightly tricky then. Alright. So, okay. We can have one thing. Well, let me tell you a trick which you can use, and trust me, it is very good. Okay, so suppose this is a linked list. Yes, let's link it. Okay, yes, okay. Yeah, so this is a linked list, right? Now how to insert 0 at the beginning, that is our question. So very basic, very good idea that I can give you here is, suppose here
I insert 0 somewhere here. Okay, what will happen? N will be pointing towards 0 and 0 will be pointing towards 20. Alright, and I'll just swap these values. That means 0, 10, 20, it would be 30 and 40, and 40 will be pointing towards 0. Okay, let's try and run its code here. Let's have a little zoom in. Okay, yeah. So let's try and write our beginner function. So let's do it like we do every time. We'll have before insertion. Let's cut this. Okay. Now let's insert B node star head. We'll write cout after insertion. Okay, and we'll simply display head here. Okay, now let's let's try to write this function. Okay, let's write it here. Node star insert B node star head. We have a node temp. Okay, we didn't write the element, so let's make it int x new node x, and here it is equal to 0. Okay, suppose if head is equal to null, we are going to have temps next as temp and simply return temp. Or what we are going to do here is we are going to first of all add temp between head and its next. Okay, this basically code depicts that we are in. Yeah, this code tells us that we are inserting temp between head and heads next. All right, now here what we are going to have int, we are just simply writing a swap algorithm. Okay, let's move it here. So see, what we're doing here exactly is this function
like this algorithm, these lines of code tells that we are inserting temp between our head and heads next. And in this part what we are just simply swapping the values of our head and temp. And since the new like x is at head, so we are just simply returning the head. Now let's try and run this code. Okay, see, before insertion our code is 10, 20, 30 and 40, and after insertion the code is 0, 10, 20, 30 and 40. This is the required output. Okay, now let's do one thing. Okay, so we like inserted and all, but now let's see insertion in the end. Okay. So before writing our insert end function, let's try and see how we can have it. Okay, so this is our linked list. Yeah. And the new one should look like 150 should return to 10. Okay. Okay, so now try and think how like you can write this code. Okay, a slight hint if I give you, the thing we did in the insert at the beginning question, the same thing would be applied here. Okay. Okay, so let me tell you what you can do is you can simply insert 50 here. Okay, yes, 20 here, 30 here, 40, and this will be pointing towards here. Now since you're going to swap 50 and 10, 50 will be pointing towards here, and 10 will be pointing towards here. And if I return this element, it's next. This would be the last element. Yes. So we'll write this code here. We'll copy this part from the return head, like from the insert. Okay. And we want to have insert e node star head index. Yeah. Okay. Head insert and let's insert 50 in the end. Okay. Okay. So we're going to insert the 30 here. Pasted the same code of insert E where we got temp node where we stored value of x, and then in this part what we did was we inserted element x between head and its next, and here we exchange the data of head and temp, and here we are simply going to return head next. Right, that means we're returning the original head here. Let's try and run this code. Okay, see, before insertion it's 10, 20, 30, 40, and after insertion it's 10, 20, 30, 40, 50. Okay. So I guess you learned how to insert data in a circular linked list. It was slightly different from what we did in singly linked list and doubly linked list. And in the next video we are going to look at insertion in the end, deletion in a circular linked list, and after that we are going to look at few of the interview questions. Okay, that's it for this video, and thank you for watching. See you next time. Hello everyone, I welcome you all to another lecture of our linked list, and this is going to be the last theory lecture of your linked list, and from the next videos we are going to look at interview problems. Alright, so without any delay, let's start with the video. So in this video we are going to learn about deletion in a circular linked list. Alright, so let's talk about what is a circular linked list. So if these are the nodes, then the relation between them is going to be like this, and the last element is going to point towards the first element, thus making a circle. And if I delete this element, our output should look like this. Okay. So if you recall that how you delete the element here is that you simply remove this element and uh, have your head pointing toward here, right? But here you cannot do the same thing because this 40 is also pointing towards your 10, right? So let's see. What you can do here is, yeah, suppose this is 10, 20, 30, 40. Okay. If I, you know, copy this element here, and then if I delete this element, right? So this output, alright, yeah. So this thing and this thing are same, right? Okay, so let's do and code this thing. Okay, I write cout before deletion. I'm going to have display head. Now head is going to be delete b head cout after deletion. I'm simply going to have display head. Alright, now we just have to write our delete function. Let's write it as delete b. Alright, now let's see. Suppose if there's no element, first we'll deal with the edge cases. So if there is no element, we are simply going to return null. And if there is only one element which is already pointing towards itself, we are simply going to delete head, and we are simply going to return null. Alright. And if these two are not the case, then what we are going to do is we are going to shift heads data as head next data. Okay. And we are going to have a node temp. We're going to contain head next. We're going to have heads next as heads next, and we are going to delete temp, and we're going to return head. So this is the code which we saw. Alright, let's try and run this thing. Let's see if it works. Okay, there's a problem here, I guess. Okay, let's see. I am not getting any problem somehow. Okay, yeah. No, wait. We got our head also here as HP, and then the C out part. What is it that we are getting wrong here? If head is equal to null, we are just simply returning null, and if it's next is equal to head, okay, my bad. Now let's try and run this thing. Yeah. See, before deletion, our output was, our linked list was this, and after deletion, our linked list is this. Okay. This was the required one. Let's have one thing. Okay, we have head is equal to delete E. Alright. We are going to look at if we delete in the end. Alright. Suppose this is the linked list. Okay. And if you have to delete this element, we'll get this output. Alright. Cool. So can you think like how to do this thing basically? Okay, let me tell you. What you're going to do is you're going to have address of this element and you need to have address of this element. What will happen, we'll simply change its node direction from 40 to 10, and we'll just simply delete 40. Okay, so let's try and run this, write this code. So it's node star delete E node star head. Okay. Now suppose if head is equal to null, simply return null. Okay. And let's say if head next is equal to head, you will simply do delete head and you simply return null here. Alright.
And now we are going to have a node curve which is going to point toward head, and we'll um, you know okay, we have this thing, node star curve. We also require a previous. We also require a temp is going to store the head. You see what we are going to do here. So I'm saying while curve next is not equal to head, we're going to do two things. We're going to change previous to curve. Alright. We're going to change curve from curve to curve next. Alright. So give me a minute. Let me clear out a bit. Okay. Yeah. So after our while loop, curve is going to point over here and previous is going to point over here. Now, okay, this is going to press, yeah. So we did the while part. Now, we'll simply have pref next as curve next. I want to have head as pref next. Alright, and we are going to delete curve and simply return head. Alright, let's try and run this code, see if it works. See, before deletion, this was the output. Before this was the linked list, and after deletion, this is the linked list. So this is the required thing. Alright. So I hope you understood deletion in the linked list, and as I already mentioned before, this is the last theory lecture, and from the next video we're going to look at some of the interview problems. So thank you for watching this video. Happy learning. See you later. Hello everyone. So today we are looking at one of the interview problems, as I told you in that we are going to start our question videos from this video onward. So here is our first question. It says the question title is middle of the linked list. So let's first of all let's read the question description. So it goes like, given the head of a single linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. Alright. So let's see our example one. Suppose this is our linked list 1, 2, 3, 4, 5, and if we have to return this element, so output is going to be this. Okay. And if this is our linked list, then we have to return this one. Okay. So can you think of how to solve this problem? You may take 2 minutes. Okay. The basic approach which might be coming into mind is, suppose this is our linked list. Okay. Yeah. So what you might think is, you will traverse the linked list till the end, and you will find the size. So you will find the size as it is 1, 2, 3, 4, 5. Okay, so your size is 5. You're again going to traverse the linked list, and in the third iteration, when you reach here, you'll simply
return the address of this linked list. Okay. So this is a very naive approach, I would say. Okay. The time complexity here is O of n. Okay. The time complexity here is O of n, and you are going to traverse 2 times. So it is basically O of n plus O of n. Alright. Now, since I told you about the naive approach, think of an efficient approach. Efficient approach. Okay. Yeah. Let's go. Suppose if I say we have the same linked list 10, 20, 30, 40, 50. Yes. Now, suppose we have 2 pointers here. Okay. One is slow, one is fast. So in every iteration, we are increasing slow by 1. So slow after first iteration is going to be here. And we are increasing our fast by 2. So that means after first iteration, our fast would be here. Okay. Now in second pass, slow will come here and fast will come here. As soon as you see that fast is at the last index, it's simply going to return the slow. Okay, that's how you can find the middle of the linked list. Yes, let's have a dry run of the second thing, which is 1, 2, 3, 4, 5, 6. Okay, let me clear out a bit. One, 2, 3, 4, 5, and 6. Now slow is here, fast is also here. You increase slow by 1 and increase fast by 2. Now slow is here and fast is here. Now since there are 2 middles, we found the first middle when it is at the it is not when it is here. We have to find the second second middle. We are again going to increase s and fast is going to be pointing towards null. Okay, so the loop is going to run till either fast next is equal to null, which was in the case here, or it's or either fast is equal to null. All right. So let's try and run this code. All right. Yes, let's try and run this code. Okay. Suppose let's deal with our edge case first. If head is equal to null, we are going to simply return null. Okay. Now let's have two things. Let's node star head. Let's node star slow. We're going to point toward head, and we'll have star fast, which is going to point towards head. Okay. Now I'm saying while fast is not equal to null and fast next is not equal to null. we're going to have fast is equal to fast next. We are going to jump it 2 times, and we are going to jump slow only 1 time. And here we are simply going to return our slow pointer. Alright, so let's try and run this code. See, accepted. Let's try and submit it. Okay, we found the output. Alright, so yeah, that was it for this lecture. Okay, I hope you understood this. This is a very basic interview problem, I would say very easy one, but it is one of the important ones because you understood a new pattern, I'd say, or algorithm, I'd say, where you use 2 pointers, slow and fast. This will come in handy in the future problems. We'll deal with them when they come. Alright, so that's it for this video. We'll have another problem in the next video, and thank you for watching. See you later. Hello everyone, and I welcome you all to another video of our Linkless series. And in this video we are going to look at another problem which is very important in terms of our interview preparation. Alright, so let's get started with this video. Let's see the description of this video, the description of this problem. So the problem name is remove duplicates of sorted list, and let's read the description. So given the head of a sorted linked list, delete all the duplicates such that each element appears only once, and then we will just simply return the linked list sorted as well. Alright, so suppose see example 1, there are 3 elements 1, 1, 2. So this is sorted, and we have 2 ones, so obviously we're going to remove 1 as we have to delete all duplicates, so our output should look like this 1, 2. Alright, let's look at this example 2. There this list is sorted 1, 2, 3. With 1 duplicate of 1 and 1 duplicate of 3, we'll remove this and we'll get this in output 1, 2, 3. Alright, let's think of the solution. Suppose I have code like this. What I am going to do here? You may like pause the video for 2 minutes and think of the solution. Okay. So this is a very good approach. You like this is a learning for you how to use this approach exactly. So what we are going to do is we are going to use 2 pointers here. Let's see, one pointer is I1, another pointer is J. Now what we are going to do is we are simply going to traverse J where initially both the pointers are here. Now J is going to point from, like, we'll check if J's data is equal to I's data. If it is correct, we'll simply move J from here to here. We'll check again if J's data is equal to I's data. It is. So we'll shift J from here to here. Now we'll again check if J data is equal to I's data. It is. So we'll simply move here. Alright. Now we'll check if J's data is equal to I's data. It is not. Yes. So what are we going to do here? We change our I basically was here, so we'll just change our I's next. That means I's next is this to point towards J. That means all these elements get removed, and then we're simply going to change I from there to here. Alright. Now we'll again say that I is equal to j. Then we'll again go to j forward. Alright. J is pointing towards here. We'll check if j is data equal to I is data. It is, so we are changing the pointer from here to here. We'll see that j zeta is not equal to I zeta, so we'll just simply change I is next to j. Right, and we are going to change I from here to here. Now the rest you know, and as soon as j reaches null, we'll come out of the while loop. Okay, so let's try and run and write this code. Alright, so select list node star it1. Let's make it as head and we have star id2. I'm saying while it2 not equal to null, we are going to do two things. it2 is going to be it1. Alright, it is going to be it1. Alright, you might be thinking why is that, so let me tell you. Suppose this is 3 and this is null, right? So as soon as this reaches here, j will come out of the loop and this action won't be performed. Alright, it's going to be it1. Okay, we have now it2 as it1, and we have here while it2 not equal to null, right? And it2 val is equal to it1 val. We simply going to shift it2 as to its next, simply iterating it2. Right, I'm just simply going to change it next as it2 and it as it next, and here we are simply going to return head. Let's try run this code. Let's see if it works. Okay, my bad. It's going to 91 next. This error everywhere, I guess. Let's see. It runs now. I made this error everywhere. Sorry for that. Okay, so our output is accepted. Let's try and submit it. Okay, let's get submitted. Alright, so this was the question. Yes, so we solved it. So I guess you learned about the new approach we did here of 2 pointers, and you may seek help or like use them for the future questions. Practice more, you can use these two questions to work here. Remove duplicates from sorted necklace 2 and remove duplicates from an unsorted necklace. Alright, so I guess that's it for this video, and thank you for watching. See you next time. Hello everyone, and I welcome you to another video of our linked list series. And in this video, we are going to look at another interview problem called reverse linked list. So let's see the description of this question. So the description of the question goes like, given the head of a single linked list, reverse the list and return the reversed list. All right. So what does this mean is, see this example where we have 5 nodes and data are 1, 2, 3, 4, 5. And if we reverse this linked list, so what would be the new linked list? 5, 4, 3, 2, 1. So this is the output 5, 4, 3, 2, 1. All right. Let's look at another example 1 and 2. And if we reverse it, our output would be 2, 1. Okay. Now, before jumping to solution, you may pause the video and try the solution on your own. Otherwise, you can watch the video. Okay. So first of all, let's make our linked list here. 2, and it is 3, it is 4, increase the size of it. Yeah. Then it is 5. Suppose we have another one that is 6. Alright. Now, can you like think how would be the reversal here? Okay. Suppose we have some functioning, like we write a function to do this job. Alright. And at any time our function reaches here. Okay, suppose you have a curve which is iterating this linked list, and so curve is here right now. Okay, so before this, what would we be having? Yes. Okay, cool. Now how would you change this arrow to this arrow? What will you do to do this? Okay, so first of all, to do this, you should be having address of this one, this node. Let's call it previous. So what you'll simply do, you'll just change curves next to previous. Okay, but how will you come here? So for this, you're going to have another node. Let's call it next. Okay, and assign next as curves next. Okay, I'm not writing the whole thing here, but get a gist. Right, next is equal to curves next. And then after doing this, you will just going to change cur from here to here, meaning we will change cur to next. Okay, that's good. So this is how the thing is going to work. All right. Now you must be wondering one thing, that is okay. The intermediate parts you can think of how the loop would work. But suppose we are at the first node, then what would be the previous here? Yes, you guessed it right. So previous would be null. Alright, we'll initially put previous as null, and we'll just point this to here. Alright, and one more thing. Since this was previous, we did everything, and then our previous is also going to change from here to here, and same thing would work. Okay. Alright, that's cool. Now let's clear it a bit. Okay. Yeah. And suppose this is the thing, and this is our number, and cur is here right now. Okay, now what is going to happen? We'll point 6, which is pointing towards null, to 5, and we'll remove this part. And after like everything, what will happen? We'll have a null at which our curve would be pointing, right? And this would be pointing towards previous. And after this loop, we'll see that curve is equal to null. We'll come out of the loop, and the new head would be previous. 6 would be the new head. Alright, this is going to be the new linked list. Okay, now let's try and code this thing. the ID. Alright. So let's see. Let's have list. Let's make our nodes. First is going to be cur, which is going to point towards head. Then we are going to have a previous, which is going to point towards null. Alright. Okay. Now we'll say while cur is not equal to null, we are going to perform operations. Where let's have one more node. Next, which is going to store cur's next address. Yes. Okay. And now cur's next is going to point towards priv. Alright. Now priv is going to point towards cur, and cur is now going to point towards next. Alright. So this was the code, and we'll simply return priv here. Alright. So this was the working which I told you. Now let's try and run this thing. Okay, so accepted. Now let's try and submit this code. Alright, so we got the correct output. Okay, so I hope this question helped you, and this question is like pretty important, I'd say, because there are like tougher problems ahead where we have to reverse and pairs and stuff. So we'll jump to that, but you need to have the you need to have your basics clear, which you can have it here. All right. So yeah, that's it for this video. Thank you for watching. See you later. Hello everyone. So I welcome you all to another video of our Lingua series, where we are going to look at a very interesting and a little bit difficult problem. So the problem statement is reverse a linked list in groups of given size. So first of all, let's try and read the description of the problem. So it's given a linked list of size n. The task is to reverse every k nodes with k1 input to the function on the linked list. If the number of nodes is not a multiple of k, then left out nodes in the end should be considered as a group and must be reversed. Okay, so let's look at this example. This is 1, 2, 2, 4, 5, 6, 7, 8. Okay, let's try and write this. It's 1, 2, 2, 4, 5, 6, 7, 8. Okay, now we have to reverse it in a group, and group size is given by 4. That means first 4 elements would be reversed. So it will be 4, 2, 2, 1. Then another 4 elements would be reversed. That is 8, 7, 6, 5. Alright. This will be first 4 elements, second 4 elements, and these are reversed. Alright. So this is like basically what we have to do in the question. Also now let's try and see the other example. It is 1, 2, 3, 4, 5. K is 3. So 1, 1, 2, 3, 4, and 5. Okay. Now we'll first K is given as 3, so we'll reverse these 3 first. So it will be 3, 2, 1. Now there are only 2 elements and K is 3. So read this line of the question. That if the number of nodes is not a multiple of K, then left out nodes in the end should be considered as a group. So we'll consider this as a group and we'll reverse it. Alright. So yeah. So basically this is what we have to do here. Alright. Okay, that's good. Now you may pause the video and think of solution, like how can you do this question. I know it's a bit tough to think, but try thinking it. You may like, if you get a little bit of idea like how to do it, and if you see the video, then so you'll have a better clarity to how to solve this thing. Alright. So okay, let's start our part, how we are going to do it. Okay. So let's have an intermediate position. Suppose we have reverse the linked list till here. 3, 2, 1. Alright, and here we have 4, 5, 6. Alright. Okay. Now this has been reversed, right? And we have to reverse this part. Alright. So okay, we reverse this thing. We're going to reverse this thing. You know the basic algorithm of reversing. We talked about in the previous video. So we simply reverse using that part. Alright, like this. Now this thing is what? Previous. So I'm talking about the notations which we use in the previous one. Previous video, this is going to be previous. And we have 3, 2, and 1. Okay. Now basically what, I suppose there is one more part. So what are the things, like what are the variables which are required? We need this thing. Alright. So that we can link it to here. So this is what? Previous first. Let's have previous first. And after that we'll require this element. For suppose we have another set here. We'll change the previous first to here. So we will name it first. Alright. So we require a first, we require a previous, we require a previous first. Okay. And one more thing. We having an edge case here. Suppose if we have to reverse the first group. So suppose we reversed the first group. Okay. And so we won't be having any previous first here. So there's no point changing that. Alright, and also the head is going to change since we return head, so our new head would be previous. We'll do this only if we are at the first pass. Alright. So yeah, these are all the things which you require to do in the question. So let's try and code it so that we can have a better understanding. Alright. Okay. Let's have our nodes. Okay. I'm having a curl node which is going to traverse head. Okay. I'm going to have a previous first node which is going to be null at in the beginning. Alright. B is first pass. I'm going to check the condition if the
pass is first, so we'll change the head to previous and we'll just change the view to change its first pass to false. Right. We'll see what we're going to do here. And we'll have a counter equal to 0. We'll have a counter that a number is less than, like count is less than k or not. Okay. Wait a minute, we'll put it in another thing. I'll tell you now. So we have a loop while curl is not equal to none. We'll have a node previous it is pointed towards left. We have one more node first. We want to point towards the first element. Alright. Now let's have one more thing. We'll reverse it. While curl is not equal to null and count is less than k. Okay. We reverse it. Okay. So we'll have a struct node star next curse next. This is the basic algorithm of reversing a linked list. We talked about it. So now we have curse next to where that where is going to be curve and curve is equal to next. We are simply going to increase the count. Alright, so reverse it. Now, since we reverse the group, we check if it is the first group, if it is the first pass. If is first pass, what we are going to do here is we are going to change our head to priv. Alright, and we are just going to mark it as false. Otherwise, what we are going to do is we are going to change priv first next to priv and priv first will be upon the first one. Alright. Cool. Now we are going to do what? We are going to simply return k. Okay. Now let's run this code. Let's see if it works. There is some compilation error. What is this? Okay, we didn't mention the counter, my bad. Yeah. Okay, so we are getting the expected output. Output matches the expected output. So let's run this code. Yeah, cool, our code works. That is nice. So yeah, I hope you learned how to reverse a linked list in a group of given size. It is one of the important questions asked in many companies. So it is a very important question. Okay, and you also used your learning of the previous video of reversing a linked list. We just reversed a group simply and then how to connect it. We talked about that. Alright. So I hope everything is clear to you, and in the next video we are going to look at a few more problems, and yeah, that's it for this video. Thank you for watching and see you later. Hello everyone, so I welcome you all to another video of our latest series where we are going to look at another problem.
So the problem statement is linked list cycle. Okay. So let's first of all read the description of the problem. So it goes like given a head, the head of a linked list, determine if the linked list has a cycle in it. This cycle in a linked list, if there is some node in the list that can be reached again by continuously following the next pointer, eternal pause is used to denote the index of the node that its next pointer is connected to. Alright. So we have to just return true the cycle in the linked list, otherwise we have to return a false. So let's look at this example. If we go next, and if we reach the end node, and according to simply linked list, its next should be null. But here it is pointing towards the position 1, so that means there is a loop here. Right. Similar is the case here, and since there is no loop here, our output is false. Right. So first thing is how to solve this question. Right. Let me clear it a bit. Okay. Yeah. So like first question that comes to mind is how to do it. Okay. So I can see the first method, which is a very naive method, which may came into mind is hashing. Alright. See, if you don't know about hashing yet, I'll cover it in a later video, but if anyone knows about it, you can watch it, otherwise you can skip for the efficient method. So basically in hashing, what we can do is we can make a set, alright, of nodes. Yes. Alright. Now we are just going to have a pointer curve. We're going to point, which is currently pointed towards head, and we'll say while curve is not equal to null, we increment curve to curve next. Alright, like you know what the loop is going to be. And then we are going to insert every element in our curve. Alright. And before doing this, we are going to check if this element, that is not find curve, is already present in it or not. If it is already present, that means we have already visited this node. So that means there is a loop. So we will return true here. Otherwise, after the whole loop, we are just simply going to return false. Right. So let's write the nice solution also, so you will have a better idea what I am talking about exactly. So here we are going to have node set node star yes. We are going to have for node star curve is equal to head curve not equal to null curve is equal to curve next. Yes. Okay. If I say is dot find curve is not equal to s dot n, that means we have found the element, we will simply return true. Otherwise, we are just simply going to insert that element. And then we is going to simply return false because we just came out of the loop and we haven't seen any loop there. Okay. Okay. Oh yeah, it is going to be less node. Less. Then it is also going to be less node. Okay. See, our output is correct. And let's try and submit it. Yeah, so we got the correct output. Okay, alright, that is good.
But here is one thing you should be knowing, that if we use a hash, what happens is we have to use an extra space here of O of n. So it is not a very efficient solution. Alright. Now we'll talk about an efficient solution here. Okay. Let's write it as efficient. Okay. So efficient solution, it is a standard algo called Floyd's detection cycle. Alright. So what did I say? It's Floyd's detection cycle. Okay. Cool. So what we are going to do in Floyd's detection cycle is basically we are going to have two nodes. Let's suppose this is the thing 1, 2, 3, 4, and 4 is pointing towards 2. Okay. We are going to have two pointers here. One pointer is fast, one pointer is slow. Alright. And both are pointing towards head. Okay. Now we are going to increment fast by 2 nodes and we are going to increment slow by 1 node. So, and if at any point fast becomes equal to slow, that means there is a loop there. Alright. So, okay, there is a proof of Floyd's detection cycle which includes your mathematical induction process, so I don't think so you need that. So we'll be sticking to just knowing that if fast becomes equal to slow, we'll have a loop. That means we detected a loop. Okay. So let's try and do that thing. Alright. Okay. So let us tell you we are going to have two nodes. One is going to be fast, going towards head. We are going to have another slow, going to point towards head. Alright. Now I'm saying while fast is not equal to null and fast is not equal to null, what are we going to do here is we're going to move slow as slow next and fast as fast next. Alright, we say if slow is equal to fast, that is a loop, so we return 2 here. Okay. But otherwise we are simply going to return false. Let's run this code, let's see if it works. Okay, I expect output is accepted. Let's submit it. Yeah, okay. We are getting the right output. Okay, that's right. So yeah, I guess that's it for this video. We learned about loop detection. In the lectures, we talked about two methods here: Ashen and efficient method for its detection cycle. Okay. So thank you for watching this video and see you later. Hello everyone, and from this video onwards we are going to look at we're basically going to start a new topic called strings. Alright, so in the previous few videos we learned about linked lists, we did few problems on them, and we'll follow the same pattern here. We'll look at the theory part of our strings here, and then we'll jump to
interview problems, and this is how we'll complete the topics one by one. Alright. So yeah, so okay, without any delay, let's start this video. So first of all, let's talk about what are strings. So strings are basically defined as a stream of characters. Okay. Strings are used to basically represent text and are generally represented by enclosing text within quotes as this is a simple string. Okay, like double quotes. Cool. Now, if you have learned about a little bit strings in your C language, so what happened there was we have to make a character array, and there we used to store string like this. Okay, and basically every character here was part of a array. Right, and if we have to search anything or remove anything, we have to iterate over the array C. Okay, but since this was a very complex and tedious task, we have a very good function in our C++. It is that we have a class in C++. All right, called std string class. So let's see what it is all about. So basically it is that C++ has in its definition a way to represent a sequence of characters as an object of the class. So rather than an array, it represents characters as object of the class. Okay. So this class is basically called std string. Alright. So the string class stores the characters as a sequence of bytes with functionality of allowing access to a single byte character. So what did I just meant here? What was before I have this thing. Okay. Yeah. So, okay. Yeah, so what I was saying. So rather than going into the array part, we just simply write it like this. Programming knowledge. Alright. So that is how you simply do it. Okay. Cool. Rather than declaring a string, basically array of characters, we simply define string in C++ like this. And we have like C++ standard template library of our string class to help us, to have some very few basic functions. Okay, now let's jump to our VS Code and let's try and perform these things. Okay. Let's have it main here. Let's try to jump into string. Okay, easy. And simply use cout. Yes. Let's run this then. Okay, we got the correct output. Alright. Okay, there are like, let me tell you a few functions, few functionalities of STL of C++, of STL of basically string in C++. I tell you the basic ones which you'll be using, and after that you may, if you want to learn more about it, you can obviously surf the web for it. Suppose I make a string s1 and I name it programming. And if I have string s2 and I make it knowledge. Now what I can do is simply cout s1 dot length and let me have cout s2 dot length. If I enter in this thing, let's see if it works. Okay. So basically, okay. I do it bit messy. Cool. So it's 11 and 9 basically. So that means string 1 contains 9 characters, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that's right. And string is 2 contains 9 characters, 1, 2, 3, 4, 5, 6, 7, 8, 10. Yeah, that is also correct. So that means we are getting the correct output. So this is a length function, right? We can do one more thing is, let me show you a very beautiful thing. If you do this thing, it will concatenate both the strings. Concatenate basically means to join any two things. So here we are concatenating two strings, S1 and S2. Let's try and run it. Yeah, see, we have concatenated the strings. That is nice. Okay. And now let me tell you one more thing. The nice one. Suppose what I do here is, let me change the thing a little bit. Okay, so we have few uppercase and we have some few lowercase. We have to convert it all to lower. What I'll do, so what I'm just simply going to do, I'm going to write transform. Okay, I'm going to have s1 dot begin. Okay, I'm going to have s1 dot end. I'm going to have s1 dot begin. I'm simply going to write to upper. Okay. Okay, and if I just see out S1 now, let's see what would be the output. Okay, this should not have been happening. Okay, so basically what's the problem here is, okay, there's no problem. It was alright, because I didn't say the code. So okay, we are getting all the uppercases later here, and if I want to have lowercase, I'll just change it to lower, and I'll save it again, and let's try and run it again. See, I'm getting all the lowercase letters. So these are some of the basic STL functionalities of a string class, and rest you can obviously anyways check on serve the web. But these are the few ones which you would be needing in your like few of the questions and things. All right. So yes, I guess this was the introductory lecture for the string class, and I've told you about what is a string, how to define a string in C++, and we talked about few of the basic SQL functionalities. So that's it for this video, I guess, and we'll look more into it in the next video, and thank you for watching. See you later. Hello everyone, so welcome all to another video of our string series, and in this video we're going to look at a very basic problem called palindrome string, which is I guess you have or maybe have solved that in school if you have taken computer science. Right. So okay, let's talk about what is a palindrome basically. Okay. See, if I say if I write A, B, C, D, A. So if I read the string either from here, if I read the string from here, to have the same output ABCDA, ABCDA. Correct. So yeah, that is it. So this is basically what a palindrome is. That if I read the string either from left or either from right, I should have the same output. Okay. Now the question is that we are given a string S and we have to check if it is a palindrome or not. Okay. First of all, let's talk about what we say nice solution. Alright. So suppose we have a string ref, alright, which is equal to string s, and what I did here is I just reversed the string
how do we reverse that? So we use the STL functionality reverse and reverse the whole string. Alright. Now we simply return is equal to yes. We have I say if this is equal to yes, and we return 1, and we return 0. Alright. Let's try and compile this code. Let's see if it works. Yes, your output was correct. So I'm not going to submit it because I know it is not going to work because see auxiliary space is 4 of 1. So what is happening here is we are using a string here. We are using one more string to store the reverse of s. So here we are going to have space complexity as 2 of length of s. So that is not the required space complexity here. Alright, so that's why we are not going to save it. So this is a very nice solution, and can you think of how to optimize it? Okay, let's go to our book. Yep. So this one, this part and this part, and yeah. Suppose I have a pointer begin here, and if I have a pointer here, and if I move it from here, and if I move it from here, and if I check every character if they are same or not. Suppose we check the first character from here, we check the first character from here. If both are same, we'll move this here, we move this here, and we check the next characters. These are also same, so we'll take them also. Then we arrive here and we'll check, and yeah, we'll get output as true. Okay, so what would be the ending condition of the loop? When this iterator, let's call it begin, and this iterator, let's call it end. When begin becomes greater than or equal to end, I can say that I have reached the other side, and the string is palindrome. Otherwise, it is not. Okay. Okay. Now let's try and run this thing. Let's have the begin as 0, and let's have the end as s dot length -1. Alright. Now say while begin is less than end. What I'm going to do here? I say that if string begin is not equal to string end, return 0 here. Otherwise, what I'm going to do, I'm just simply going to increment and increment our operators. I'll just simply return 1. Let's run this code. We are getting the expected output. Let's run this code and see if it works. Okay, very nice, it works. So this is a very basic problem of a palindrome string which we did, and I hope you understood what is a palindrome and how to solve it efficiently and valid solution. Alright. So I guess that's it for this video, and we'll see more in the future videos, and thank you for watching.
Hello everyone, and I welcome you all to another video of our string series. Alright, and in this video we are going to look at one of basic problems called anagram. Alright, and in this video is going to be very important because we are going to learn a very important trick, or you can say algorithm, which we use to solve most of the string questions. Alright, so make sure you watch this video till the end. Okay. So, okay, let's start. First of all, let's read the description. So, description goes like, given two strings A and B consisting of lowercase characters. Alright. The task is to check whether two given strings are an anagram of each other or not. So an anagram of a string is another string that contains the same characters. Okay. So let me tell you what are anagrams in a more simpler language. Suppose I have a string A, B, C, D. Alright. Now if I like have to define the anagrams of this, so I'll just basically say permutations of this string BACD, CADB, ACBD, and yeah, many. Wait a minute. Okay, yeah, and many more like this. Okay, so suppose I have one string S1 and one more string S2. It is like some string like this. So how can I say S2 would be anagram of S1? Simply I can say that frequency of characters present in string 1 and frequency of characters present in string 2 should be equal. Suppose A frequency in this string 1 is 1, so frequency of A should be 1. Frequency of B is 1, so here also the frequency should be 1. Okay, that's cool. Let's erase this a little bit. Let's leave one anagram and leave the rest. Alright. Now, first, let's talk about the brute force approach you can apply here. You may like pause the video and think on your own like how to solve it. Okay, first of all, let's talk about the nice solution. So here we have two strings, right? This is S1 and suppose this is S2. So if I say I sort both of these strings, so after sorting ABCD, the sorted S1 would be obviously ABCD and sorted S2 would be ABCD, and I can simply compare these two, and both, if the comparison, like if we compare it and if we uh, get the comparison result as true, the output would be true, otherwise it would be false. Okay, so let's just simply write it here. So I'm going to use the inbuilt sort function provided by C++. So if you don't know how to use it, let me tell you. So basic syntax goes like, you just write sort, okay, and then you write what you have to sort and from where to where. So I have to sort a string A from its beginning to end. So I'll just return A dot begin, A dot end. Okay, I'll write sort P dot begin, comma P dot end, and simply I'm just going to return A is equal to B. Is that correct? Let's check it. Let's compile and run. Let's see if it works. Okay. Okay, what are we doing wrong here? Okay, so b dot begin, we forward the parentheses. Let's see and compile. Let's see if it works now. Okay, it is working. Let's try and submit it. Okay, we're getting a correct output. So let's talk about the space complexity here. So space complexity used by a sort inbuilt sort function is big O of number of characters. Say number of characters is n, so it would be big O of n. And time complexity used by
the inbuilt sort function is n log n. Okay. Now we'll think of a better approach, which would be like reducing our time complexity here. So can you like think of doing this question in time complexity of n? Big O of n. Okay, let's erase this, and now we'll talk about the efficient solution, which will use the algorithm which I mentioned earlier in this video. So let's quickly see what it is all about. So I can suppose I have a string of, I have an array whose name is char. Okay, and it, okay, and it basically like contains what exactly here? It would be containing the, the frequency of elements, frequency of basically letters in a word. Are you understanding what I'm trying to say? Okay. Let me tell you by giving an example so you will understand better. Suppose I simply have a char of 256. Okay, you might be wondering why I'm using 256, because see, when we are dealing with letter, so we generally have, if we want to like, uh, you know, basically, what do we say that word? Yeah, if you want to like convey a letter, okay, in terms of numbers, so we'll it can be done using ASCII code. Okay, so I'll repeat what I just said, that if a letter, if we want to represent a letter in terms of numbers, we'll be using ASCII codes, right? So if you don't know about ASCII code, so it is basically like every letter like A, capital A, B, capital B, these are given ASCII codes. So A has some ASCII code in numbers, capital A has some ASCII code, capital B has some ASCII code in numbers. So the maximum ASCII code of a letter is 256. That's why I use an array of 256 here. Okay. So yeah, we have a character array of 256 and all the entries are 0 currently. Now suppose I have a string s1 a b c. Okay. So see, I come across a, right? So what I'm going to do is that I'm going to increase a's frequency in my character array by 1 and rest of the elements are 0. Then I again see A, I'll again increment its frequency by 1 and rest of the elements would be 0. When I come across B, I increment it. Okay, now I come across C, I'll increment it and rest of the elements are 0. Now suppose there is another string, and if I have to check whether this string is anagram of this string, what I'm going to do? I'll come across this first letter, it's B. So I'll just reduce its frequency in my character array by 1. That means 0. I come across A, I'll decrement its frequency by 1. I come across C, so decrement. I came across this one, I simply decrement. Alright. And after doing this stuff, in the end, what we are just going to do is we're going to check if all the entries in our character are 0. If they are not, then both the strings are not anagram of each other, and if it is 0, that means both are anagram of each other and we'll return true. Alright, so let's try and code this thing so you'll understand better. Let's remove this stuff, previous code. Now we'll have const int char 256. Alright, we'll have a check if a dot length not equal to b dot length, simply return false, obviously. Now we'll have a array called count
Okay. And it is going to be 0, all the elements. Now I'm going to have for int I is equal to 0, I less than a dot length I plus plus. What I'm going to do is I'm going to increase for a letters in string a and decrement for letters in string b. Okay, now what I'm going to do is we are going to check if all the elements are 0 or not. So if count of any element suppose is not 0, we are simply going to return false, and if in the end we'll just simply return true. Okay, let's try and run this code. Okay, so we are getting a correct output here. Let's try and submit it. Let's hope it works. Okay, so yeah, it works. So in this video you learned about an algorithm basically where you declare array of count where you store the frequency of all the elements present in a string. Alright, and remember this number, you have to create an array of this size only. Alright, so I guess that's it. That was it for this video, and if you have any doubts regarding this lecture you may ask your queries in the comment section. And yeah, that's it, and we'll see you in the next video. Thank you for watching. Hello everyone, and I welcome you all to another video of our string series. Alright, and in this video we're going to look at one of the important problems called leftmost repeating character. So first of all I would like to tell you that I couldn't find any coding platform which has this question exactly. Alright, but this question is very important because it has been asked in numerous companies like Goldman Sachs and many more. Alright, so I thought that you have to like understand the approach to how to solve this problem. So for that, I have written the basic driver codes here, int main and header files, and we have to just complete this function and see whether our output is correct or not. Alright, so now let's jump to our question. So it's basically leftmost repeating character, right? So let me first of all tell you how to like for what is basically what is the like what the question is asking. All right, so basically if we are given a string like suppose our input string is geeks for geeks, so there would be characters which will be repeated in the string. All right, for suppose G is repeated here and here, E is repeated, K is repeated, S is repeated. All right, so suppose if these characters are repeated, then we have to find the leftmost repeating character. Suppose C, G is here, E is here, E is also here. So E is a repeating character, but you can see that G is here and G is here. So G is also repeating character. So which is the leftmost among them? Obviously G, right? So our output would be 0. The index of the leftmost repeating character, that is 0. You know that string is saved as a 0 based index, so our output would be 0. Alright. And suppose if a string is A, B, C, D, E, no repeating character, so our output would be -1. Okay, so this is the basic idea of the code. So first of all, let's talk about the nice solution here. What I can basically do is I can have two loops. Okay, suppose
I have two iterators I, alright, and I have j, which will go from I plus 1. Okay, and I'll check for every character. If I encounter the same character, I'll return the index of this element. Basically I'll return I. And if I cannot find, I'll just simply return -1 in the end. Okay, so that sounds cool. So let's try and code this thing. Okay, so let's go back to our Visual Studio Code. Let me increase it a bit so you can see better. Alright, so exactly what did I just say? That we'll have two loops. I is equal to 0, I less than str dot length, right? And I'll have one more loop j, which will move from I plus 1, j less than str dot length, and j plus plus. All right. Okay. Now I can do two things here. Suppose if my stri is equal to strj at any point, what I'll do, I'll simply return I. Alright, and if it is not equal, I will simply return -1 in the end. Okay, that's what we learned. Now let's try and run this code. Let's see if it works. See, our output is first repeating character is G. Suppose our input string was this. Suppose I make it E B C D E. Let's try and run this. Okay, what is the problem here? Okay, we didn't save the code. Now let's try and run this. See, okay, this was when index was -1, right? Cool. Now let's talk about the time complexity. So we are having two nested loops here. Like first this loop, and inside it we have another loop. So we clearly know that in such cases we are going to have time complexity of auxiliary of O n square. N is the number of characters here. Okay. Now if I ask you how you will optimize this thing. Okay. So let me raise it a bit. So okay. Now let's talk how we can optimize this stuff. So if you remember in the last video, I told you about how we can use a character array to store the indexes, right? So what I can have is, suppose I have a character array of size 256 and all the elements stored are -1. Alright, like this. Okay, and what I'm going to do is I'm going to move from this element. Okay, and I'm going to say that if right, so suppose I retrieve value of, suppose, char g. I stored this value in some my element fi. Alright, so initially here what I'll get? I'll get fi as -1. Alright. And suppose if I come here now, my, like, we'll talk about this situation, but suppose here I come and I somehow stored the uh, value of index of g 0 in char g. Alright, so now here fi would be 0. Okay, so suppose I have output which will print as res. Okay, so res would be minimum of either res or current fi. Alright, cool. And suppose if fi is equal to -1, we'll store, that means we encountered this element for the first time and we'll store its index here. So if this is the case, we are going to store char of g as fi. Okay, cool. So let's do one thing. I think it is a bit complicated for you guys. So first of all, let's try and write a code. Okay, and then we'll have a dry run on our input string. This we'll have a dry run here. Okay, so let me erase all this stuff for now. Okay, okay. So remember a bit what I just told you, so we can write it. So I have a vector int char, and I told you how we store elements, like how we initialize it like this, right? So we have a character array called char, and all the elements currently are -1. Okay, now I'm going to have a loop. Okay, and I'm going to store index or element of my, like, the letter I encounter in character array, right? So int fi is going to be what? Int fi is going to be what exactly? Char, right, of sgri, right? Now I simply say if fi is equal to -1, char of stri is equal to fi, else res is equal to min of res plus fi. I didn't mention res here, so let's have res as int max initially. Okay, so we had this loop. Now I'll just simply say if res is equal to int max, that means I didn't find sorry, go to -1. Yeah, so this means I, like, the string didn't have any duplicate characters, so I'll just simply return -1. All right, so this would be int max only, right? Yeah, else
I'm going to return res. Alright, let's change it to geeks for geeks, and let's hope our answer comes out to be G. Okay, there is some problem here, I guess so. Guess we are having some trouble here. Let's see what are we doing wrong here. So we have interest as int max, and we have this thing. I just said int fi is equal to char of sri. Alright, we just said if fi is equal to -1, we just put char sri is equal to, okay, this is going to be I, right? This is going to be I. Now let's render this thing. Your first repeating character is G. So, okay, just take a screenshot of this code for now, and now we are just going to have a dry run of this code on the same string, and then you'll understand what we are exactly doing here. Alright, so okay, suppose I have a character array. I'm not writing the char as whole, I just understand it's -1, -1, and -1. Okay, res currently is int max, right? Okay, now I come at this point. All right, so now my fi is what? It is -1. Well, fi is basically what? Character of fi currently is what? C of G, but since this is the first element, all the elements are -1, so fi is -1. So according to our code, what is going to happen? If fi is equal to -1, G will just change character of stri as I, right? So that means C of G is now 0, right? Now I come to E, same thing happens. Now character of E is 1. Now I come here, and when I come here, our fi becomes 1. Alright, and we have seen that if fi is not equal to -1, which in our case here it is 1, so we'll have res as minimum of either res or fi. So now our res is going to change to 1, right? Now I hope you're getting what exactly is happening here. So similarly, this code is going, and at a point it will come here. Right, now our fi is going to be C of G. C of G is the, what is that? 0. Right, now we'll again see that if fi is not equal to -1, we are going to have res as minimum of either res or fi. So our fi is this, our res is this, which is the minimum? Fi, obviously. So we'll change res to 0. Alright, and we run I further, but obviously no number would be less than 0. So our output, meaning what our function is going to return is 0, and hence we are getting G. Alright. So this was a very important problem as asked in many interview questions, and plus you use the important algorithm which I teached you in our previous class. Alright. So I guess that's it for this video. We'll be looking at some of more problems in the upcoming videos, and thank you for watching. See you later. Hello everyone, and I welcome you all to another video of our string series. And in this video, we are going to look at another problem, and this problem is going to be really interesting, I would say, because in this lecture, we would be like basically dealing with two questions at once. All right. So the question is reverse words in a given string. So for this, you should be knowing about how to reverse a word if it is not given in a string. All right. And then we'll look at this problem. Okay. So what I am saying is, suppose there is a letter called, give me a minute. Yeah, cool. Okay. So the word is suppose word. Right. You have to reverse this specific word. What will I get? D, R, O, W. Yes. All right. So let's make a function. Let's call it void reverse. All right. We'll pass string like this. We're going to pass. I'm just writing for now, and I'll be explaining. Just give me a few minutes. All right. So here I'm just simply going to return reverse s comma low would be suppose 0, and I would be s dot length minus 1. All right. Now I am saying while low less than equal to high, we are going to swap s low and s high. All right. We're going to increase low plus plus and high minus minus. Okay. And let's have a custom string like word. Okay, let's compile and run. Let's see. It should work. Okay, my bad. If I say this as let's say string, all right. And what I do here is I return s. Now let's try and run this. Should work now. Okay, we just have to do our this word only, right? Let's try and compile this thing. Okay, cool. Our output is also DROW, right? That leave this expected output. This is something else. We'll talk about this later. All right. So our expected output is DROW, right? Which we needed. So this is a very basic reverse function. We did it in array 1 also. I hope you remember it, but I'll do a dry run for this so you can recall it. All right. So I'll just erase thing. Okay. So our low was here and our high was here. So what I say that we'll swap these two. So that will become D O R W. Alright, and I'll increase low here and high here. Alright, and I'll again swap. So this becomes this. My low becomes this and my high becomes this. And what was my terminating condition? It was while low is less than equal to high. So I reached this condition and I'll just return this thing. Alright, so that is DROW. Okay, cool. Now what I have to do here. is, okay, we'll have this reverse function so for later, and we are going to have a reverse word. All right. So let's now read the problem of this question. So it's like given a string S, reverse the string without reversing its individual words. Words are separated by dots. All right. So S is basically a sentence. All right. So suppose S is like I like this program very much. All right. And what would be the output of this? Much, very, program, just like I. So what we have to do exactly here is we have to reverse the string without reversing each word. Alright, so what does that mean? That our first word much would be the last word much in our string would be the first, and similarly very very, program, this, like, and I. Notice that no word has been reversed individually. Alright. So like, can you try to think about this solution? Okay, if you're not able to, then let me tell you. If you remember my array video of rotating an array left by d places, if you remember it, what we do in that scenario is, suppose, let me clear out a bit. Yeah, suppose my array is 1, 2, 3, 4, 5, and I have to reverse and I have to shift it by 2. So what I do is that if I have to like shift by 2, so I'll reverse this part, I'll reverse this part, and then I'll reverse the whole. Right. So this is the basic idea. So same idea we are going to apply here. So what I'm going to do here is that I'm going to uh, reverse every word individually, and then I'm going to reverse the whole string. All right. Okay. I hope that is like making sense to you. Okay. And well, let's try. Let's have a dry run first so you can understand what I'm like trying to do here. So, yeah. Suppose let's take a second string. It's small and would be easy to tell. So let's have it. It is like P Q R dot M N O. So what did I tell you is I'm going to reverse this thing first. Okay. So it is going to be R Q P. I'm going to reverse this part. O N M. Now I am going to reverse this whole string as 1. So it is going to be M N O dot P Q R. Okay. So this and this are equal, right? So this is what we have to do here. All right. So let's try and write our code. All right. So um, I'm going to have a variable called start and a variable called n, which is going to be s dot length. All right. Cool. Now I'm going to run a loop for int I is equal to 0. Let's call it end, so would be easy. End is equal to 0, end is equal to less than m, end plus plus. So this thing is going to run for my uh, the whole string at first. Okay, now I'm putting a condition that if at any point, okay, if at any point, if my si is equal to give me 1 minute, let's have it void. All right, and not return anything. You'll understand why I'm doing it, so just be chill. Okay, if I say if si is equal to my dot, that means I have like traversed my first sentence, first whole word. Okay, now what I'll do here, I'll simply reverse my, I'm simply going to reverse my whole string from start to end, right? And now I'm going to put my start as end plus 1. Okay, that is basically the whole thing. So what I'm going to do, what I'm exactly doing here is, see this. This was a code, suppose there is one more, RSG, right? So I encountered my first dot and my start was here. So I encountered my first dot here, right? So I'm just going to reverse this whole thing. This is going to be dot R and Q and P. Okay. Okay. I hope that is making sense here. And then again I'm going to swap this thing also. Similarly, I found the dot, I put the starting here and would be here, it was going to be ONM, right? And now see, when I reach here, I'll just complete my sentence. There's not going to be any dot here. So in the end, I have to do one more reverse from start to n minus 1. Okay. And now I'm simply going to reverse the whole thing. And f from 0 till n minus 1, right? So let's simply return s. Now see, let's see if it works. Well, I hope it works. Okay, my bad, it's ascend, right? Okay, I am not understanding. All right, all right, all right, all right. Yeah, it should be here only inside the function. Let's now compile and run. Let's hope this works. Okay, my output is not the one I'm expecting, right? Okay, let me just remove my reverse function. Okay, and I'm going to have the inbuilt reverse function. I guess that will work. If you know about the inbuilt reverse function, it's good. Otherwise, I'm going to tell you in a bit. Just give me a second. Let me see if there's some problem with the code or was there some problem with the reverse part. Alright, okay. So this is going to be s dot begin plus start, and this is going to be till s dot end, or you can write s dot begin plus end. Right, and this is going to be s dot begin, going to be s dot end, and we are simply returning s, right? So let's check if there could be any more problem. I hope so. There should be no problem as such. Okay, let's try and compile this code. Let's see if this works. Okay, I'm getting these. I bad. Oh, that is really a very silly mistake. Very sorry for that, guys. That was really a silly mistake. So our previous reverse function would also have worked, right? So if you're comfortable with that reverse function, you can use that. Otherwise, let me tell you what I'm doing here. So what happens in reverse function exactly is this is a inbuilt reverse function used for C++ STL. So string, as you know, is a C++ standard template library. So in that we put reverse and okay, let me code it like this. We put reverse. It is start end. That means from where do you have to start and from where do you have to end. So that means like if I'm given a string WRD, I'm going to start the reversal from W and end it till end like D. Alright. So that's what we did here. It is beginning from s dot begin plus start. Alright, and it is ending as plus begin dot plus end. And this too we did, and this is also the same thing. Alright. So let's try and submit it. Let's hope it works. Oh yeah, it's okay. Cool. So guys, yeah, this was the reverse word in a given string, and in this lecture you learned about two problems: how to reverse a word individually and how to reverse a whole sentence. All right, and I guess you learned something important today, and that was it for this video. More theories, more concepts coming in the upcoming videos. So stay tuned and thank you for watching. See you later. Hello everyone, and I welcome you all to another lecture of our string series. And in this video, we are going to look at another problem. And this problem state name is check if a string is a subsequence of other. All right. So before starting this question, like solving this question, we should know what is a subsequence. All right. Cool. So let's learn it by using an example. Okay. Or rather, let's read this part first. We'll have a better idea like what a subsequence is. So let's read it. Okay. So given two strings A and B, find A is a subsequence of B. Okay. So that's what we have to find. And now let's read the definition of a subsequence. So a subsequence is a sequence that can be derived from another sequence by deleting some elements without changing the order of the remaining elements. So that was a bit complex, I guess. So we'll understand it with the help of an example. So suppose this is our example. All right, let's write it here. It is a x y and the second one is YAD YADXCP. Okay. So see, our output is false. So I'll do one modification here so we can have the correct output. All right. Okay. Okay. So what does a subsequence means exactly here is, see, we have three letters here, AXY, and we have to find AXY here in, let's name it string 1, let's name it string 2. So to find the letters AXY in string 2, alright, the order should be same as AXY. We can have like elements between them, but the order here should be same. So see, we have A here, alright, we have X here, and we have Y here. Okay, So as you can see, we have elements in between these, but that doesn't matter. What matters here is that we are having the same frequency and or frequency meaning same order of the elements, like a x y, and here it is axy. All right, now you can see one thing. See, here it was axy, but here it is y a x. So a is not a subsequent, so v as y appears before a. All right, let's look at example 2 so you will understand it better. It is GKSREK. All right, so let's write it. GKSREK, and second string is geeks for geeks. All right, geeks for geeks. All right, now let's see if this substring is there here. See, we have GG, all right, and then we have K, okay, and then we have S as well. Then we have R here. Then we can have any of the E's here, and then we have K. All right. So we can see that all the letters G, K, S, R, E, K are present in our string 2, that is geeks for geeks, and the order which is here is also maintained here. Alright, we can see like there are many letters in between, like here we have 2, here we have 2, here we have 3 actually, and here we have 1, 2, here we have 2. Alright, so that is like, you're getting what I'm trying to say, right? So yeah, so this is like uh, so okay, so this is what it was there, and now we just simply have to find um, whether string A is a subsequence of B. So in my opinion, this question is easy. All right, the only catch here was understanding meaning of subsequence word. All right, as soon as you understand that, you can easily do the question. So what we can do here exactly is, I'm going to first of all write the code, okay, and then I will try to explain it. Okay, so let me write the code here. What I'm going to do in this code, I'll explain you side by side, and then overall explanation will be given in the end with the try run. Okay, let's have while I a dot length. Okay. So if I'm saying that if both the letters are same, I'll do what I'll do is I'll increment both the iterators. Okay. Otherwise, I'm going to iterate over j plus plus only because A is already like, what do I say? Because we have to find the letters of A. Right. So yeah. So cool. Now if I say if I is equal to a dot length, I'm going to return true, else I'm simply going to return false. Let's try and compile this. Let's see if it works. Okay, expected output is true. Just the EXY and ADX CPY. Let's try and submit this code. Let's see if it works. Oh yeah, test cases are all passing, so problem solved. Good. All right. So let's have a dry run exact. Like I guess you would have understood already what I'm doing here, but still, I'm going to tell you what we are doing exactly. So we have a, x, y, and another is y a dxcp, y a dxcp. All right, let's remove this one and let's have p here and y here. Okay, so currently my I is starting from here and my j is starting from here, right? I is 0 and j is 0. So what I'm doing is I'm comparing these two letters. Alright. If these two letters are same, I'm going to increment both of them. But if these two letters are not same, so I'm going to increment only j, because I need to find this one, right? So that's what I'm doing here. If both are equal, I'm incrementing. I'm going to increment both of them. Otherwise, I'm going to increment only a second string. So I incremented it here, and it's j here now. All right. Now our I and j elements are equal, so I'm going to increment I as well as j, right? J is going to be here. Cool. Now again I'm going to check whether d is like string 1's I and string 2j are not equal, so I'm going to increment only j. This is x, by the way. Yeah, j. Now I say string 1 I and string 2 j are equal, so I'm going to increment x. I'm going to increment j as well as I. So my j would come here and my I is going to come here. Again, both are not equal, going to increment it and reach here. J is reaching here, I is reaching here, and both are equal, so we increment both of them to somewhere here. Alright, and this is going to increment somewhere here. Now these are like at the end of the length part, so I have put this condition, so we'll obviously come out of the loop and our I is here. That means our I is equal to a dot length. So if I is equal to a dot length, we return true, else we return false. So this was the basic idea of this question. So you can see this question was very easy, but the only main catch here was understanding what is the subsequence, which I told you. So this question was pretty easy for you then, right? So I guess that was it for this video, and in the next video we are going to look at another problem of string series. So thank you for watching and see you later. Hello everyone, and I welcome all of you to another lecture of our string series. And in this video we are going to look at a medium lead code problem called longest substring without repeating characters. So the question name itself defines like what the problem statement would be, but still let's read it. So the problem statement goes like, given a string s, find the length of the longest substring without repeating characters. All right. So this is what we have to find. All right. Now let's look at examples and analyze, and I guess that would help us to get the answer correct. Okay, so all right, let's see. Hmm. So if I look at this problem, so what would be the longest substring without the repeating characters? It would be ABC 3, right? It can be BCA also. It has also like 3 unique characters. CAB also. This ABC. But this cannot because there are 2 B's, right? And we cannot have these 4 because A is there. So I guess you got the gist that what we have to do here. So let's look at example 2. So only this would be the
longest substring without repeating characters, because all are the repeating characters here. All right, let's look at this example. So we cannot have this one, right? We can have this one. We can have these three, right? WK cannot have these four because W is there. So answer is 3. So this question is a little bit tricky. If we talk about the efficient solution, which would go in big of n time. So how to do that? So if you want, you may pause the video for 2 minutes and ponder over it, and I'll tell you the uh, answer or the approach which we would be seeing here. Okay. Hmm. Let's erase our previous work. Okay. Now our string suppose is pw w k e w. Is that correct? All right. So that is correct. Now, how to solve this? So what I am trying to say here is we can do two things here. All right. So the first thing is that let's find the length at every word at which okay, let me give you an example so you would understand it better. Suppose I come at k. All right. So I have to tell the largest substring length which would end at k. Okay, without repeating characters. So let's analyze it with this example. So p is 1. All right. W is 2. This is 1. All right. And k is going to be wk2, wk3 is going to be 1 again. Hmm. So now here, can you tell me what I did? Let's name it SG. So this is the length of the largest substring which would end with this letter P. Since there's no any letter, so P would be there only, so it is 1. The largest substring would be PW, so here it is 2. Since here we have one more W, so here our W is going to be only 1, right? And here it is WK, alright, and at E it is WK E, and at W it is again 1, alright. So this is what we have to solve, alright. So what can we do here is see, if we encounter a new letter, we'll increase J. Suppose here our W was 1, here we encountered a new letter, so we increased J. Here we encountered a new letter, so we increased J. Alright. Now, if we have the same letter, then what are we going to do here? Suppose here we have this letter and this letter are same. So what we did here is we subtracted this index with this index. Its index was 2, its index was 1, so we got answer as 1. Right. Now how we got 1 here is this is 0, 1, 2, 3, 4, 5. Alright. One more thing, this would not be 1, this would be 3.
because we would be having kw, right? So yeah, 5 minus 2, 3 again. All right. So yeah, this is the case. All right. Now you are thinking, yeah, this is the correct explanation. Okay, so we are going to write the exact same code which I told you, but there would be a summation error here. We would be looking at it like why it is there. I would try to explain it to you. It is a very typical one, so just bear with me. All right. Also, I like came with this approach, but that specific test case was failing, so I had to make some modifications. But the basic code would be this only. All right. So now let's write the code. All right. Let's have int as s dot length. Let me, yeah. All right. We'll have answer as 0. $256, our standard one. We have j as 0. Now for int I is equal to 0, I less than n, I plus plus. If last index of si, that means we have encountered our character for the first time. So we'll just increase j, right? Else j is going to be I minus last index of, right? This is what we thought. And then res is going to be max of res comma j. And now last index of s of I becomes I. Now here we'll simply return res. Okay, let's compile this code. Here we are getting the accepted output. Let's see for all the examples. Again, it's accepted. Now let's try and submit this code. Yeah. So here we have a wrong output. This is what I was talking about. It is ABB here. All right. Let me clear it a bit. Cool. It's A, B, B, A. So our J exactly is what? Here it is 1. Here it is 2. Right. Here it is again 1. Yeah. And here it is supposed to be 2. Am I right? All right. But what will I get instead of this? 0, 1, 2, 3. So instead of uh, 2, I would be getting 3 here. All right. And that's why my output is wrong. So what, see, this would always happen. Like you come up with a code and it won't work. So what I thought of here is let's make j as minimum of j plus 1. All right. So it would become 2, or the same thing, I minus last index of s of I. All right. And this would satisfy all my conditions. So let's try and write this thing. Minimum of I minus last index of s of I. Or j plus 1. Now let's try and submit this code.
and we got a correct output. So this question was a little bit tricky, and another thing which I wanted you guys to understand is that you may come up with an approach and like your test cases would be passing, but at some point there would be some test case error. So you have to like basically modify a little bit of your code, not write another full code, right? Like when I came up with the solution, I came all right with the starting part, but when this problem was occurring, I also thought like I should like look at a solution or something so I can get it. But I came up like this far on this question, so why not modify it a little bit? So that's what I did here. All right. So yeah, I guess that was all for this question, and I guess we have done like plenty of questions in our string series, and we would be starting with another topic from the next video onwards. And but yeah, also if you want like more questions on string or any other data structures which we completed before, so you may like comment it in the comment section, and I'll surely bring one or two more questions on that topic specifically. All right. So thank you for watching and see you later. Hello everyone, and I welcome you all to our DSA series. And in this video, we are going to start a new topic. We are going to learn about a new data structure called stack. All right. So as we discussed before, data structures are basically structures used to store data like arrays and linked lists, which we have already covered. And in this video, we are going to learn about star data structure. All right. So okay, yeah. So a stack data structure is basically a linear data structure which follows the LIFO order. All right. So you might be wondering what is LIFO. So LIFO means last in, first out. All right, cool. So stack is basically a linear data structure that follows the LIFO order, which is last in, first out. All right. So what does this exact basically means is suppose this is my stack data structure container, and suppose there is data here like 0, 5, 10, 15. All right, 4 data, and the container from this side is closed. All right, closed. And you can only insert elements from here. All right, so what we did here is we basically inserted 0 first, then 5, then 10, then 15, and suppose here I insert 20 as well. All right, so every number that is inserted is inserting at the top. All right, so that means 0 was the first number which we inserted, then 5, then 10, then 15, then 20. All right, so consider this as a stack of plates which you see in canteens. Like this is plate 1, this is plate 2, this is plate 3, this is plate 4, this is plate 5. So we know that plate 5 is the last plate which was in kept here. All right, and if you go and if you want to pick a plate, you'll by common sense you'll pick the plate number 5, this one. You're not going to pick this plate, you're not going to pick this plate, you're going to pick the top plate. All right, because is that what basically common sense is, right? So what does that mean? The last in, that means the fifth plate was kept in the last, was taken out first. Okay, I'll again repeat what I said. The fifth plate was kept in last and is the first one to be taken out. All right. So the same thing goes with our data. So basically this is our container, right? And here we can insert elements. So 20 is the last element which was inserted. And if I have to remove any element from this stack here, so how can I do that? Uh, Only I can remove the top element because the bottom is closed, so I cannot do anything from here. So I can only remove the top element. Yeah, that's correct. Okay, cool. So that's what we mean by last in and first out. Okay, great. Now there are like some functions, basic operations which we do on stack. They are basically push, pop, top is empty. So push function inserts an element on the top of the stack. All right. Pop function removes the element which is on the top of the stack. The top element, the top function returns the value of the top element, and is empty tells whether the stack is empty or not. All right. Okay. Let me give you an example. Suppose this is my array. This is my data stack data structure. 5, 10. So how will I create this stack? So let me write a pseudocode so you'll understand like what is happening. We'll implement everything in later, but here I'm just writing a pseudocode. Suppose I made a stack s. All right. So I just simply s dot push 10 here. I'll do s dot push 20 here. All right. So this is what I did till now. Okay. That's what. Okay, cool. Now if I want to remove this element 10, what will I write? So I'll write s dot pop. It removes the top element. All right. And now if I write s dot top, what will I get? This one will clearly give me answer as 5 because this is the top element. All right. And okay. And if I write s dot pop again, and then I write s dot empty, is empty is basically used in Java, and s dot empty is used in C++. All right. So after this pop function, our 5 will also get removed from here, and we'll be left with the empty container. So if I write this function, this will return me true. All right. So this is what we do in stack data structure. All right. So I guess that much is clear with you. Cool. Now, let's quickly talk about what would be the time complexities of all these functions. So all these functions time complexity would be O of 1. That means they would take constant time to perform these functions. All right. Okay, cool. Now we'll talk about how to implement a stack. Okay. So we implement stack by two data structures. First is array. All right. And second is linked list. So in the next video, we'll be looking at how to implement a stack using an array. And in the further video, we would be talking about how to implement a stack using linked list. So this was the basic introduction of stack data structure. I hope this would be clear to you, right? And we'll be talking more about stack in the upcoming videos. And thank you for watching this video. See you later. Hello everyone, and I welcome you all to another video of our stack series. And in this video, we're going to learn about implementation of stack using
our array. All right. So before starting, let me give you a brief like what we did in our previous video. So basically, we learned about stack. All right. So yeah, yeah. So this is a stack. It basically follows the leaf order. Right. Right. So what is a leaf order? Leaf order is basically last in first out. That means you can see stack as a container with the bottom closed. So we put elements like first element, second element, third element. And if we have to take out an element from here, obviously we're going to take the third element out first. Right. So that means the last in, which was third, is taken out first out. Right. So this was all you need to know of a stack. All right. Now the thing is how to implement a stack using array. Right. So that's what we have to study. So I told you the basic functions of a stack are push, pop, is empty, size, and top. So push basically pushes the element in our stack, like first element, second element, third element. Pop basically pops the element, that means popping the top element. Is empty tells whether the stack is empty or not. Size tells the size of the stack, and top basically gives you the top of the element, top of a stack. All right. Now, without any delay, let's try and implement this code. Okay. So here we have our stack program. Let's include the header file. All right. Now let's write our stack function. So to create a stack, let me write struct my stack. All right. So this is basically going to be a structure. Here we are writing a vector which will implement our stack. You know, vector and arrays are same, and that's what we use in yeah, uh, that's what we use in our vector. All right. So we have like written vector int v. Now let's write our first function, which is going to be push. We are suppose we have to push x in our stack. So simply I'm going to write all right. That is all. Now if I have to write uh, int pop. Right, so int pop will basically return the top elements which you are taking out. Right, so int pop is going to be int res is equal to v dot back. All right, v dot pop back, and simply return res. All right, now suppose if I have to write int top, it is going to be return v dot um, back. Right. Now if I have to write about the size one, suppose I write int size, what I'm going to do, I'm simply returning v dot size. Alright. And now if I have to write about int going to be bool empty. So basically I'm going to write return v dot empty. Alright, so I already have discussed about the vector of functions like pushback, popback, vback, size, and empty. So I am guessing you guys must already know it. So see, if we like void push and write an element, it will simply push the element inside a stack using our vector. Similarly pop, similarly top, similarly size, and similarly pool empty. Now let's implement this thing. Let's write int main. Let's make our my stack variable s. We're going to call it s. So for now, let's push 5. Let's push 10. And let's push 20 in it. Alright. Now I'm going to have cout s dot pop. Let's write handle as well here. Now I'm going to write cout s dot size, and now I'm going to write cout s dot top, and then we can write cout s dot empty as well, and in the end you can return 0. Alright, let's try and run this code. Let's hope this works. Okay, so these are the outputs. Now let's have a dry run if the outputs are correct or not. So let's do one thing. Let's erase this part. Okay, and here let's make a new alright. So initially we are pushing 5, 10, and 20. So our first element in our stack is 5, right? And our top element is 10, and then the next element is 20. So here what I did was I called s dot pop, right? So what that will do, it will erase this element 20, which will take out the top element, and we will get the output as 20. Next you can have size, so we can see the size as 2, so size is going to be 2. Next it is s dot top, which means it will give you the top element correctly, so it is 10. Next is cout s dot empty, that means it will return a boolean value 0 or 1. So since we don't have an empty stack, so it will return 0, right? So this must be the output you should be getting, and let's check the output. It is 2210 0. 2210 0. Alright. So I guess this was all you have to like study about implementation of a stack using C++. Alright. And you should know about the nomenclatures, which is pop, top, push, right? So I guess that's it for this video, and in the next video we are going to learn about implementation of a stack using a linked list. All right, so thank you for watching this video, and see you later. Hello everyone, and I welcome you all to another video of our stack series. And in the previous video we learned about implementation of a stack using array. Alright, and in this video we are going to learn about implementation of a stack using a linked list. Alright, so I hope like you remember what is a stack. Stack is basically a data structure which follows the LIFO order, which is last in first out. Alright, and I also hope you remember what is a linked list. So linked list is basically a data structure which contains nodes, and every node contains two things: data and address of the node it is pointing to. Alright, so this is the basic stuff, you should be knowing it. Okay, so we have to like implement stack using a linked list, and here are the functions which we have to implement. So we have to implement the push function, we have to implement the pop function, we have to implement the isEmpty, size, and top. So we know what is a push function. It pushes a value inside a stack. Pop removes the top element. IsEmpty tells us whether the stack is empty or not. Size tells the size of the stack, and top gives us the top element of the stack. All right. So suppose my stack contains 5, 10, and 15. All right. So my linked list, which is implementing the stack, should look like this. All right. Yes. Now, if I say, if you remember in our linked list, we always have the head pointer with us. So if I say I have to add an element here, suppose if I have to add 20. Suppose if I have to add 20. So what I'm going to do, I have to like traverse this linked list till the end, and then I'll add 20 here. So the traversal will take big O of n time, right? But I already told you that we have to do all these functions in big O of 1 time. So a better solution would be to make our stack look like this. Just give me a minute. Alright, 15, 10, and 5, right? So if I have to add an element here, we'll like suppose I have to add 20. So I'll simply create a node of 20. 20 is going to point here, and then head will point here. All right. And similarly, if I have to like remove this 15, what I'll do, I'll simply increment the head here. So all this is going to take big of 1 time. So we have to like add every element, new element at the head in the beginning of the linked list. All right. So now without any delay, let's try and code this, and after that we'll do a dry run. Let me increase the size a bit. Okay. Let's include our header file. My bad, 1 minute. Alright. So if you remember, we have to make a structure of our linked list. So let's make the structure of our linked list. Right, it is going to contain data, and it is going to contain a next node. Alright, and if I say node index, data is going to be x, and next is going to be null. Alright. So this is the basic linked list creation code, which we have already discussed in the linked list series. So I'm not going deep into this thing. Now let's write our my stack, which is our stack structure. All right. So let's have the head here, and let's have the size, which will contain the size, and let's make the constructor for it. Initially size is going to be 0 and head is going to be null in our constructor. All right. Now let's write a push function. So suppose I have to write a push function. It is int x. So I'll make a node star temp is equal to new node x. All right. Now I have to insert this in the beginning. So what I'll do, I'll simply do temp next is equal to head, and head is equal to temp. All right, and I'm going to increase the size. Now what I'm going to do is I'm going to write the int pop function, which will pop the top element and will give us what is the top element. Okay, so what we can do is, if head is equal to null, that means there's no element, so we don't have anything to pop out, so we'll just write cout empty. All right, and what we can do is we'll have int res, which will contain the head data. All right, and I'm going to have node star temp equal to head. All right, and I'm just going to do head as head next, and then I'll simply delete our temp. That makes sense. I'll decrement the size and I'll simply return our res. All right. Now if I have to write int top, it is going to give me the value of the top element of a stack. Our top element would be basically the value stored in our head of a linked list, right? So I'll just simply do return head data. Cool. Now if I write about int size, so it will simply be return size. Alright, and if I have to write the function bool empty, so if what I'll do, I'll simply return head is equal to null. Cool. So I have written all the functions: void push, int pop, int top, int size, and bool empty. Okay. Now I'll write int main, and here what I'm going to do is simply make my stack object s. Alright, and simply I'm going to push 5. Let me close this thing so we'll have more space here. Alright, then I'm going to push 10, then I'm going to push 20. Okay, now I'll simply write cout s dot pop endl. I'm going to write cout s dot size. All right, and I'm going to write s dot top and I'm going to simply write s dot empty. Okay, let's try and run this code. Okay, so our answer is 2010, 20 to 10 0. Now let's have a dry run to see whether what we got is right or not. Okay, so here we have our okay. Okay, I cannot make the right line straight. Um, Give me one more time and okay, this would work. So if I see here in my stack, currently my according to my constructor, my head is going to be null and size is going to be 0. Alright, so size is what? 0 and head is equal to null. Alright, now what I am going to do is I am doing s dot push as 5. Alright, so if I write my linked list, it would look something like this, pointing to null. And here I'll have an element 5. Now what will happen? I'm going to push 10. So 10 would come here, right? And I'll push 10 here. And this is going to be my head. Now what will happen? I'm going to push 20 here. So I'm going to push 20. And 20 will come here. And head will point towards here. And size would become 3. For every insertion, our size is also going to increment. So we increment as we inserted 3 times, so our size would increment by 3. Okay, cool. Now I'm doing s dot pop. So in pop, what we are doing exactly, we are returning the top element or head in our linked list and deleting the head. So that means we should get the output as 20. Okay, removing this element from here, making this as our head and decrementing size by 1, so size would become 2. Cool. Now what we have here is we have to return the size, so we'll simply return the this as z, so we'll get 2. Then we have to tell the top element basically is going to be top element here, which is going to be head, this one, so we'll get 10 here. And next is whether it is empty or not. So our stack would be empty when our head is going to point towards null, so our head is not pointing towards null, so we'll get the output as 0. So we should get this as our output. To cross check, let's see. Okay, what is the problem here? Twenty-two ten zero, the same output. Alright, so I guess that was it for this video where we implemented a stack using our linked list. So we have learned about implementing a stack using array as well as our linked list, and in the next video we are going to talk about C++ STL, which is standard template libraries. It has its own stack class and related functions, so we'll talk about it in the next video. So thank you for watching this video, and if you have any doubt regarding it, you can put it in the comment section. So thank you and see you later. Hello everyone, and I welcome you all to another lecture of our stack series. And in the previous couple of videos, we learned about implementation of a stack using array and linked list. All right, and there we learned how to make a structure of a stack and how to implement these functions: push, pop, empty, size, and top. All right, and um, if talking about this video, what we are going to learn in this video. So in this video we are going to learn about implementation of stack using inbuilt STL C++ class. STL, as you know, stands for standard template library. So that means that C++ has already been occupied with a stack class which we can use rather than creating our own structure of stack. All right. So before diving into that, let's first talk about the applications of stack. You must be wondering why are we learning about this stack structure? Like what is the use of it? So the first use is कि stack can be used to check for the balancing of parentheses in an expression. Alright. Suppose if you have been given a code and you write something this and then this. So this must check that this has been opened last, so this must be closed first. This is the first one, so this must be closed in the end. So this is a basic parenthesis question, and we'll learn about it and we'll see more of it in a separate video. Alright, and other than that, we can see that redo undo features are at many places such as editors, photoshops. You have like seen in many editors like Microsoft Word or Adobe Photoshop that we can redo and undo in them, right? So that feature requires stack and forward and backward features in web browsers. So while browsing in a web browser, so like you have to come back to the previous page, so you click this icon, right, and then if you have to do something like if you have to go forward, you then click the forward icon. So that thing also uses the stack data structure. All right, now let's talk about the implementation using C++ STL. All right, so let's try and write a code. All right, so to create a STL stack, what we do is we write stack type of data structure in it. Suppose for now it is int and its name. So s is the name. All right. So if I have to push something in it, what I simply do, I simply write s dot push and the value. Similarly, all right. So what we did exactly here is we made a stack with values like this: 30, 20, 10. All right. So this is what we did till now. All right. Now suppose I write cout s dot size, then I write cout s dot top, and now if I do s dot pop, now I write cout s dot top, now suppose I push something in it like 0, and then I do cout s dot top. Alright, and now I'll do cout s dot empty. I guess that this much code is enough to help you understand the stack STL functions. All right. So we talked about the push one, right? Now I did s dot size. So s dot size basically returns the size of this. So currently size is 3. So we should get the output as 3. Then we wrote cout s dot top. S dot top should return the top value of our stack, which is right now 30. All right, and then we pop this element. S dot pop basically removes the top element. It is a non-returnable function, so it just removes the top element. Okay, so just this. After this, we again write s dot top. That means we'll get the output as 20. And after that, we push 0 in it, s dot push. So we'll get the output as 0. We did s dot top, and then we did cout s dot empty, which will return either the stack is empty or not. All right. So let's try and run this code. Let's see if our output and the terminal's output is same or not. Okay. We got 3, 20, 0 and 0. Let's change it to 5 so you can get the idea of the 0 one why 0 is coming. Okay, 3, 30, 25 and 0. 320 and okay, wait. What we did exactly. Alright. So we're getting the same output 3, 30, 25 and 0. This basically returns 1 if the stack is empty, otherwise 0. So our stack is clearly not empty here, so we'll get an output as 0. Alright. So these are all the functions of our stack C++ STL library. Alright. So we don't have to like explicitly create a structure for a stack, rather than we can use the inbuilt stack class, which can be used like this. Alright. So I guess that was it for this video. I hope you learned how to use the STL C++ stack class, and also I hope you learned about the applications of stack. And in the upcoming videos, you'll be looking at some of the questions based on stack, so you'll understand the concept better. So thank you for watching this video. If you have any doubt regarding this lecture, please put down in the comment section. See you later. Hello everyone, and I welcome you all to another video of our stack series. So in previous of videos, we learned about stack, implementation of stack using C++ and linked list, and then we saw the inbuilt stack function of STL class. All right. So now it's time to do few questions. So the first question which we are going to do is valid parentheses. So this is one of the like most fundamental question of stack. All right. So let's dive into the question. So given a string S containing just the characters, which is like small bracket opening, small bracket closing, curly bracket opening, curly bracket closing, square bracket opening and square bracket closing, determine if the input string is valid or not. Alright, so an input string is valid only if open brackets must be closed by the same type of brackets and open brackets must be closed in the correct order. So let's talk about the correct order first. What is the correct order? Suppose I have just them. Alright, these are my brackets. And what would be the closing sequence? First, this bracket would close, and this bracket would close, and then this bracket would close. Alright. So, just by a mere observation, you can see the last bracket which we used is going to be closed first. Alright. I'm going to repeat my statement. The last bracket inserted, opening bracket inserted, is going to be closed first. Doesn't it sound like stack? The last in, first out. Right.
Suppose if I take a stack and I input my opening brackets, and if I come across a closing bracket, it should be corresponding to the top one. Right. So this is what we have to do. All right. So there are a few conditions. So let's talk about the conditions. If you know that if you come across a closing bracket and if you check if this is the corresponding bracket of it or not, if it is, we'll continue. Otherwise, we'll return false. That is the first thing. Another thing could be that suppose this thing is empty here, right? And still we come across a bracket, then also this would be like false. All right. And suppose we just iterated over the string and we still have some elements in the bracket like this element or this element. That means these don't have the closing brackets, hence the answer here would also be false. So keeping everything in mind, try to write down the code on your own. The link is given in the description of this question. So try to write down the question on your own. Otherwise, I'm going to solve it. Okay. Let's try and write the code. First, obviously, we are going to have a stack of char sg. Alright. Now what we are going to do, for int I is equal to 0 is dot length I plus plus. So what does this mean? We are iterating over the whole string length. So if I say if si is equal to this, or si is equal to this, si is equal to which bracket is left? Alright, small bracket. This. Then we are simply going to push SIN. That means we're going to push the opening ones, right? Otherwise, suppose if our stack is empty, we'll return false. Otherwise, what we are going to do, if is matching, that is stack dot top comma si. So is matching is basically a function which will see if the opening bracket and closing bracket are corresponding. We'll make this as matching function, but for now let's let you understand that this is what is matching to here. Okay, cool. Then we are simply going to v dot pop. Otherwise, simply we are going to return false. In the end, we'll return. Okay, in the end, we'll return. This is okay. I made some errors. This is, yeah, this is making more sense. Cool. So if I am saying if, what is going to happen here? I'm saying if st.empty return true, else return false. Cool. Let's try and run this code. Okay, 1 minute. I didn't make the is matching function. Right, that is our error. Let's make our is matching function. So here I'm going to have carry and char b. I'm simply going to return if a is equal to this and b is equal to this, or a is equal to this and b is equal to this, or
A is equal to which bracket is left? Alright. And B is equal to this. Alright. Cool. That means if A and B are this, we'll return true. If A and B are this, we'll return true. If A is this and B is this, we'll simply returning true. Okay. Now let's try and run this code. Hopefully it should work. Right. Okay, we are getting the test case as accepted. Now let's try and submit this code. Okay, we got the correct output and our runtime is 0 milliseconds. Cool. So this was, the one of the most fundamental questions, because even in these, when you like iterate to the question, you understand that the last opening bracket should be closed first. This statement, like, you should inculcate that we have to use stack here. Okay. So I guess that was all for this video. If you have any doubts regarding this video, you may ask in the comment section. And in the further videos, we're going to do some more questions on our stack. So thank you for watching. See you later.